Hello, everyone, and welcome to JetBrains NET Days Online 2021. I'm Martin, and with me is Matthias, one of our developer advocates as well. Hey, Matthias.
Hey, everyone.
How are you doing? Nervous?
I'm great. I'm just really excited. Yeah,
it's
very nice lineup. I think we have put there.
Absolutely, totally agree. So, what should we do? How do we start? Let's maybe add our screen first and explain a little bit about what's going to happen today and in the next couple of days. Well, next couple of days, today and tomorrow. It's a free virtual event focused on .NET, and we'll have people from the community talk about the topics that they are passionate about. So we have a couple of speakers talking about deep technical things, some folks showing more frameworky kind of things. So you will definitely enjoy those. Before we dive into the agenda, maybe a quick note about last year's events, because this is the third year that we are holding the .NET Days Online 2021. Well, 2021 is this year, obviously. Last year we had 2 days as well with lots of sessions. And if you search on Google or Bing or whatever your favorite search engine is, you will find recordings of that event. I think this year we have Tess again, and we also have Khalid hosting one of the later sessions today.
And we also have Michael again, right?
Sorry? Oh, yeah, and we have Michael again as well. Yep. Long agenda, long agenda. So yeah, definitely have a look at the previous events. There's good recordings there, really good sessions that are still relevant this year. But obviously, also this year, we have more events. So let's have a look at the agenda there. By the way, if you are watching, this is on YouTube and you have the URL in your browser. If at any point during this session or during the day you have to go or you want to rejoin for another session, just hit the same URL again. It's the same URL where you can find the recordings as well. So you can always pop out and pop in again whenever you need. Matthias, are you watching questions already?
I'm watching questions. Well, I'm following the chat, and everyone is saying hi from all around the world, which is really great to see.
I see a lot of people are up really, really early, so that's even cooler.
Yeah, or still awake, like I am most of the time. I'm still not sure what time zone I'm currently in. So
this is like Central European time. Central European time.
Yeah, something like that.
So yeah, most people have found the chat apparently. So that's also the place where you can ask questions for the speakers. So during the sessions, Matthias and myself will be monitoring what is going on in the chats, try to respond or give links to any resources that we have, but we'll also try to keep a couple of questions for the current presenter. So when that person is presenting or finishes presenting, we can always, ask those questions and see if they can be answered on screen. So, shall we go through the agenda a little bit and see what's going to happen?
That would be nice, today? I think. Let's introduce a couple, at least in picture mode, and briefly have the title of the sessions. I think it's really great, and there's something for me definitely in there, something that sometimes I already know and I want to deep dive more into it. Or sometimes even things that I'm kind of have on my list of things I want to check out, right?
I think all of those things are things I want to check out, actually.
Can you make it a bit bigger, maybe? I mean, maybe my is a bit small.
I think I can. Yes, there we are.
Yeah, that's better.
Right. So yeah, today we'll invite Andrey in a little bit to talk about C# source generators, which I'm personally really looking forward to because it's going to be one of the first time that I see a lot of things in action. We'll then have Tess with debugging.NET applications, and really Tess is really deep dive into debugging and profiling techniques and strategies and so on. So I'm really looking forward to that one as well. Then we will have Steve Gordon, who will be talking about writing high-performance C# and .NET codes. which is also going to be really interesting. Actually, all of the sessions in the agenda are going to be really good. This afternoon we'll have, this afternoon Central European time, of course. We are going real time using CosmosDB and React. So not a lot of .NET, I think. Maybe yes, maybe no, we'll see. I see Signal are in there as well, so maybe some .NETs. Then gRPC, one of those topics that I should look into at some point when I manage to go through the to-do lists. Have you been playing with that, Matthias?
Sorry, say again. I just had to cough.
Have you been playing with gRPC before?
Not yet. You know, it's I'm not sure if I'm the only one, but I'm seeing all those talks every now and then and updates on it, and it's a bit like everywhere, but I haven't really followed up on it. So I definitely will do this. Just now, it will be part of my job even.
Yeah.
So that's cool.
Cool. Yeah, we will get a free 1-hour introduction to the topic. Yeah, we'll also have GraphQL, which is definitely going to be interesting as well. It's different from gRPC, I think, but I guess we'll see during the day. And then we'll end with NoSQL. I thought we were ending with SQL, but it's NoSQL. And that's a stupid joke.
I laughed. I totally laughed.
That's cool. Thank you for the support there. We'll have tomorrow as well, but we'll introduce those talks tomorrow. But if you're here for the 2 days, then awesome. We would love to have you tomorrow again, because we have more interesting sessions and interesting people on the agenda. Before we dive into the actual events, I also want to thank our community partners that we have. .NET Foundation has been doing a lot of promotion and spreading the word about this event. A lot of user groups and other communities around the globe have been also pinging their members about this event and that the event exists and so on. So thank you, people, for doing that. Also, thank you for attending today. And I also want to, in advance, thank all of the speakers who are joining us for the remainder of the day and tomorrow, because without you, we could not pull off this event. Is there anything you want to add, Matthias?
Basically just the same, and you just triggered my Alexa HomePod, which is weird because because you didn't say Siri, right? But yeah, no, I'm just really glad about all the support that we also have from our community partners, particularly also with the speakers. It's like really great. I'm looking forward to like every session that we will have, and yeah, I just think it will be 2 really cool days. Getting insights and leaving your questions, everything that you have, and yeah, I'm really looking forward to that.
Same thing. By the way, maybe one more practical thing. So you will see all of the JetBrains .NET developer advocates on stream as well. So Matthias and I are kicking this day off, but we'll have Matt there. We will have Rachel and we'll have Khalid on. So you'll see our Twitter handles on there as well. So if you want to follow us on Twitter, you can always do that. And as usual, as it goes with streams on YouTube, if you like this event, give us a thumbs up. And if you want to have more information later on, do feel free to subscribe to JetBrains TV. To make sure that you can join next year, right? Absolutely. Not to miss the news. Yeah. Also, we have regular webinars each month. So it's like one session that we have today, but then every month we have 1 or 2 of those that you can also attend. Less long of a day. It's not a real event with 8 sessions in a row, but still we have those people from the community bringing their content that they want to share with you. Yeah, which is probably worth also noting. I mean, we had a lot of submissions. We couldn't get everyone in there, of course. I mean, it's probably obvious, but we will also have some of those that we couldn't have here in regular webinars, which I'm looking forward to as well. Same thing. All right, then I am going to stop sharing my screen because I think we've covered the introduction here, and let's bring in Andrey, our first speaker. There we go. Hey, Andrey.
Hello, Andrey.
How's it going?
Fine, thanks.
You have the honor of kicking off the event as a speaker.
I think that's because of source generators. They seem to be a hot topic right now.
Absolutely, yeah. I think everyone wants to see source generators in action.
Yeah, me too. Definitely.
So, let's start then.
Yeah, let's bring your screen on and let's maybe start this first session, because I think you were mentioning that you require close to 1 hour. So let's maybe bring up the screen, start the session a little bit early, and make sure that we have some time for questions, which I think people will have in the end.
Thank you. Okay, so I'm Andrey. I'm working as software engineer at JetBrains, mostly working on C# features for ReSharper and Rider. Lately, I've been working on nullable reference types and source generators support in ReSharper. And I've been very interested in metaprogramming for quite some years now. And because of that, when source generators became available, I was very curious where do they fit among existing tools, what are their pros and cons, and when I should use them. So in this session, I'll briefly introduce source generators to you. There will be 2 live demo sessions. In the first one, I'll focus on quickly building a simple yet useful source generator from scratch. And after that, I'll compare source generators with other metaprogramming tools we have available today. And in the second demo, I'll focus on some advanced scenarios and best practices when using source generators. But first, let's discuss why we need source generators and what problems are going to be solved by them. And first and foremost, it's generating boilerplate code. So if you have some standard implementation of equality members or toString methods in lots of types in your solution, instead of coding them yourself, you can simply delegate this work to a source generator, and in this case, you won't even have to update them every time you add or remove some members to the containing type. Of course, they can also be used to do type generation from schemas, to do some object mapping code, to produce code for object materialization from some service. And because we can generate boilerplate code easily now, we can also have some performance optimizations. For example, we can get rid of reflection in serialization, can register types for dependency injection without reflection. I'll get back to it in a bit later. And first, let's start with a simple example that is likely familiar to most people. It's an interface called iNotify property changed. It has a single event notifying its listeners that some property of an object has changed and perhaps it needs to be updated on the user interface or some other logic should take place. And because it's just a single event, it's really easy to implement in any type, for example, a car model with a speed property. But now we have a problem because this auto property doesn't fire any notifications about its changes. So instead, I'll have to write it as a regular property with the backing fields, and in its setter, I'll fire the notification. And that's already a lot of code. And what's even worse, every time I'll need to change something, for example, the name of this property and its type, I'll have to update almost every single line in this code. And it's a lot of places. What we can do here, we can only leave backing fields in our model and generate notification properties with a source generator, because they all follow exactly the same pattern. And I'll show you how it looks like with and without source generators. So you might notice that there is a lot less code with source generators. And this code won't grow very fast when you add new properties, for example, a model name for this car or its number of doors. So when at some point you'll add some business logic, for example, an acceleration method that will increase the speed of this car by 10%, you'll still be able to see what this type is about, what members are available there, and you won't have to scroll multiple screens of boilerplate. So what are source generators? As I mentioned before, it's a new metaprogramming tool from Microsoft. Basically, you are going to write a type that will be a part of the compilation process. It can access a model of your code and generate new files based on it. So ROSM begins compilation of your project. It reaches some source generator step of compilation. It transfers control to your type along with everything it knows about the target project. And based on this information, you can generate new source code that will be added as an input to compilation, and it will resume as if these files were there forever. So let's get to the first demo. And I have a website called SourceGenDev, where you can upload a bunch of examples provided by Microsoft. And one of them is actually implementing the notify property changed interface. And here we have the actual source code for our program. There is an example view model type with a bunch of backend fields and an auto-notify attribute. There is a program that simply subscribes to the property changed event and changes a couple of properties to verify that everything works and we are getting the notifications. And we can check what was added to this program by source generator. It's the auto-notify attribute and a partial declaration of our example view model type. So it's essentially a part of this type that implements the notify property changed interface and adds the property changed event and the properties that fire the notifications. And on the top right, you can see the actual source code for this generator. But it might seem that there is a lot of code, and in order to work with this, you have to be familiar with Roslyn API, how the compiler builds its syntax trees, what types are available, because if you check it for the first time, you'll see a lot of types you probably don't know, such as isyntax receiver, attribute data typed constant. You'll see some safecast to C# compilation, C# parse options, add syntax trees, C# syntax tree parse text, source text from. And what to do if you don't know all these types? It might seem that you have to be familiar with Roslyn API to start working with them. And in my first demo, I want to show you that everything you need to know is about 3 methods total, and everything else will be easy to find with code completion and derived type search. So here I have a car model type with 3 backend fields. I've demonstrated on one of the previous slides an acceleration method and a lot of boilerplate implementing the property changed notifications for these backend fields. And this program simply subscribes to its property changed event and fires a couple of notifications to verify that I'm getting notifications for model name changes, for number of doors property changed, for speed property changed. And let's remove all this boilerplate with the help from source generators. I'll need a new project where I'll declare my generator. It has to be a new .NET Standard 2.0 library. Because this assembly will be loaded in the Visual Studio process. You cannot use anything fancy such as .NET Core 5, and it has to be .NET Standard 2.0, don't forget that. And I'll need a couple of packages in order to work with the compiler API. I won't focus on this now, but you'll be able to find source code for this demo on my GitHub. And you'll also be able to check these packages in any example focusing on source generators. For a source generator, I need to declare a type that will implement iSource generator interface. And it has to be annotated with a generator attribute. The interface itself contains just 2 methods, initialize. They won't need it there yet. I'll get back to it in the second demo. And execute where the magic happens. And here you have access to context compilation, which is basically everything the compiler knows about the target project. For example, you can access any types that are available in the target project with get type by metadata name. For example, here I'm interested in system component model. I notify property changed interface, since I'm going to implement it in a couple of types. Notify interface, and you have access to compilation syntax trees. Essentially, one syntax tree is one file in the target project. So for each file, as with any tree, you can access its root, and you can check descendant nodes themselves. And since I'm going to work with type declarations, I'm only interested in class declaration syntax elements. And here you might want to stop me and ask, okay, how we should know that this type even exists if we are not familiar with how Roslyn works? And there are 2 methods you can use. First, you can check what descendant nodes and self return to you. And it's a collection of syntax node element. You can check derived types from it. And these are every syntax element available in C# language. Usually they have quite descriptive names, so you won't have any problems if you search, for example, for record. And there is a record declaration syntax if you want to extend records only. If you want to do something with interfaces, there is an interface declaration syntax. With class, there is a bunch of types. The first one is class declaration syntax, which is exactly what we need. But what if you don't know how to name some method? For example, a method call. How would you name this element? If you cannot guess the name of the syntax element you need, you have another website that can help you. It's called SharpLab. You can switch it to syntax tree mode and type any code there you are interested in, for example, console write line, and you'll be able to see that console write line is an invocation expression with a simple member access expression qualifier and an empty argument list. So if you are not sure what syntax elements are produced by the compiler, you can simply put your code on SharpLab and check the generated syntax tree. So let's get back to our example. And syntax elements is essentially what is written in the code editor. So there is a class keyword, there is some name identifier. And what we need is semantics. What members are available in this type, what interfaces does it implement, what attributes are there. And to move from syntax to semantics, you can use compilation, get semantic model from this syntax tree. It's a variable for that. And you can move to semantics with semantic model, get declared symbol from this syntax declaration. And these are the three methods you really need to know. Semantic model, get declared symbol, compilation, get semantic model, and compilation, get type by metadata name. So everything else you'll be able to find with code completion. For example, since I'm working with types here, I'm interested in type symbols. And I'm interested only in types that already implement my notify property changed interface. So there is an interfaces property. And I can check that one of them is my notify property changed interface. I can put them in a hash set. And this will be the types I'm going to extend. So let's name them target types. And for each such a type, I'm going to provide declarations that will implement this interface. So target types for each. I'm going to provide source code, generate property changed for this target type. You don't have to provide any compiler structures. You need to provide a simple string as with code in the editor. So here I'm going to use string interpolation. I'll declare it using system component model here to use the notify property changed interface. And the namespace that will be the same as containing namespace of my partial type I'm going to extend. There will be a partial class with the same name as the type I'm extending. So it's essentially a part of the same type. And since I'm going to implement the notify property changed interface, I can also move the property changed event itself in the generated part. So let's simply copy it. It's easy to do because we're working with simple strings. And I'll need to provide properties that will fire these notifications. So generate properties for this target type. And here I don't know yet how many properties there will be. So I'll need a string builder. And I'll need to check what members are available in the target type. Code completion is your friend here. You can type members, and there is a get members method. I'm interested in fields only, so I can type field, and there is an iField symbol, which is exactly what I need. And I won't rely on any fancy attribute-based configuration here. So instead, I'll rely on simple naming convention. If something is, name it with a field suffix, I'm going to provide a property that will fire notification when I'll update its value. So let's check that the name of this backend field ends with my backend field suffix. And for each such a field, I'm going to generate a property with a name that will be the same as the backend field name, except for the suffix length. So without the backend field suffix, that's C#8 feature. Sorry. And now I have to provide the actual property implementation. Apparently my Visual Studio is lagging, don't worry. And builder append line. And again, I can use one of the properties I declare in my actual program to use it as a template for what I'm going to provide. Simply paste it here, escape the curly braces. and update it because it's not always a string property. I need to use field symbol type as a return type for this property. I need the name I've just calculated. I'll return backing field from its getter. I'll update my field symbol, the setter, and I'll fire the notification for the property name. So I have to return the string builder. And now I have left is to add this source code to my actual target project, this context add source. I'll need to provide a name for this file, for example, the same as the target type name with notify CEST suffix, and provide the source code. Now let's add this generator to our main program. And I'll also have to tell the compilers that it's not a regular reference. I'm not going to use types provided by it. And it's actually an analyzer, so it will do something with my code. So its output item type is analyzer. And if I did everything correct and didn't make any typos, I can now simply remove all this boilerplate from my type, mark it as partial, and run this program again. Everything should work. Let's check it. Yeah, everything works, everything compiles. I'm still getting notifications whenever I change any properties, for example, the model name, the number of doors, the speed property. And the only problem you might have noticed is that my code editor looks a bit broken. There is a lot of red code. And that happens because Roslyn, which is the underlying engine that powers Visual Studio, will only update generator references once you open a solution. And when I opened this solution, there was no source generator. So I have to close it and open it again. If you are not using ResSharper, you'll have to fully restart your IDE here. Don't worry, you don't have to do this every time you change something in your code editor and need to restart the generator. This is only required if you change the generator itself. And if this is a problem for you, for example, if you want to develop some code and get immediate feedback on every time you change something in the generator, you can switch to JetBrains Rider, which supports hot reload for source generators. And now everything works. So let me show you that you don't have to restart your IDE every time you change something. So you can add a new double property, weight of this car, backing field. And as soon as you add this property, you can see it in code completion. You will be able to get notifications for it. It will simply work as soon as you've added the backing field. And now you might have a couple of questions about the generated code, because right now there is some code in the car model type that we don't see, and how we can check it and check that everything works properly, how we can debug it if there is some problem. And these errors are usually quite hard for metaprogramming tools because you not always have the source code available. And since Visual Studio 16.9, you can simply find the reference to this generator in your Solution Explorer, and there will be a list of files generated from this generator. But in large projects, it might not be convenient because there will be a lot of files that will not be grouped. So instead, I suggest you to work with this generated code as if it was your own code. So I can navigate to a car model type, and I'll see that there are two parts of it, one in my main program and one in the generator folder. I can navigate to this type. There will be the 4 properties I've declared. I will be able to check the source code for them. And I'll be able to set a breakpoint here and simply debug this code without any problems the next time I'll run this application. Let's check it. And yep, I can check what value I've assigned to the backing field, and I can debug this code as my own. And another interesting question is, okay, how can we test the generation process itself? And for this, you can ask the compiler to compile some arbitrary source and run some generators over it. I have a project prepared for this in advance. You can check exactly how it works on my GitHub after the talk. There will be a link. So I simply provide some source code. I'll create compilation from it. The code is a bit cumbersome, so let's not focus on it. I checked on my GitHub if you want to test your source generators. And then I can run my generator over this code and check that the returned compilation has some syntax trees that include my notify.cs file. And I can check its source code. I will be able to check that my index backing field has resulted in a new property that fires the notifications, and the regular field that doesn't follow my naming convention wasn't processed at all. And of course, in this case, you'll be able to set a breakpoint in the generator and hit it when you run this test. But what if something is wrong in production, but not in our test code? And because our tests are fine, we don't know what the problem is. How can we debug it? And for this, you can add a line debugger launch to your generator. And the next time you'll compile your project, it will be prompted to attach a debugger. For example, you can choose the same Visual Studio instance and let it debug its own build process. So let's try it and see how it's different from our test run. For example, you'll be able to see that in a real project, there is not one file, but 3, and only one of them is my program CS, and 2 others are auto-generated files with some assembly-wide attributes. Don't forget to remove this line after you finish debugging the problem, because as I mentioned before, Roslyn will only update generator references once you open a solution. So if this line is in the compiled assembly, the moment you open your solution, you'll be prompted to attach a debugger every time you change something in your code editor, which is quite a lot. So don't forget to remove this line and fix the behavior in test. And before we'll go to the next section, I want to mention a couple of things I've overlooked for the sake of simplicity in this generator, and you might want to handle them in the actual generator. For example, here I've only used class declaration syntax. There is a new C#9 feature called records. You might want to support them as well. For this, you'll also have to update this keyword to record. You might want to check that containing namespace is not the global namespace for the assembly, in which case it will be empty and this code won't compile. You might want to check that this class is nested in some other type, in which case you'll have to declare a containing declaration as well. And you might also want to check whether the interface is implemented directly or is inherited from some base type. That's the difference between interfaces and all interfaces. The same with breaking fields. You might want to check whether they're declared in your own type or they're inherited from some base type. These checks are relatively straightforward, so I don't want to waste time for this because I believe that you won't have any problems doing them. So let's get back to our demo. And I hope that I've demonstrated that in just about 15 minutes, you can declare a generator that will save thousands of lines of boilerplate in an actual source code. For example, in real-world projects, there might be projects with dozens of types implementing notify property changes for dozens of properties. And now you might notice that implementing this interface isn't actually all that new. And before, I used Foddy to implement exactly the same interface without all this boilerplate. So should we use source generators because they are new, shiny, and provided by Microsoft? Or do they have some unique advantages over existing tools, for example, text templates, IL weaving, IL generator? And I'm going to compare them to IL weaving, which is probably the most common way to extending some functionality. So the main difference here is that source generators can only add new files, and IL weaving rewrites bytecode after the assembly is compiled. If you haven't worked with Foddy, it looks like this. You simply implement the interface in some type, declare the property changed property event, and declare some auto properties. And after this code is compiled, these properties are transformed to regular properties with backing fields that will fire some notifications from the setters. So it works like magic, and I want to highlight a few key differences with source generators here. For example, in order to alter some bytecode, you first need to compile it. And for that, you have to declare the property changed event, because without it, the project won't compile. You don't have any bytecode. So with IL weaving, it might be hard to declare something that is required for compilation. For example, some members that you need to implement from interfaces. But on the other hand, with source generators, you won't be able to declare regular auto properties there, because the only option available for source generators is to add some new sources to your solution. So if you already have an auto property, it already doesn't fire any notifications. Source generators cannot change that. Instead, you'll have to rely on backend fields and either some naming conventions or attribute configurations to tell the generator how to generate a property from this backend field. And one other interesting difference is that whatever you add from a source generator will be visible at compile time. Usually it's quite beneficial because you don't care whether you've declared a member yourself or whether it was generated, you can simply use it. But for property change, it might be a bit cumbersome because you'll have the backend fields in code completion, you can accidentally assign some new value to it instead of the property and miss the notification. So back to pros and cons of generators over IL weaving. Actually, source generators are superior in many aspects. For example, compiler will check the string you provide to it instead of writing some bytecode that might result in invalid program exception if you do it wrong. You have no problems navigating to the generated sources and debugging it, something that might be very hard with IL weaving because you don't have the actual source code. And the only disadvantages of source generators are they require partial to extend any type, which is probably not a big deal. And second, they cannot change existing code, whereas IL weaving can remove or change anything, for example, to optimize your code. And this brings us to the question whether IL weaving is obsolete now or not. But as I mentioned before, IL weaving can alter existing methods, and this is often used to add some functional aspects to your code. For example, to swallow exceptions, to do some login injection, to drop trace messages. For example, with Foddy, you can drop a line in a log every time you create a disposable object and every time it reaches finalization queue. So with these logs, you'll be able to find where you created an object that you forgot to dispose. And according to the official documentation of source generators, all these tasks are code rewriting tasks. They include optimization, IL weaving, call site rewriting, and login injection. And while they have many valuable use cases, they do not fit into the idea of source generation. And this is a bit disappointing. So let me show you that actually you are still able to provide some extension points for source generators, for example, for login injection. And by this, we usually understand that we want to log something at the beginning of a method, for example, the values of the call arguments, and at the end of a method, log its execution type, whether there were any returned values, whether there were any exceptions. For example, with post sharp, it looks like this. You simply add a log attribute to some method, and after the compilation, there are about 75 lines of code. It's a big enterprise framework that boil down to the following. First, let's log the parameter values at the beginning of a method, then under a try statement, execute the actual source code that was there before the transformation. And after that, either log that the method has ended successfully or that there was some exceptions. So can we do this with source generators? For example, here there is some service that might be part of some bank service, for example, to get clients' accounts and get their balance. And in object-oriented programming, if you want some extension point, you simply add another layer of abstraction. So let's introduce an interface for this service. And now I can generate a decorator for this interface from a generator. For example, I can implement the same interface in a proxy implementation. I'll accept the actual underlying business logic in my constructor, and then implement every single method with the decorators that will add all the required logging, and then simply delegate the control to the underlying object. With this technique, I'll be able to add whatever I need before and after the call, and I'll only have problems changing something deep within a method, which is probably not needed very often. And I'll also have some problems too when I won't be able to extract something in an interface, for example, static members or private methods. For this, for example, you can try to use abstract classes and extend them from a generator. And with this, I believe that isle-weaving will become a niche tool because most modifications can be easily re-implemented with generators. There will be a slight implementation difference. Isle-weaving is difficult to debug and test, but at the same time, implementation details won't be visible during compilation. So for property changed, I would probably stick with 4D because I cannot imagine a situation where I'd like to debug this code. But for example, if I'm going to implement some equality members, I'm going to use source generators because I might be curious how, let's say, collections are compared. And some extensions are actually almost impossible to replace with generators. For example, with 4D, you can add null checks for every method. This is something you probably don't want to do with decorators. You are able to add configure await to every call in your program. And since this call might be located deep within the method, you won't have an extension point for source generators there. For example, with post sharp, you can add deadlock detection by dropping a line in a log every time you work with some synchronization primitive. And unfortunately for these tasks, isle-weaving is still the tool to go. And isle-weaving is not actually the only way to generate some code. We also have runtime generation, which is usually done with a type named isle generator. If you haven't used it directly, you might have used expression compile that uses it under the hood. And it is often too used to add some functional aspects that require a lot of boilerplate. I've personally used the isle generator type to provide some login decorators and encryption over some messaging interfaces. And if everything you need to extend is available at compile time, you can simply replace the isle generator with source generators. It will work the same. If something you need depends on runtime arguments, for example, if you want to provide a method that will process some regular expression, and it might be provided by your customers from a user interface, and you don't know them until runtime, source generators are entirely a compile time tool. So in this case, you'll still have to go to the source as the isle generator type. And one other tool I want to mention is reflection. It might be a bit surprising because reflection doesn't generate any code, does it? But actually, we often use reflection to write less code. For example, for serialization. Whatever framework you are going to use, units of JSON, system text JSON, data contract serializer, XML serializer, in order to serialize an object, you need to know what fields and properties does it have. And this is often checked with reflection. But actually, we could have provided a serialization method for every type in our project and update it every time we add or remove some fields or properties in it. We usually don't do this because it's a lot of code and a lot of maintenance. But if we can generate these serialization methods automatically from a source generator, it won't be a problem and we won't have to use reflection. And there is actually a project that does exactly this. It's called JSON SRC-Gen. And it adds serialization methods to JSON to types in your project. And according to its maintainers' measurements, the first startup time and first serialization time is a few orders of magnitude faster than when using system text JSON. So if everything you need is available at compile time, another example is dependency injection container building, which is often done by registering every single type in an assembly that is found with reflection as the implemented interfaces that are again found with reflection. You can simply provide some customized code from a source generator to either serialize your objects or to build a dependency injection container. And if something depends on runtime arguments, for example, runtime object inspection, or if you want to work around some compiler limitations, such as access to private members, reflection is still the tool you'll use. So with isle generator and reflection, everything depends on the way you use them. Check whether it makes sense for your particular scenario to replace them with source-generated code. Isle-weaving, I believe, will become niche, but they still have the unique pros. And the only tool that is likely gone is text templates, because just as source generators, they only create new files. They have their own syntax without direct support in most IDEs. And for example, Roslyn, our compiler, is already using source generators to provide syntax types from the XML declarations, something where text template would be applicable. You can check pull requests that uses source generators there. And the only advantages text templates have, they can create any files and not limited to just C#. And you have much more fine-grained control on when text templates are executed, because source generators are going to be triggered by the compiler every time something has changed in the code editor, and this might be a bit too often for some CPU-expensive tasks. And in the next section, I'm going to explain how to deal with some common problems. For example, how to handle dependencies in your generators. What if you want to use multiple generators, how they will fit together, how to let your colleagues know about some generated members, and how to make a generator configurable, what to do if you need some additional data that is not a part of your C# project, how to let your customers know about some problem, and finally, how to make a generator faster. And probably the first problem you might have is you don't want to declare your own generator for some common tasks. So there are some good news. Generators can be added as a regular NuGet package, and sharing your own source generator is as easy as with any ROS analyzer. But if you're going to write a generator you're going to share with the community, don't forget that you are writing code for someone else's project. For example, don't forget to check the target's project's language version, because there's a common misconception. People tend to think that source generators are C#9 feature. Actually, you can use them even with earlier language versions, as long as you are using the modern compiler. So these people will probably not be happy if you add some pattern matching or covariant return types in their solutions. And actually, source generators aren't even a C# language feature. You can declare generators that will write some Visual Basic code as well. And don't forget that your code has some dependencies. For example, if you're going to provide serialization members, you might want to use some common libraries, such as newtons of JSON for, let's say, arrays of primitives. And don't forget to take a public dependency on this package, so everyone who will reference your generator will also get this assembly and won't have to wonder what they need to reference in order for the generated code to compile. And another interesting question is what to do if you have multiple generators. Whether you can declare an order of the execution, what to do if you want to use something that will be added from another generator in a different one. And the short answer is that generators are completely independent. Everything the compiler passes to your generator is immutable, so you cannot affect any other generator in any way. And every file from all the generators will be added all together to the resulting compilation. So when any of the generators is executing, there is nothing that will be added by other generators yet. So if you need to add something that relies on another generator, you can simply use it within your source code. It won't be a problem, because when this code will be compiled, everything from the other generators will be already added. And if you want to extend something from different generators, for example, to add login injection to some interface and then add caching to it, the one approach you can use is decorators. So simply provide one decorator from one interface, another from another generator, and you'll be able to combine them in the actual source code. And one final advice here before we'll go to the second demo is use the new partial keyword. It got extended in C#9. Before that, we could only use partial for private members that won't return anything. So if you don't provide an actual implementation, the invocation can be omitted. And now we can use them for public methods. Doesn't matter whether they return something or not. And because we'll have to return something, this invocation cannot be skipped. So what you'll get there is essentially an abstract method that requires an implementation within the very same type. So in this case, I'll have to provide the second part of this type and provide an actual implementation for this method. It might seem a bit strange. Why would I need to declare something only to immediately implement it? But as you've probably guessed by the topic of this talk, the second part might be source generated, in which case the original declaration serves two purposes. First of all, there is now a place where you can put an attribute to control what is generated. And second, a few years later, either you or your colleagues won't have to wonder what methods are available in this type. They immediately spot this declaration and will be able to use it to navigate to the actual source code. And let's get to the second demo for a few more examples of what you can do with source generators. Here I have login injection implemented with a source generator. There are some services that demonstrate how it might work in some bank application. I can calculate balance for my clients. I can check what accounts they have, and I have an extension method with login provided by a generator that simply wraps an interface in a decorator that will add some login for it, as I mentioned before with decorators. So let's check how it works. I'll need to compile this project first. The generator is operating with a log attribute. So I simply annotate any interface I want to extend and process it from a generator. And here I request how many money there are on some accounts for one of the clients, John Doe. It also checks what accounts they have. There are 2 accounts, and in 568 milliseconds, I might want to check what's the performance problem here. I calculate that they owe me $5,000 US. And for the second client, Jane Doe, there is actually an exception that is thrown, and I now know where it happens, with which arguments I can debug this problem. So that's login injection, and here's the generator that does it. It's on purpose very similar to what I've built in the first demo. It simply checks every single file in the target project and check every type declaration in it. After that, it checks what types are annotated with my log attribute by checking, say, attribute classes. And if it's an interface, I'll simply provide a withLogin method and a decorator. So this code is not really interesting, but let's discuss how we can improve this generator. And checking every single file in the target project is not very good, because there are large projects. For example, ResHarper solution has about 650 projects. It compiles about 5 minutes on my machine. So if I'll add a generator that will work another 5 minutes, it will already be somewhat bad. If I'll add 10 generators, I'll have to wait about 1 hour for this to compile, and I'll never agree to wait such a time. So checking every single file is not what we want. And instead, you can subscribe to compiler notifications about syntax elements that are there in the target project with the initialize method. In its context, there is a single method, a register for syntax notifications, that you can use to provide a syntax receiver. Syntax receiver as a type that should implement an iSyntax receiver interface. And this interface contains a single method on visit syntax node. So when the compiler first checks what is there in my project to provide you with the compilation object, it also checks every syntax element in the target project, and it will fire notifications for every generator about the syntax elements it found. So I can check that syntax node is actually a type declaration syntax, and I can check that it has some attributes, so I might need to process it in my generator. Simply check that there are some attributes, and I can store them for later. For example, I can add this declaration to a hash set that will store type declaration syntax elements. And this run will be shared among all generators, so the compiler will only check every file in the target project once and notify every generator about it. So here, instead of checking every single file myself, I can instead access context, syntax receiver, cast it to my syntax receiver type I've just declared, and I'll be able to work with an already populated hash set of every type declaration in the target project that has some attributes instead of checking them and finding them by looking through every single file in the target project, and it will work exactly the same. And it might be tempting to check whether it's the log attribute they're annotated with, and it might seem that you have everything you need from the syntax element. So attribute list, we can select many attributes in it, and we can try to check whether any of them has a name that equals to our log attribute. And in some scenarios, it might work, but I want to warn you against it, because in real projects, log attribute might not always be written like this. It might be written in the full form log attribute. It might be written with some namespace, and it actually can be written with an alias, because C# supports them. So you cannot check that something is named log. You need semantic model for this, and it is not available there yet. So simply store every single type that has some attributes, and then check them in your actual execute method and move this semantic model getDeclaredSymbol method as early as possible, because working with syntax is not always convenient. And another problem with source generators is they are triggered very often by the compiler, because it doesn't know whether some changes in the code editor require you to restart your generator and produce something different. So if I type console write line, this generator has just been triggered 60 times. So that's 3 times per every symbol I've typed in an editor, which is a lot. And instead, you might want to check whether someone is still interested in what you are going to generate with context cancellation token, because maybe your customer has already typed something else and there will be another run of this generator. And you can check this throw if cancellation requested. And this method is actually very interesting because it throws an exception. And it's probably not a problem if nobody is interested in what we are going to generate. But what if there is an actual exception in your source generator? So what if it runs in, let's say, null reference exception or in any other kind of exception? Will you as a customer be able to debug what's going wrong and guess what the problem is? Let's check it. And when I compile this project, I'm definitely going to get some errors about the login implementations not being there. And the only error I have telling me that the typo namespace name login impl default, which is supposed to be generated from my source generator, is not there. And as a customer, I might wonder whether I've annotated everything properly, whether I've configured the generator, whether it was run at all, or I forgot to add some output item type analyzer, for example, or if there is some other problem and my generators are simply not executed. And it's very inconvenient. So you actually have a warning telling you what's wrong there. It's telling you that generator login proxy generator failed to generate source. It will not contribute to the output, and compilation errors may occur as a result, which we observe. And this warning is easily lost among compilation errors it triggers. So I have no idea why the compiler team has decided that emitting a warning is enough here. And I recommend you to lift it to an error with MS build warnings as errors. Note that regular warnings as errors won't work here. You'll need the MS build prefix. And now the next time you'll compile this project, you'll get a very clear error telling you exactly what is wrong with your generator. And you'll know that it was triggered and it's configured properly, but there is some error in it, and you might want to contain the generator author or debug this generator yourself. Now I have an error telling me exactly what is wrong. And speaking about misconfiguration of generators, here I simply ignore every log attribute that is not placed on an interface and not generate anything. This might be quite inconvenient for your customers if you are using this generator for the first time. So for example, they might accidentally place this log attribute on the actual implementation types instead. So let's check what we'll do. Our generator in this case. And I've moved to the log attributes. Let me recompile this project and check what errors I'll get and whether I'll be able to understand what's going wrong here. And yeah, the only error I'm getting is telling me that the typo namespace login impl default is not found. Again, I have no idea why the generator has not generated anything. And this is a problem that you as a generator author can solve. You can add some diagnostics from your generators. So essentially, generators are code analyzers. You can provide a diagnostic ID and category, such as log generator. You can tell your customers what is wrong. For example, log must be applied to an interface. And you can tell the compiler whether it's a warning or an error. And last but not least, you can provide a location where the problem has happened. Every syntax element has a method called getLocation that you can use to guide your customers to the exact place where the problem has happened. And now, if I compile this project again, I'll see a few more errors telling me exactly what is wrong and how to fix this problem. I can simply double-click on this error telling me that log attribute is misused, and I'll see where the problem is. I'll see how to fix it. Let's fix it again and run our generator. And by the way, there is another interesting problem with the log attribute. It is not clear where your customers are going to get it. Right now, I have to provide my generator with an instruction telling my customers, please don't forget to use this log attribute, declare in your code and use it to configure my generator, which is quite inconvenient. And it might seem that we can simply move this attribute to our generator as well. After all, we're generating code for this project. So log src is this log attribute, and I can simply add this source file, add source log cs, and everything should work. So let's try it. And unfortunately, the only error you'll get there, again, will tell you that the login impl default is not found. Let's check that it actually happens. And there are no other errors, so the log attribute is resolved correctly, and you might have no idea why it doesn't work. And as I mentioned before, every file from every generator, including your own, will only be added after all the generators has finished their work. So until there is no log attribute in the target project. So when you ask the target project to provide you with log attribute, it is not there yet. And it's quite inconvenient. So in the future, the compiler team wants to provide you with some API to add some static sources, for example, some attributes you might need in the initialize method. But for now, we have a method called compilation add syntax trees, where we can add some syntax trees to the target project. And for this, we'll first need to parse them, C# syntax tree, parse text, this log attribute. And I'll also need to provide C# parse options to tell the compiler what language version should use, for example. They will be the same for every file in the target project, and they are available from your context. So this will be our log syntax tree that I'll add to the compilation. And as I mentioned before, every method you are going to call on the compilation object is pure. So what you'll get is a new compilation object that will differ from the original one by this one attribute. And the scope of this compilation is limited to your generator, so you won't be able to affect any other generator or the resulting project. You'll simply be able to use the log attribute that you've just added. Don't forget to add it to the actual source code of the target project as well. And now everything will finally work, and you'll be able to pack the attributes you need to configure your generator as a part of it. Let's check that everything works. I should get the login attributes working now. Oh, I've hidden the console window. And I'm still getting everything. And there is one other thing you might want to configure in this generator. And the problem is that this is some sensitive information. I print the names of my customers, their contact emails, how much money they owe me. So at least in production, you might want to hide this information behind some encryption. And this generator might not do this yet. And you also might not want to do this in debug because your developers might have a hard time deciphering every log when they try to develop your application. For this, you can provide the generator with an access to some MS-built properties with the compiler visible property. Include a property named log encryption, and you'll be able to set it, for example, a directory build props file for your solution. Let's do this. And I'll set it to true only in release mode. So encryption true. And now I can access this property from my generator and change something based on it. I can use context, analyzer config options, global options, access this property with a build property prefix. I'll get a full encryption string. I'll be able to parse it to a Boolean value. I'll get whether someone wants me to encrypt this log, and I won't write any real encryption in just 5 minutes. So let's simply use this variable encrypt and change something. So we'll see that something has changed in release mode. For example, I can use system convert to base 64 string coding UTF-8 get bytes for my original message. I'll pass this parameter from natural method. Now let's switch this to release mode, and you'll see that we now cannot read this log without some tool. Because base 64 encryption is not real encryption algorithm. It simply transforms some strings, so don't use it in production for some sensitive data. So let's simply check that something has changed in release mode. And in real production, you might want to configure an actual encryption key for your generator. And this again might be a bit tricky because you don't want it to be as part of your generator. Yep, we cannot read this log anymore in production. And if you want to provide encryption key, you might not want to see it as a part of your generator because it might be a third-party generator. And you might even not want to see your encryption key in your repository because a lot of people might have access to it. And for this, you can provide an additional file for a generator that will only be available, let's say, on the build server. And you can provide some file, let's say, log encryption key, that you'll be able to read from a generator and use as an encryption key. With context, additional files, you'll be able to find first file that has .key extension and use its text as an encryption key. And with this, you can gain access to something that is not part of the target compilation. So it is not there, but you'll be able to use this file as an encryption key. And last but not least, I must warn you about some security problems, because not every generator you are going to find might be good for you, and you are not from it doing something like this. Util send sources to my email, and I'll pack every single file in your project in an email to hack@gmail.com. Here I've commented the actual SMTP send call, and I'll leave a line knock knock now, all your sources are belong to us, to let you know that all your sources have been stolen by a generator. And you might wonder what's the big deal here. We have Roslyn analyzers for a few years by now. They can stall our source code. It hasn't been a problem yet. We can run some third-party code and it might execute something, for example, the console write line, as I did here, as a part of this third code library we referenced. So how generators are different from this. And one interesting distinction is that you don't need to actually call anything. So let me remove everything from my main method, and I'll still be able to print these two lines, knock knock now, and they will be executed as a part of your application with its rights. It might be a web server running with administrative privileges, or there might be some database connection strings nearby with databases, some sensitive information. Or it can be an application you deployed to your customers, and I might use it as a backdoor to them. Any other year, I would have hard time stressing enough how problematic this could be. If you followed news earlier this year, you might have heard about SolarWinds breach. And some hackers are getting access to a build process of the company and injecting some code in their product, so it can be turned into a backdoor for their customers, among them, there were some very influential companies, for example, some of the United States government structures. And what source generators essentially are, they are a part of your build process that will inject some code into your program. So it's essentially a ready backdoor if you haven't checked what is the source code of your source generator. Here I've used a model initializer to simply run some code even before your application is fully loaded. It's a new C#9 feature. And unfortunately, one other difference with a third-party library is that third-party libraries' code is static until you update them. And with a source generator, you might check that the generated files don't contain anything problematic, but you cannot guarantee that the second run of this generator on a build server will be the same. So it might try to check whether you're running in release mode, whether it's running on a build server, and change some code injected in your product. And to be safe from it, you can ask the compiler to emit every file generated by a source generator on the hard drive, for example, in the generated folder with emit compiler generated files true. And this is an option I recommend you to set on your build server so you can check what is generated during an actual product build that you are going to ship to your customers. So let's check that this folder is there. Of course, you also need to check that these files aren't tampered with, because the generator might spawn a process that will try to clean up it. And you'll see a folder with this generator and some suspicious file called hex.cs. So don't overlook it in production. And I hope that this won't scare you off source generators, because this is essentially the risk we have with every third-party code. So if you're going to use them, leave CS8785 warning to an error with MS-build warnings as errors. If you're going to write source generators, don't forget to check context cancellation token and use asyntax receiver to make your generator faster. Produce diagnostics to tell your customers what's wrong with your generator, and pack every attribute you need as a part of your generator. And to wrap it up, source generators let you create boilerplate code easily, which makes possible to do some performance optimizations at startup, for example, by eliminating reflection. And they solve a lot of typical metaprogramming problems, such as navigation to the generated code and debugging, test coverage for code generation process. And finally, they're easy to use, because write something as a string is something we do every day in the code editor. It's not as difficult as writing some bytecode. And because of this, many metaprogramming tools become niche, but since generators can only add new files, they're still with us. And if you want to use some examples of source generators available today, there is a very useful list of GitHub projects containing them. There is an SVG2 C# source generator you might want to check that transforms SVG files into types returning a sky picture. There is a JSON SRC gen I mentioned before that provides serialization to JSON without reflection. There is a generator provided by Microsoft, Win32p involve generator, that adds Win32 methods and all required types to your project. So check it out. And if you now want to write your own source generator, check Source Generators Cookbook from Microsoft. There are a few examples that I explained in details. If you're interested in something I've built during this session, for example, how to test your generator, you can check these examples on my GitHub account. You can try to go to SourceGenDev and use some examples there to play with them. And I'm looking forward to what you're going to build with source generators, but don't forget that with great power comes great responsibility. Every link you'll be able to find on a GitHub gist by this QR code, and thank you for watching.
Right. Let's add ourselves back. Yeah, there we are. Thank you, Andrey, for a fantastic talk. It's a really deep topic, and I think you managed to squeeze 5 hours of amazing content on source generators into 1 hour. So thank you for that. Absolutely.
Definitely.
We do have some questions that came in, so let's see if we can get them answered.
Sure.
First question that came in was really about the tooling that you've been using. So I think you mentioned sourcegen.dev at the end in the resources.
Yes.
Are there any other tools that you recommend to see and inspect syntax trees and get familiar with what you can do with them?
Well, Sharplab.io is a website I've used to check what Roslyn generates for some arbitrary code, and that's where you can check how some syntax elements are named, which could be very useful if something will change in the, for example, C# 10 version. So if some code is processed differently, you'll be able to check how the new element is called and will be able to update your generator according to it. And that's what I usually use when I want to work with the compiler. So nothing really fancy there.
All right, that makes sense. Then a couple of more practical questions, I guess, that came in from a couple of people. Are there scenarios where you do not recommend using source generators?
First, I would definitely recommend you to check the source generator's code if you're going to add something to your project because of some security risks. And if you cannot afford to do the code audit or at least check what is generated, that's probably not something you want to add to your project. And personally, I don't like source generators for the property change notifications because I'll see my backend fields and I'll never want to debug it. It might be a bit cumbersome to use if I want to extend every single method in my project, for example, with null checks, because I cannot move, for example, private methods to interfaces to provide decorators. So for some tasks, I would definitely still prefer to use IL weaving.
Yeah, cool, that makes sense. Yeah, you mentioned seeing the code and so on, so I guess that ties in nicely into the next question that we got. How easy is it to unit test generators? Do you generate plumbing for those, or are there libraries that people can use? Or
I haven't seen any libraries, but since I've written a couple of generators myself, I simply added a single line of code that compiles some arbitrary source and runs generators over it. So it's a single method. I don't think you really need a library for that. And you can check it on my GitHub and add it to your unit test projects. And after that, it's a simple compile some source code and run generators over it, check what it returned. So
I can add there. What I really like is Verify by Simon Kropp. That is really cool because you can grab the generated code and then compare it with a verified snapshot of what has been generated before. That's really cool.
Cool. All right, we have a couple more. Matthias, I think you were creating a list of questions as well.
I also have one. That's more a bit more far from the topic. I mean, slightly a bit philosophical. Are you still looking forward to have like proper AOP support in C#? I mean, source generators have a bit of limitation, making the original class partial and stuff like that. But do you think with options that we have like PostSharp and Foley, you mentioned both, something like proper integration for AOP is still interesting?
I believe it definitely is still interesting because source generators have their limitations. I mentioned a couple before. For example, it will be really hard to change something within the method, in the middle of a method, or change something that requires you to provide an extension point for a private method. And because of this, I would definitely still use AOP, but I don't believe that something like this is going to be provided as a part of C# compiler now, because they have their own tool and every other scenario is already covered by existing IL weaving tools such as Foley and PostSharp.
Yeah,
so it still has its use, but I don't think it will be integrated into the C# language right now.
Yeah, I guess it is pretty niche. I mean, there are usually you just have a handful of how to say, very specific use cases for AOP. At least that's what I remember when I studied a bit about them. One thing that I remember. Do we still have a bit of time?
Yeah. Go ahead.
One thing I remember, and I'm sorry, maybe you mentioned it, but I had to run for the door really quick in the meantime. One thing that I discovered is usually you're limited by this partial declaration of methods and types, right? What I found also works pretty nice, and it was more by accident, is that you can derive from the original type and just make it hide the other one. So, do you know what I mean?
Yeah, I understand what you mean. It seems a bit hacky to me because imagine that a few years later your colleagues will find this and they'll try to navigate to some method and they'll have no idea how to look for something you've generated. So I would not do this. But I've been toying with an idea of working around source generators limitations. For example, if you actually want to provide some extension points within a method, let's say to add login every time you work with some synchronization primitives, another interesting approach you can use, you can simply generate a copy of the original type and simply put all the required strings there and use this copy instead of the original type. So the generator will basically see everything that is declared in your project. You can simply provide a copy and augment it the way you want. As long as you are using the generated type, it will not have any problems with extension points.
All right.
All right. Yeah, I have a couple more questions that are that seem to be coming in. So that's always nice. If you have questions, do feel free to ask them in the chat, and we'll see if we can ask them to Andrey. One of the questions we got was on compilation time. You mentioned that source generators essentially run individually and run as part of the compilation, of course. Do you notice any noticeable slowdown in compile times or something?
Well, as I mentioned before, I've actually measured. They run on average 3 times per every symbol you type in the code editor. So if you don't see any critical lags in code editors, then probably source generators are working quite fast.
Yeah.
And you can alleviate this problem by bailing out early this context cancellation token. You can also use a syntax receiver I mentioned before to make the exploration type linear across all generators. And quite frankly, there is now a lot of things going on in your code editor. Every time you change something, there is a Roslyn analyzer that has to provide you with code completion, that has to know everything you've changed, which members are available to highlight something. There is a ReSharper analyzing that does similar things. So if your generator doesn't do any, let's say, web requests and updating gigabytes of data, it's not usually a problem. If it is, one approach you can use is to wait some time before doing some heavy loading, check whether the cancellation is triggered, or you can switch to text templates because with them you'll have a much more clear and fine-grained control over when you do some heavy loading.
I actually have one more thing. Martin, can I make an advertisement for my webinar next week?
Do it.
So if you're interested next week, I think on the 18th of May, but you can definitely check on our website. We will have silk.net in one of our webinar series. And that's going to be like a proper real life scenario, let's say, about source generators. I think if I remember correctly, their source generator runs for 25 minutes on the build agent, which is crazy, but they use it to it's kind of generated from other sources, so it's looks reasonable. But definitely, if you're interested, then check this out next week. I think on the 18th May.
Cool, thanks for that. By the way, if you are watching the stream here, if you are interested in more webinars that we give and more sessions like these, do subscribe to our channel here. And with that, I guess we are through our questions, and let's bring in our next host and next speaker. Andrey, thank you again.
Thank you.
And we'll see you around.
Thanks, Andrey.
And Matthias, I am afraid that I will kick you off the stream as well, so we can bring in
I'll kick myself out. I will show myself the door.
It's fine. Go for it.
See you later.
See you guys.
See you.
All right, and there's Matt. Hello, Matt.
Hello there. How are you doing? How's it going? It's going well so far. That was a really good session. Very much enjoyed that.
Just want to say it's probably also recommended to not watch it at double speed because there's so much information in there that you don't want to miss.
I did have to catch up for the first 10 minutes there, and that was fast. It's like straight at you. But it's really good. There's lots of really cool things there. One of the things I liked was the gotchas. Some of the gotchas which are great for sort of source code analysis type things, where you think you can look at the log attribute just by looking at an attribute name for log, but it can actually be log or log attribute or namespace.log, namespace.log attribute. All of these kinds of things there, little gotcha of things that can easily trip you up, and it's nice to have those kinds of hints and tips, really, isn't it?
So yeah, I guess I know what we'll all be doing in the team, writing source generators and giving that a try.
Yes, they can be a little bit dangerous, though, can't they, Martin?
Yes, they can. Actually, I've been playing with them last week. So if you search for my blog, there's a post there where I'm actually doing a supply chain attack and shipping off your machine name to a DNS server that I control. It's not really scary, but also the fact that you can do all those things is kind of scary. It's
kind of scary when you use your colleagues as guinea pigs as well. That's I'm just going to leave it out there like that.
I still appreciate you testing that one for me. Thank you.
Yeah, anytime. I'll take one for the team. It's good. Oh, and I just noticed. No, I'm not a Lego man. That's not actually me, by the way. Somebody's just commented on the stream there. That's just a cartoon. It's not really me.
All right. So let's also bring in our next speaker, who is gonna cover debugging, actually CSI.NET Core, looking into debugging and things like that. So let's bring in Tess. Hello, Tess.
Hello, how are you?
Good, how are you?
I am good.
Really looking forward.
Excited.
Yeah, same thing. Also, thank you for joining us again for the second year. That's
it was fun
nice.
last year, I think.
Cool. So what will you be covering in your session?
Well, last year I was talking about Python because I'm actually more of a Python developer these days. But lately I've been getting back to .NET. So I've been getting back to my roots with .NET debugging. So we'll be looking at .NET debugging of like really pesky issues like memory leaks and hangs and these kind of things. But now in sort of like the .NET Core world, Linux, Azure, you name it.
That sounds like a lot of fun. These kinds of things are skills you kind of really need to pick up, I think, to be able to solve some of the really tricky problems.
Yeah, I think so too.
Cool. All right, then I guess we can bring your screen in as well and
yes.
give you the stage so you can enlighten people about the crime scenes that you've been wading through.
Yes. Cool. So, yeah, can you see this? Cool, let's go. So I'm Tess. I'm a software engineer at Microsoft. Been at Microsoft for a long, long time, and I started my career at Microsoft in developer support, so helping people troubleshoot memory leaks and hangs and stuff. Actually, back then in ASP, but then ASP.NET and so on. And I used to work with that for a long time and debug really hairy issues. Nowadays, I only troubleshoot my own issues, but yet I still wanted to sort of like take this time to show you a little bit like how it works. So what we're going to delve into, like I mentioned to Martin, was high memory issues, bad performance, crashes, exceptions, the kind of stuff that you can't really step-by-step debug. So it's not easy to go through these issues with Visual Studio or setting breakpoints or what have you. And also these type of issues tend to happen very, very intermittently. So you can, and that's also a reason why you can't step-by-step debug, but it might happen intermittently on your machine or on someone else's machine, and maybe on a machine that's not even your operating system. Like if you're running Windows, it might happen at your customer's machine on Linux or Mac or even in the cloud. So the question is, how do you deal with these issues that you can't really step-by-step in debugger? And I also want to sprinkle it with a little bit of .NET internal, so how .NET works under the hood, because I think when you're debugging something, or even if you're not debugging something, but you're just developing in .NET, for example, it's nice to know how things work underneath, because then you can sort of like prevent these issues from happening, because you know the kind of issues that you don't want to get yourself into. So we're going to delve in the deep end on this, start debugging a high memory issue. And when we're troubleshooting a high memory issue, we only have to ask ourselves really two simple questions. What's using up the memory, and why is the memory, sort of why is the allocated memory not going away? Because one thing we know about .NET, and that hopefully most of you know about .NET, is that it's using a garbage collector. So theoretically, we would think that the garbage collector should take care of throwing away all the memory that we're not wanting. So the question is, why is it still sticking around? And we'll have a look at that. So let's just dig into our first example. And this session is going to be very much demo based. So we're going to see how to troubleshoot these issues live. We'll start off with one simple case, and I'm calling it simple because I'm going to show you before we even start sort of what the problem is, so that you can follow along while debugging. So we have a very simple console app, and in this console app we're simulating a memory leak by creating these product items. Nothing fancy about them. They just happen to have like a char array because that generates a lot of memory fast. And we're just generating them in a loop, so 10,000 of them, and adding them to a list. So essentially, once we've gone through one of these loops, we're now holding on to 10,000 of these products. And then we can simulate it by going through this loop over and over. But this is the product we're going to troubleshoot in the first case. And you can imagine a situation where you didn't know what the problem was, i.e. that we're creating all these products and putting them in a loop. So, and then that you would have to troubleshoot why we're using that much memory. So we're going to run .NET run, and I want to point out that I'm running this on Linux. So the tools I'm going to be using are tools that work on Linux, on Windows, and in Azure if you want to. But it's good to know that these are sort of platform agnostic. So we have this project. Sorry, I'm going to see if I can turn off. Let's see if that works. Yeah, so we have this project or this process that's running, eating up some memory. And one of the first things we want to know is, are we actually, like, what's our memory usage look like? So we have this tool called .NET counters that you can install with .NET Core. And we can do .NET counters PS to list the processes that we can monitor. So with .NET counters, what we can do is we can, in this case, let's just start and you'll see what it is. .NET counters monitor, and then we want to monitor this this process 2036. Let me actually just write that down because I'm going to need that number later. So what this gives us is a number of counters that tell us how they tell us some information about the process. For example, what's the CPU usage right now, how many garbage collections, and so on and so forth. And if we look at this one in particular, this is how much .NET memory are we using. So we're using 202 megs, just from what we've been doing here. Now, let's leak some more and follow along on that counter. So that counter went up, telling us that, yes, indeed, we are leaking, or we are using a lot of .NET memory. And the reason why it's important to look at this is because even though the process is using up a lot of memory, we might not be using that much .NET memory. We could, for example, be leaking, we could be using a native component and leaking images or something like that, or we could be leaking DLLs. But in this case, we're pretty safe. We can pretty safely say that we are in fact leaking .NET memory. So .NET counters is a good way to sort of just get an overview of what your process is doing. Now we want to figure out, okay, so what is using up all this memory? So we can use another tool called .NET GC dump, and it comes with a command called collect, and we use the same process ID. So the process ID was 2036. So what this will do is it will generate a snapshot of the .NET heap. What that means is that it will generate a snapshot that we can now use to figure out what we were allocating. And we can open this up in Visual Studio. So let me bring Visual Studio over here and open up the file. So let's see, I had it sequence dumps. And even though this is a Linux GC dump, I can still open it up here in Visual Studio on Windows, so that's nice. By the way, I should also say that if you're troubleshooting sort of like your own process and you're working in Visual Studio, you can also get to this from diagnostic tools. And in diagnostic tools, if you're debugging, you can right-click and create a heap snapshot. And in this case, then we see that if we look at the things that are using up the most memory, we can see that in fact, all of the 402 megs that we're using are being used up directly or indirectly by these product items. And in fact, we have 20,000 of these product items. The question now is, why are they sticking around? Well, if we double click on these, what we'll get is a root chain, and a root chain tells us for everything what it is that's like our object and what it is that's holding on to it. So if we look at this root chain, we can see that the product is held on by a list of products. And now once we get to this point, we might say, okay, so I recognize what this list of products is, and I know what the product is, so let me go and fix the problem. If we don't know what it is and we want to troubleshoot it further, we can go in here and we can instead run another tool called .NET dump, and we'll do the same thing, collect-p 2036. So this will collect not only a dump of the .NET memory, but a dump of the whole process. So we can see what the threads are doing and all of that good stuff. So once this is written out, we're going to go ahead and analyze it and try to troubleshoot this just a little bit further. Okay, and we can also see that the process here reacted at the same time, saying that, hey, we wrote out all the memory for this dump. So you don't have like something that generates dumps for you without you knowing it. Now we can run .NET dump analyze, and it is called core or something. So this is using the exact same tool, but instead now we're going to go ahead and sort of look at what's in this memory dump to try to troubleshoot why it's using up so much memory. And this .NET dump tool is very similar to if you've ever used WinDBG, which we'll be using a little bit later. This is another incarnation of it, but only for .NET Core. So the dumps that we generate with .NET dump, we can also read in WinDBG, as we'll see a little bit later. And the commands that you'll run in here will also be sort of similar to if you've ever used WinDBG to troubleshoot .NET memory issues or hangs. One of which is, for example, version, which tells us what version of .NET is running in the process. EE in this case is execution engine. And we can tell that we're running .NET Core 5.0. We're running in something called workstation mode. And workstation mode means there's essentially two big modes, workstation mode or server mode, where workstation mode is for things like console apps or Windows apps or things like that, where you're not expecting a whole lot of concurrent requests. So on the other hand, server mode would be something that you run on a web server where you're expecting a lot of concurrent requests, and you want to make sure that that you're processing, for example, garbage collections in a way that you're not blocking those. But on workstation mode, you want to make sure you're not blocking the UI thread. So that's a little bit about the difference between these. One other major difference between these, we can see if we run eheap-gc. So eheap-gc gives us the overview of the heap. So the heap is where all the memory is kept. So eheap-gc here, we can see that we're using 406 roughly megs. Most of this is in these segments. So there are a bunch of segments, and we'll get around to talk about how memory is structured in .NET in just a little bit. And then we have some other, so these are the normal objects, and then we have some other heaps for large objects and pinned objects and so on. But we can see that we only have one of these GC heaps. And workstation mode only has one, as opposed to server mode that has one per logical processor. So the only thing you need to know about that is that it's useful more for what it's blocking or not blocking when it's doing the garbage collection. So we know that we're using 406 megs, but what are we using it on? So we'll run another command called dumpheap-stat. Dump heap statistics, which dumps out all the .NET objects, and this is quite useful and quite interesting that we can do this, and this has to do with how the memory is laid out, the fact that we can actually enumerate every single object that you have in your .NET process. But this gives us something that's very similar to what we saw in the GC dump case. In this case, at the very bottom, we're listing the objects that use up the most memory. So we have 20,000 system character arrays that in total use up 400 megs. And then if we look a little bit further up, we can find the products. For example, we have 20,000 products that in total, in this case, it says it's using up 800,000. And now we might ask, so why was this different from what we saw in GC dump? That because in GC dumps we saw that it used up 400 megs, and the reason is because this number that we're seeing here is not inclusive, in the sense it's not telling us what this product plus everything it's holding onto is using up. So even though, for example, the character array is a part of the product, that is not being counted in here. But anyways, we can see from this that if this was a memory dump problem and someone would say, hey, why am I using so much memory? I would say, you know, are you aware that you have 20,000 products? Is that fishy to you? Is that normal? And then I would go in and say, okay, so these big hitters, like the character arrays, where are they? Why are they sticking around? So I would then do, for example, dump heap and -mt, and mt comes from method tables. So that's kind of an identifier, or an ID for the type of object. So let's see if it. I think I'll stop it because I don't want to dump out all the 20,000 of them. And then I'll take one of them, and I can do something like do for dump object, or dump object for short, for long. So this is a character array like we were expecting, and I can say, why am I keeping this around? I'll do GC root. So this is the equivalent of clicking on it in GC dump. Let's see what happens. So now what it's doing is it needs to go through and enumerate the heap and try to find this and find anything that's holding on to it. Okay, great. And this usually takes a while if it's a really big memory dump. So we have the character array, and we see that this is linked by a product, and the product is linked by a product array, which is the internal implementation of system list. And then it's linked on a thread. So let's take this just one step at a time. Let's go into the product. So we'll do do on the product. So this is on the address. And we can see a couple of things here. A product, like I mentioned before, the size of the product does not include its member variables. So each product will always be 40 bytes. It will contain the same type of things, like it will always have a string, an int, and a character, and these are sort of defined by the method table and the EE class. So the EE class is the blueprint, method table tells us what methods we can use on it, and it's also the identifier for it. And the reason it was showing up here was, of course, because this character array here is this character array down here. So this is how we can figure out that why this is sticking around. So we know that as long as this is being held onto by a product, which is part of a list, which is used on thread 7F4, this won't go away. We can also go in and actually see what that thread is doing. And that thread is this thread, which we happen to be on. We can see by the star that we're on that thread. Otherwise, we could do set thread 0, for example, and then we can run CLR stack. So CLR stack in this case, what it will do is it will run, it will show us the stack, just like we would see in Visual Studio if we're stopped on a breakpoint or something. And we can see that it's in main and it's in a console read line, and all of this is just system stuff. But so now we know what the product did, or what the thread is doing. The thread is holding onto a list, and the list is holding onto that character array. So now we can start Unravel and fix that problem. Okay, so that was the long version of troubleshooting that problem, but hopefully it will give you just a little bit of an idea of how to troubleshoot just a basic memory problem on .NET, in .NET. So we use .NET counters, .NET GC dump, and .NET dump, and all of these are installable with .NET install. If you want to do this on your own, so if you want to go through all these like this and some other of the examples here, I do have a set of labs that take you through and simulate all of these problems. So you can troubleshoot them on your own if you want to do that before you get to troubleshooting your own code. Now, I was talking about before that we have a garbage collector. So technically, the garbage collector should garbage collect if it's garbage. But the problem when we have high memory usage is usually that it's not garbage. Or maybe we think it's garbage, but we didn't mark it as garbage. Somehow it is rooted. So in our case, it was rooted by a thread. So as long as that thread is using that list, and that list holds on to those objects, they will be around. A couple of other threads that I should mention, like static objects, pinned objects. So pinned objects are when you want to pin them to a specific memory location and keep them around. Cache, which is a special case of statics. And also one that's a little bit tricky, which is the finalized queue. So the finalized queue is a queue of objects to be destructed. And things that end up on there are things that have destructors. So anything that has like a tilde function or a tilde class name. We'll see that in just 1 second. But before we get into to troubleshooting a finalizer issue, like we'll see, let's talk a little bit about .NET memory management and garbage collection in general and what you should look out for. So .NET has a memory manager, and this is quite common for most modern programming languages. Like Python has a memory management manager, Java has a memory manager, and so on. Unlike, for example, C++, where you have to physically maybe not, but you have to specifically allocate the memory that you're going to be using. In this case, .NET will allocate it for you. And you can think about it a little bit like a restaurant where the memory manager has these tables or segments on the heap. And then when you get in and you start, for example, requesting a product, it will be placed at this table. So when you get into the restaurant, you get placed at this table. And they will place you like super tightly. This is pre-COVID, so things were like super, super tight. And then it will continue placing new objects like this, one after another, like literally like next byte. So let's have a look at how that looks, because that is sort of the key to why we can enumerate the heap. So if we go back to this eheap-gc, we can go in and look at dump heap from here to here, for example. I can drop there. So you'll see here that at this address, we have an object, and this is the method table. So this is probably the char array. And then right after it, so literally 20,024 bytes after, we'll have a new one, and it's here. And then a new one, and then a new one, and then a new one. So to enumerate the heap, we can simply go from the start, because we'll know. For example, if we take this one, which I know is a product, because it's the only thing that was 40 bytes, we know exactly how big this will be, and we know exactly how it will be laid out. So that's why at every single address, when we enumerate, we can say, okay, so how big is this? So I know that the next one will now be at 40 down, you know. And this whole thing about laying things out like this is why we can enumerate it, and that's a quite useful thing. Now we'll see also that sometimes they'll inject some of these free objects. This is just sort of like to align the objects a bit to addresses that are good. So we have this, and what happens when this table is now full and we want to allocate something else? Well, at that point, we don't necessarily want to drag out another table, because that's an expensive operation, like allocating a new memory segment. So instead, what we do is we go around and we say, hey, is anyone not in use anymore? Like, is anyone finished eating? Yeah. Okay, then let's remove that and compact. So mark, sweep, and compact. And then we can allocate more. And eventually, when it's all full and we can't garbage collect anymore, then we'll end up in this, and we'll end up with another segment, and so on. So this is called a mark, sweep, and compact garbage collector. As you may have noticed, and as you may know, we also have generations. So generations are there to optimize the way that the garbage collector works. And the reason it's nice is because if we think about it as little notes or little sticky notes that we have, what we do is we start allocating things, and we write little notes on sticky notes, and we place them on a board. And once that board is full, then we garbage collect them, and then we can start new sticky notes. And sticky notes are very, very inexpensive to write and remove. Because we know that anything that we allocate now, or anything that we write now, is likely to be used now, and it's likely also to be not interesting in a little while. But however, the things that are interesting once we've done our garbage collection, the things that are still around, we can now mark them as generation 1. And we know that if something survived one collection, they are more and more likely to stick around for a lot longer. Because, for example, generation 0 will be things like variables in our functions. So they will only be alive as long as we're in the function, or they will be variables that we use in our requests, and they will only be alive as long as the request is alive. But then they'll go away. So it would sort of be useless. It's useless to use a garbage collector that would try to garbage collect everything, even the things that have been around for a long time, the ones that are in sort of long-term storage, because they are much less likely to actually go away anytime soon. I feel like I didn't necessarily explain that like super neatly, but just remember, whatever is created now is more likely to be removed soon, like the variables that are used in your functions and requests, and things that are in cache or things that have been around for a long time are likely to actually stick around also a lot longer. So this is an optimization, and the way it works is that we garbage collect when we allocate. We don't garbage collect on a timer or anything, but whenever you need to allocate something new, that's when we garbage collect. And one thing we can do when we have a generational garbage collector like this is that we can also optimize the storage. So we try to keep, for example, generation 0 in L2 cache, or we try to keep generation 1 so it doesn't get swapped out to disk and things like that, because it's very much more likely to be used more often than the long-term storage generation 2. One thing we haven't talked about so far is the elephant in the room, like the large objects. So large objects are any objects that are over 85,000 bytes. They're a little bit special. They end up in something called the large object heap, which is a special table only for large objects, because they are heavier to move around and sweep and compact. So we don't want to sort of like put them among our normal objects, also as a way to optimize the garbage collector. But there is a problem with this. And that is that if we have a process that's very allocation heavy, specifically allocation heavy on the large object heap, we end up exhausting the large object heap a lot, and we end up collecting it a lot. And when we collect a large object heap, we collect everything. So that means that if you have a process that continuously triggers large object collections, you continuously trigger full collections. So be a little bit more frugal allocating very large objects. So again, one thing I want to mention is that, for example, the product is not going to be a large object, even if it contains a member variable that is a large object. It's only like the character array in this case that would be a large object, or a string or anything like that that can have varied size. But we'll see an example of that in a bit too. Let's go back a little bit to the finalizer. We're going to look at another problem here, another memory leak. In this case, I've taken a memory dump in advance of a process that was running high on memory. So I'm going to use another tool called WinDBG, and you can download this from the Windows Store. And you can use this, as I mentioned, with the .NET dump memory dumps, but also with memory dumps that you grab on with Task Manager. So you can right-click on any process here and create a dump file, and you can open up that here, or with procdump, or with whatever. There are many tools that you can use to generate memory dumps. So let's go ahead and open up a dump file. And yeah, this one. Let's see what happens. So in this case, let me just just a little bit bigger. So I'm going to run the same things here, E version, and just one little thing. In this case, I'm going to run exclamation mark before, because Visual Studio, WinDBG uses this as an extension. So in this case, SOS, which was built into .NET Dump, is an extension. And when you use an extension, you have to use this. In order to install SOS, so SOS comes with the .NET Framework, but for .NET Core, you install it with .NET Install SOS. Cool, so we run E version, and in this case, we can see that it's still 5.0, but we're running server mode with 8 GC heaps. This is because I have a 4-proc machine with dual cores, so that counts as 8 logical heaps. And we can also see this then when we run e-heap-kc, that instead of just 1 heap, we have 8 heaps, so heaps 0 to 7. But otherwise, it's still the same. It's segments, it's the large object segment, it's pinned segments, and the total amount of memory in here is 190 megabytes. And we'll run the same kind of like command. So dump heap stat. So we want to know what we're using as far as .NET memory. So most of it, again, is in a system character array, 8,000 of them. I usually go from the bottom and I look for things that that I recognize or that should be recognized by the developers. So this one, I can see that we have 8,000 of these links. So that might be a little bit interesting to understand why we have 8,000 of them. But let's go for this one. So I could have run a dump heap -mt and that method table, but in WinDBG we have something called the debugger markup language that allows you to create these clickable links. So SOS nicely have them. And let's take this one for example. So this one will create dump obj, or it will run dump obj on that. So okay, so this was character array with some kind of string in it. And then the next step here, I want to know why this is still sticking around. So I run gc root. And I can see from the bottom here, I have a character array that's part of a string builder, that's part of a link. So let's go ahead and drop this out just to see what it is. So it was, let's see, ended up with 948. Or sorry, the string builder ended with 900. Yeah, and it has to be this string builder, the 900. So this was the URL of this link object. So as long as this link object is around, this URL will still also be around. And that link object was around and stuck on the finalize queue. So this means that this object is ready to be garbage collected. So we don't need it anymore, but it can't be garbage collected yet because it's waiting in the queue to be finalized first. So the way it goes is that you garbage collect, you say, hey, are you free? Yes. Do you have a destructor? Yes. Okay, then let me put you on the finalized queue and once you're done with finalization, the next time around that that we go through a garbage collection, then I will garbage collect you. So that means that if you have a finalizer or if you have a destructor, you will always survive one generation. And that might be very important to note, just so you don't like without purpose add destructors to your objects, not even empty ones, because then they will survive 2 collections. But it's still a little bit fishy that it's around, because the finalization, even though it happens only on one thread, it usually is quite fast. So So this is our finalizer. As I mentioned, we only have one. Even in the server case, we only have one of them. And we can go ahead and look and see what it's doing. Because usually, if something is stuck in the finalize queue, it's because the finalizer is blocked. And in this case, it is in fact blocked. It's trying to finalize a link, not necessarily the one that we were looking at, and that called asleep. I just did this to simulate blocking the finalizer. But for example, if this were, I don't know, closing down a database connection or doing something, and then the database didn't answer, that could, for example, block the finalizer. And then anything that needed finalization would not, would just be sticking around until the finalizer was unblocked. So this is a very common issue. Let's see, actually, I'm going to go in here and show you, like so, this is the destructor I'm talking about. Right. So yes, again, quick note, not even empty finalizers, because even empty finalizers end up on the finalize queue. Okay, so that was sort of like all about .NET memory issues, or .NET high memory issues. Just to summarize some of the tools: .NET counters, .NET GC dump, .NET dump, and then if you want to use it in WinDBG, then download WinDBG from the store, and you can then also download the tools or install the tools .NET SOS, so you can use it in WinDBG. Actually, the WinDBG version that comes with the store, I think, actually contains the .NET SOS version. And also .NET Symbols is a nice tool if you want to delve into some of the .NET code and get stacks for it. If you want to read more about .NET memory and want to sort of like dig into it super deep and performance issues, go ahead and look at Maone's document on .NET performance, or .NET memory performance analysis. It's really nice. She's the main developer main architect on the GC. So her stuff is sort of like the huge, really good version of my Cliff Notes that I have on my blog, I should say. Let's talk, switch gears to bad performance. So bad performance, like requests taking too long, high CPU usage, that sort of thing. And with bad performance, we can also reduce it to two very simple questions. What are we doing, and why is it taking so long? Like, those are simply the questions we want to answer in the performance problem cases. I want to show you how you would do this on Azure, because it's not always that you have your processes running on-prem and you can sort of like handle them yourself. So let's go here and have a look. So what you would do in a case like that, where you have a performance issue and it's on Azure, is you would go into, for example, to your app service, and then click on this diagnose and solve problems. And there's a lot of good tools in here that you can use to troubleshoot these kind of things. So go into diagnostic tools, and I think I'll zoom in a little bit so you can see. So in here you can do all sorts of things, like connect profiler traces and memory dumps, and do network connectivity troubleshooting and crash monitoring. So crash monitoring, for example, and proactive CPU monitoring, you can set up that it should take a memory dump when it crashes, or when it hits a certain amount of CPU, etc. All of this, what it actually is, or a lot of this, I should say, this crash monitoring, proactive CPU, and collecting memory dumps, is actually a server version or an Azure version of Debugging. So Debugging is a tool that you can download and use locally on your machine, and it comes in two flavors. First, the Debugging collection, where you can go in and say, I want to capture a memory dump on crash, or on a specific performance metric, so like high CPU or long, well, anything that you can find with performance counters. And you can also inject leak tracking to track non.NET memory leaks, because for .NET memory leaks, you don't need leak tracking. For .NET memory leaks, you can simply watch it in the memory dump, but for non.NET, you can't really enumerate the heaps like we've done now. So it has this for capturing, but then it also has this quite neat thing for analyzing memory dumps. And I say neat, and I feel a little bit icky when saying this, because I was part of creating these scripts. So I wrote quite a few of these scripts back in the day when I worked in developer support. So what these do are, like, as you saw in the memory case, we do the same thing over and over and over again. It's like .NET and like dump heap stat, GC root, dump obj, blah blah blah. You know, same kind of commands over and over and over again. It's quite repetitive. So I wrote scripts to sort of automate myself out of my job in support. So I cringe a little bit when I say they're really good, but I have to say that they do solve sort of like 80%, or they take you like 80% of the way there, which is quite far without having to go in and look at WinDBG or .NET Dump, for example. So I do encourage you still to use them. And they have evolved a lot since I used to work in support. So a lot of these scripts have gotten a lot better since I was there. But these are the scripts and these are the tools that are used to create this. So if we have a memory leak, or sorry, not a memory leak, well, even if we had a memory leak too, we can do that. But if we have a performance issue or something we want to create a dump from, we can then go in and say collect a memory dump, and then we have a storage account that it gets stored to, and we can choose to do with or without analysis. If we do an analysis, then it's the debug analysis that's happening. So we generate a problem, or we reproduce the problem, we collect a memory dump. I'm not going to do that because it takes a little while. And instead, I'm going to show you here how it looks after, like pre-baked. So I've downloaded the memory dump and also the report. So the report in this case, for an issue where it was reported like not responsive, came back like this. So it said it's using 89% of the CPU usage is used by this process. So quite a, like, so it's running at quite high CPU. One thing I should say here is that now this is 89, but the .NET garbage collector has this trick that it's employing, that we don't want to start creating new threads while we're in the middle of a garbage collection. So as soon as we go into a garbage collection, we actually artificially set the CPU usage to 81%, because at 80% you stop creating new threads from the thread pool. So that's just sort of like a gating thing. So sometimes you'll see 81%, even though it's like quite low CPU. You might see that if it's in a garbage collector. And we can, and then it says the following threads are concatenating strings, and it gives you this information about, hey, you should probably look into this. And this was a lab on my blog. So this is a lab that essentially the lab that we're troubleshooting right now. But if we go in and look at one of these threads down here and look at .NET call stack, we can see that we're in products controller, and that's doing a concatenation. Now you might think, so why is a concatenation such a big deal, and why are they talking about this? Well, it turns out that let me see if we can see in here. This process, if we look through the stacks, is in the middle of a garbage collection. And the reason why concatenation is such a big issue in this memory dump is because we're concatenating strings. I'll show you a little bit like how that looks in the code. Let's see, it was products controller. And I think it was, let me see. Excuse me. In the index, so here, get product info. Oh, here, sorry. So what we're doing here is we're grabbing all of the products and then we're concatenating the results together in a string. Now, what the problem is here is that this is fine, like concatenating is fine, as long as you're doing it a few times and on small strings. But the problem is that what ends up happening is this. You have a string that say hello, and then you concatenate, you say hello plus world. This doesn't sort of like continue the hello string. Instead, this creates a completely new string with hello world instead, because strings are immutable in .NET. And the reason why they're immutable comes back to what we saw with how the memory was laid out, because the amount of space that this string can use up is already predefined. It's already picked a piece of the heap, and that's what it can use. So if you want to add even a single character, you end up creating a new object and storing it sort of like last on the heap. Now, this is not a problem if you have very small strings, but if you start having very large strings, so they end up on the large object heap, and you start adding, for example, in this case, only a little bit at a time, but many, 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 many times. We're now maybe creating something like 10,000 strings, which each are used sort of like maybe 20 bytes more. So one that's like 100,000 bytes, and 100,000 plus 20 bytes, 100,000 plus 40 bytes, and so on and so on and so on. And this is literally the most effective way to generate a lot of large objects and thus exhaust the large object heap segments to the point where you have to start garbage collecting them all the time because you're generating new large objects. And what happens when we have to when we're exhausting the large object heap segments? We're creating full garbage collections. And when you start creating a full garbage collection, almost every time you allocate something, especially in a tight loop like this, you're creating a lot of garbage collections, and you're creating a very high, high CPU situation. So you're creating a performance issue for yourself. In my time in support, this was the #1 problem that people would have if they have high CPU and high CPU. So yes, if you, whether you're using Azure or not, feel free to use this debug diag as a free tool, and it will give you like these tips. So start off doing that, then dig in maybe to WinDBG and looking at the stacks and so on. Let's go ahead and go here. Now we're going to look at a slightly different one. In this case, not high CPU in garbage collection, but low CPU, still a performance issue. So let's go ahead and run here, in this case Windows, and I'm going to run this one. Let's see, debug start without debugging. And I just need the command for to stress test it a little bit. So what I want to do is, I've written these like a PowerShell command to spawn off a large number of requests. So in this case, like 100 requests towards this featured product. You can use like some tool like Bombardier, or this tool is on my GitHub. My GitHub is Tess Ferrandez if you want to use this tool, but only use it like for super simple, like repro this problem scenarios. So I spawn that up and I do, I run procdump -ma isexpress.exe to capture memory dump. Procdump comes from sysinternals. I could have also used task manager or something else, but I'm using procdump just to show another type of tool. I could also have used .NET dump collect if I wanted to, all the same. -ma just takes a minidump with all options, so it takes what's normally called a full dump, and it generated it here. And in this case, I'm not going to be using WinDBG. Instead, I wanted to show how it looks if I open it up in Visual Studio. So pick like that, ccolon this dumps, and this. And Visual Studio can also debug memory dumps. You can debug either the native way or with native and managed, but we're just going to pick managed. And as you saw here, it also shows, for example, a couple of things, like in this case, what CLR versions. I'm actually running .NET plus .NET Framework here. So and what DLLs and things are available in here. So okay, I don't want to stop debugging. And then it told us that the current thread is not running anything. The current thread, when you're grabbing a memory dump in hang mode, or like when you're not grabbing a memory dump on crash, is always going to be thread 0, and thread 0 is generally not doing anything, especially in IIS Express. If it was, for example, a console app, then it would be running, thread 0 is the main thread. And what we have here is we have a window called parallel stacks. And this is a stack, or a window that you can also see when you're debugging normally. So when you're step-by-step debugging, you can go in and debug Windows parallel stacks like this. And it tells us that we have 10 threads executing something. They are all in products controller featured, data layer get featured products. And because I'm running this on the same machine where I have the code, and the code matches what I'm running, it can actually also sort of match up my memory dump to my code. And out of these 10, I should say, like, so it's limited to 10. IIS Express limits to 10 threads. by default, you can configure that. 9 of them are waiting on a lock owned by a thread, and 1 of them is in thread sleep. And you can see this also when I clicked on here. You can see that this is represented by, this is the thread that this one is on, and there is also a thread that's on this. So this is a super smooth way, sort of, if you have this this kind of situation where you have a lock or something, and you can easily identify that, okay, so yeah, obviously the one that's in here is now blocking everything else. Even if we weren't in a lock situation, it's nice to kind of go back and be able to see what all the threads are doing. And I really like this whole parallel stacks thing, where it consolidates the parts of the stack that's the same between all of these different threads. So super useful, I think, and very easy for if you're used to Visual Studio. And also, a couple of things that you can see in here is that you can also go in and look at the variables. So if you were to do this instead in WinDBG, you would have to run a CLR stack on all the threads, and to see the objects that we see in here, you would run dump stack objects to see sort of like the stack objects. So it's the same thing. It's just that Visual Studio has simplified it a little bit and sort of made it a little bit more like what you're commonly used to. I would say that I normally go between these and do I would do Visual Studio for my own projects and when I have my own problems, but I would go to WinDBG when it gets a little bit more complicated, when I want to look at native stacks and all of that. So let's go here. So yes, some of the tools, pretty much the same tools, but with Azure Diagnostics, Debug Diag, ProcDump, and Visual Studio. And then I want to finish up with a very, very simple crash scenario. In the crash scenario, yes, the question is always like, what is happening? That's literally the only question you need to answer. And for a crash, what you do is you, instead of taking a memory dump with .NET dump or something like that, which would be quite difficult because you would have to match it like at the exact time the crash is happening. You'll have to do something that waits for a crash to happen and then captures a dump. So you can do that with ProcDump. With ProcDump, it has a -e parameter that allows you to take memory dumps when an exception happens, or with Debug Diag, or in this case with WER, Windows Error Reporting. So Windows Error Reporting, I'm going to leave that up to you to just Google how to set that up. But essentially, once you've set it up, it's a registry flag and a PowerShell or a PowerShell command, either one or the other. Then it will capture the memory dump when it crashes. And I just want to show how that looks here, like a memory dump that's like that. So this is a memory dump of a crash that I picked up with WER. So open, and I see that I'm almost at time, so this will literally take 1 minute to look at. So again, debug with managed. And it picks it up exactly, what the exception was that caused it, where the location was, and you can also go in and look at sort of like things on the stack. So see that code is null, and that's why this process crashed. So, and that was sort of like a whirlwind tour of troubleshooting these kind of issues with memory dumps. And again, if you don't remember anything, remember this this blog, because this is where where you can now be, and where you can now go back and sort of like try it out for yourself, a little bit more relaxed, I would say. So thank you so much for listening.
Martin, you're muted.
And I was just saying thank you to Tess. Damn it, I'll say it again. Thank you.
Absolutely.
Really cool
You're
session.
welcome.
That was very, very interesting. Very lots of low-level technical stuff there. It's great. Lots of juicy things to get stuck into there. Very cool.
Hopefully a tool or two that will help you.
Definitely. I actually have my docking station on my laptop crash every single afternoon at 3 p.m. So I should be looking into, and it's related to a .NET driver, I think, or something close to that. So I'll have to look into that crash dump at some point.
All right. So if you suddenly drop off the stream at 3 p.m., that's why. Is that how this works?
It's exactly how this works. Yeah. And then you're on your own.
There we go. That's fantastic. Anyway, I think we have a few questions.
Absolutely.
Do you want to start, Martin?
Yeah, let's start with probably an easy one. Where can people find all of those .NET dump tools and so on? And if your application runs on a server, do you actually need to install those tools there as well?
Yeah. So where can you install them? .NET install. So is run .NET install counters, for example, or .NET install dump, if you have .NET Core installed.
Yeah.
Yes, so do you need to run them on the server? Yes, for creating the memory dumps, yes, you would need to. Or, for example, if you're on Azure, you can use the diagnostic tools, then you wouldn't have to do it. But if you're on the memory, like if you're going to grab the memory dump manually, then you would have to have the tool where you want to capture the dump. And then you also want to have the tool on your machine to analyze it.
All right.
Is it a good practice? Sorry, is it considered a good practice to have these installed on the server, or is it just kind of something you should do just for the duration of the session that you're looking at?
No, it's not a problem to have them installed. Yeah.
That's nice to know. It's always good to have.
Yeah, and they're quite non-intrusive, so it's fine. And also, for example, .NET counters, that might be something that you might want to sort of like monitor over time too. Like maybe you want to run some sessions on your machine, or like on the server, to see how the counters look. Like it's just to see how it.
Yeah. Cool. We've had another question come through, which was asking about essentially, I guess, how you learn the tools like WinBag and .NET Dump and everything. Some of the commands to those are a bit arcane. You got the .for each command and so on, and the CLR stack and everything. So someone was asking, for example, what was CLR stack related to? Is it related just to a specific thread or to whatever? And so is there a good resource for learning these?
Yeah. So my blog would be one place, but also a much like it takes some time to. So you can also run help, and help gives you all the commands that you can run, and then and a little bit of information about.
Sorry, we didn't have the screen up as you started that. Was that inside .NET Dump?
So we started .NET Dump. Yeah, so you can run help.
Yep.
Great. Yeah, that'll be a help. There's a lot of commands there, a lot of things are available to you there.
Yes. So CLR stack provides stack trace of the managed code.
Yep.
All right.
So I would say that would be the good resource.
Yes, that'll be useful.
Cool. A couple of other questions that came in. And actually one that I kind of share the sentiment with. All of this was after the fact, like you observe a crash or you observe a process going wrong. Do you have any advice in terms of tools and or practices to be more proactive about typical performance and memory issues that you may see?
Yeah, so I mean, I think that like for my own projects, because I already know how to grab memory dumps and things like that, I like to sort of like go in once in a while and you see that it looks like I expect it to look. And then of course, like performance counters is a really good one. So you like having observability in your projects in general, kind of like setting up certain things like trigger alerts if it goes over a certain amount or of memory or a certain amount of CPU or whatever your choice is. But yeah, we're like in our projects we spend quite a lot of time on observability, I would say.
Yeah. And do you think as a developer, it makes sense while you are writing code and while you're building the application to have a tool like the diagnostic tools that Visual Studio pops up with CPU and memory charts?
For
or
sure.
like ReSharper's dynamic program analysis.
Oh, yeah,
and things like that. Yeah.
And I should say, I think JetBrains also has like a .NET memory tool that's, I have to admit though that I've not used it, but that's like a little bit similar to the GC dump that helps you troubleshoot memory leaks in .NET. That's I've heard it's pretty good, but I've never actually used it. I just recently got like the code for to get all the JetBrains tools. So I think I'm going to start using that.
Cool. Yeah. I know. For example, our development team building ReSharper and Writer and so on. They are using .memory, but also .memory units, which is essentially a tiny wrapper inside of your unit testing, so that if you have a memory leak, you can actually retest for it, so that you know that certain objects are removed from memory. And
nice. Like I like that a lot.
Yeah.
Okay, I'm going to write that down.
Things with CLRMD and so on.
Yeah, .memory units are really nice. Yeah, it's a really nice feature because you can do all sorts of interesting stuff, like assert that a certain block of code does not allocate, or that it allocates but frees. That there's a certain amount of memory traffic over a section of code, and so it's good for sort of after the fact debugging to sort of say, I fix this leak and that, but it's also good if you know you're building something which is on the critical path and you want to make sure that the memory traffic is sensible. You just say, right, this is important, no allocations or low allocations.
Yeah,
cool.
No, for sure. And then also there's sort of like, if you're really on the critical path and if your system is sort of like really, like there are ways that you can program defensively and that you can also sort of like use pinning and set up like shards and things like that to help the garbage collector on its way. But it's almost not for mortals, I would say.
Speaking of which, .NET debug, the .NET dump and WinBag, they are very low level, and you can get into a whole load of the internals of your objects and find out a huge amount of information.
In fact, a little bit
would you
scary,
drop
right?
between? You could get everything. But at what point would you drop between what the IDE provides you and what you get from these tools? Where do you think the sort of the line is for that, or is it what you're comfortable with?
Yeah. So for me, I've always had to be in WinDBG because I've never I've always gotten memory dumps of processes that haven't been mine before. So then I always had to be in WinDBG. And for me, like I try to stay in high-level tools as much as possible, but it's like with everything. It's sort of like if you're extremely used to, like if you're not very used to sort of Git, for example, it's much easier to just click and create a new branch and whatnot. But if you're used to it, you're a lot faster in your hands on with WinPG, for example. So
that's a great analogy. I like that one a lot. A Git UI is brilliant, but you can't beat the command line at times as well.
Yeah.
So yeah, I really like that one.
So for Git, for example, I use it for merging. I use UI tools, but for my regular, like I run like git add, git commit, and so on. So yeah, I think it depends on your comfort level, maybe. But also, there are some things that you can't troubleshoot with the UI tools for memory dumps. Like you have to go in, yeah. But then you can always send it to someone else who likes WinPG.
Yeah.
Yeah. So speaking of that one, since you mentioned that you've been working in supports in your early Microsoft days, were there some common problems that you've been seeing that customers were reporting, some usual suspects in applications and so on?
Yes, many of them. Like, so for example, we've seen some of them today, like the high CPU and garbage collector, blocked finalizers, and then there's always like different blocks, maybe blocks that you've even haven't created and so on. So I would say that my set of labs were all sort of like me dumping out all the common things. And I should say that those labs are quite old. So, even though it sounds like it, I'm not trying to push the labs. I'm just giving people a resource, like for, like when I leave, like there's at least some place where you can look and kind of educate yourself further.
Yeah, but these kinds of problems kind of crop up again and again. So it's still very useful to be able to understand what's going on. In fact,
they've been the same over years, like they don't change. Like it's always the same things. I mean, there are variations, and there was a crash caused by this, or like, in this case, the high CPU usage was caused, like in GC was caused by this. But in the end, it's like the same things. Like you troubleshoot them. Yeah, and that's why we automated it too. That's why we went into the whole like creating debug DAG to automate this, because it became boring. Like I was getting like a little bit on the board side of telling people the same things all the time.
Yeah, that report you generated from Azure, do you get the same report back out of that if you do it locally?
Yes.
Yeah.
In fact, I think the one that I showed might have been a local one, but they look the same.
Yeah, that's cool.
Yeah.
Cool. All right, I think we're almost through our questions. Actually, we are through our questions. So it's probably time to bring in the next hosts and next speakers. Again, thank you, Tess, for presenting today.
And thank you so much for having me. I really enjoy this. Now
it was a pleasure.
Session.
Yeah, it was a pleasure. Thank you. It was a great session.
Yeah,
Absolutely.
Thank you.
Thank you
Have
very
a good
much.
one. See ya. Bye-bye.
All right, see ya. Bye. All right, and with that, I will be the person dropping off of the stream, and we'll add Matthias again.
It's not 3 p.m. yet. You can't drop off just yet.
It's 3 p.m. where I live. It's actually past. I wonder why my machine didn't crash yet.
So the answer to this is you've got to run a live stream every day, and your laptop won't crash.
Probably, but I'm not sure if I can maintain that.
All right, well then we will catch you again later, Martin.
Thanks, Martin. Everyone. Okay, Matt and Matt. Let's bring in our next guest, which is Steve. Hi, Steve. How are you?
Hi, Steve. Oh, you're muted at the moment. There we go.
Now you're unmuted.
Now you can hear me. Hi. Thanks for having me.
I think we can't.
You're very quiet right now, so we should try that one again.
Can you hear me?
Only very faintly. No. A few technical difficulties getting everything up and running there.
How about that?
Oh, that's perfect.
Good,
yes,
good.
Miles
For some reason, the sound for my microphone had set itself at a level of 5, which is probably no good.
Computers, it's like we use them all the time, but they're nothing but trouble.
You can leave them perfect, and then you come back the next day, and they just swap things around on you.
Indeed.
Cool. Steve, how are you?
Good, thank you. Very good, thanks.
Great. I've seen. I have to say that. So in Tess talk, there were some pads, and that just increased my attention from 100 to 110%. You said you were giving your slides some enhancements as well. Was that included as well?
I did put some pet. Well, no, I didn't put pets in. I must admit, but yeah, I have tinkered with slides this morning, so it's definitely a brand new talk now in places.
That's cool. That's cool and great to hear. So today we will just continue the performance and memory greatness, I could say. Your talk is called Turbocharged, writing high performance C# and .NET code. And since we're almost on time, I would say stage is yours. Good luck. Have fun to everyone else.
I just want to say that we've just had a comment come through which says, "Let Steve loose."
Oh dear.
It's time.
All right.
Be careful what you wish for, people.
Okay, then let's bring it on. I will remove Matt. I will add your screen. Where's that? Yeah, screen is there. And I will remove myself. So have fun.
Wonderful. Thank you. Good afternoon, everyone. Thank you for those of you that have joined live. It's always nice to have some kind of audience, even though we can't necessarily be in person at all these events at the moment. Quick intro on me. My name's Steve. I'm a Microsoft MVP, Pluralsight author, and engineer for Elastic. I work there maintaining the .NET language client. So if you've used Elasticsearch.net or Nest, you are using the tools that I'm now maintaining and the libraries that I'm looking after. You can follow me on Twitter at Steve J. Gordon. So if at any point after the session you have any questions that suddenly pop into your mind, please do send those to me. My blog, stevejgordon.co.uk, has a lot of what I'm going to cover today in quite a lot more verbose form. So again, if stuff sort of resonates with you, but you miss some bits and you sort of want to go deeper, you may find some posts there that will help you along the way. And I will highlight there's a bit.ly link there on the intro slide, bit.ly/hyperf.net. That will take you to a link with all of the slides and the code that I'm going to show you today as well. So that will help you along if you want to kind of catch up after the event. With that, I'm going to go straight in because there's a lot that I want to cover. So the first thing I want to touch on at the very beginning is what is performance. Everyone may have slightly different interpretations of what this means for their applications, for their situation. So we'll just kind of level set on what I mean when I'm talking about it today. We'll talk a little bit about how we measure application and code performance. That's quite important if we're going to talk about performance. And then I'm going to start introducing some stuff. So the key goal here is this is quite advanced topics, but hopefully from a sort of beginner to those topics level. So it's kind of trying to take you on a journey that I've been on over the last couple of years of trying to understand how a lot of this stuff works, where it can be applied. And that's just come through prototyping and playing around with these features. So some of the features we'll touch on are things like span of T, memory of T. We'll talk a little bit about array pool, system IO pipelines, and system text JSON. So tons to cover, and I will dive straight in. Aspects of performance then, what I'm talking about when I say performance for the rest of this session is kind of touched on by three key areas. So the first thing I'm thinking about is execution time. How long does a piece of code, a unit of code, even a line of code take to execute? What you need to measure depends on what you're doing and your own application requirements. But really, we're talking about how fast the code can actually execute. You know, when that method gets called, how long does it take before it returns to you, that kind of thing. At a higher level, we have throughput, and this is still a useful measure of performance, but a sort of a more realistic measurement that you can perhaps track in production, as well as just measuring it when you're testing. Throughput could be things like how many requests per second can your application handle, how many messages from a queue can you process in a given amount of time. It's kind of a more real-world measurement of what your application can achieve at a unit of scale that you want to deploy it at. And this is obviously going to be linked to execution time. Something that executes more quickly in the code is potentially going to have higher throughput, but that doesn't necessarily match up. There's all sorts of contentions that you may have. It's not just how much time is spent in the CPU, but it could be the amount of memory that's going on, how many objects you have causing memory pressures, I/O for network and files. So throughput can be affected by a lot of things, but it's a good measurement to have not only as you're developing, but also in metrics that you measure with your deployed production applications. And then finally, and probably of most interest to most people, we'll be thinking about memory allocations. .NET is very fast at allocating new objects. When you do new something, you get access to that and the reference back to that really quickly. And so we can be tricked into thinking that there's no real overhead. Unfortunately, there is some overhead later on. All of this memory that we're using in terms of new objects that we're allocating on the heap, at some point in the future, the garbage collector is going to need to run to reclaim some of that memory in most situations. And so one of the things we can do in our applications to reduce the cost of those GCs, which although they're very, very fast and may not pause your application for very long at all, can have an impact at high scale. One of the things we can do to avoid them is by avoiding allocating objects in the first place. And then that leaves us in a situation where there is nothing for the GC to collect. And we can also run the applications potentially on smaller memory footprints, smaller container images, that kind of thing. Of course, performance is contextual, and everything I'm going to show you today is kind of for the extreme end of the 1% cases where you might actually need to do it. So I'm always conscious of making sure that people don't leave this talk and immediately go and spanify their whole code base because Steve showed them it in a talk. The tools are there, and it's worth being aware of them and understanding when and how they can be applied. And then deciding when to do that is kind of down to you and your applications. You know, do you have something that has to scale in a huge way that could potentially be optimized? Have you got a process in your business that takes a long time and that costs you money, costs you customers in some form? Do you want to go and optimize it? So for your situation, you need to decide if applying high performance techniques is right for your app. And there's a real important trade-off when you get into performance. So the trade-off is between performance and readability. The more performant code, as we'll see when we get to the more realistic examples later on, the more performant code tends to be more verbose, more tricky to read, more tricky to maintain. And that's a cost that you need to balance up in your own business as well. If you've got an application that's being regularly worked on by lots and lots of developers, you probably want that code to be self-explanatory, easy to read, easy to maintain, easy to test. And so erring on the side of readability is a good practical decision for your business. On the other hand, you may have an application, maybe it's a microservice that's built, it does one thing, it's already doing it well, so you're unlikely to go in and tweak it all that often, but it has to scale a huge amount to be able to keep up with load. Well, perhaps that's a situation where you can trade off the readability and the ease of maintenance of that application for looking at optimizing it, making it more performant to get a cost benefit on the other side of the coin. So this is the trade-off you need to sort of play up in your minds. And this is why performance is really going to be contextual to your situation and your applications. So I want to touch on the optimization cycle that we're going to be covering today. And the first most important point is before you do anything around optimization, measure your code. Measure it at the high level, so profiling your application that we'll touch on in a moment, allows us to understand, you know, what are the hot paths in the application? Where is the memory pressure? Where is the memory allocated most? What methods are called most often? They're the areas that if you are going to optimize the code are probably where you should be focusing first. So measure, profile, understand the application performance as a whole, then go in and measure the code that you're planning to change. And by measure the code here, I'm talking about benchmarking. Take a benchmark of how the code performs today, make your change, optimize the code, and then measure again. And do this in very small increments. Don't optimize huge swathes of your application in one go. Go in, change maybe 1 or 2 lines, apply an array pool, the span of teeth feature where it's applicable, and then measure again to validate your assumption is correct. Does that actually, in this situation, in this code path, make the difference you hope it does? If it does, great, continue. Otherwise, maybe roll it back and try something else. Ultimately, this is a cycle that you will keep doing until you either reach what you think is the absolute performance that this piece of code can do. Maybe you get down to 0 allocations and you're pretty happy. Or you might get down to a point where you think, well, actually, we've halved the execution time. That's what we were aiming to do. Let's move on. So be practical about how much of this you apply and for how long you keep applying it. It can be a bit of a kind of continuous dream to chase the 0 allocations. And in some situations, that can be a bit of a fool's errand. So think about how you're applying this. In terms of measuring app performance, there's a few tools that I recommend. So if you're a Visual Studio user, the diagnostic tools is a good starting point. These tend to boot up these days when you start debugging automatically, and they give you a bit of a profile of the memory as the application's running. Now, remember, you aren't on release build code, So there are optimizations that may be missing from your code for the debugging session to function, but it's still a good view and an idea. You can see if huge allocations occur as you're testing the app, as you're debugging through it, and maybe then focus in on those more closely. To do full profiling, you really want to be profiling the real release build of your application in as real an environment as you can give it, and with as real a load as you can give it. So Visual Studio has really good built-in tools now for profiling. They've been extending that from release to release. If you really want deep, low-level, high-grain control over how you profile and what you collect and what you analyze, Purview is a really amazing tool for doing that. It's extremely difficult to get started with, in my opinion. I've not really stuck with it in any sort of great shape. So my preference, and it's not just because I'm a JetBrains event, is the .trace and .memory tools. These are the ones that I landed on after trying all of these, that I found to be the best balance between, they gave me the features I needed. I could figure out how to use them and track my way through the user interface. And ultimately, it led me to the paths on my code that I wanted to optimize. So use whatever you have, use whatever you feel like doing. As I say, Purview is free. Visual Studio stuff is included. The JetBrains products you may already have as well. Other stuff that you might touch on, and we won't really go into this in the session, is ILSpy or Just Decompile or .peek. These are tools that let us look at the intermediate language. So when we compile our C# or F# code, we end up with IL. And the IL is this intermediate stage that later on gets just in time compiled into the machine code as you're running the application on its actual environment. And sometimes by looking at the IL code that's produced by our C# code, for example, we can see issues that maybe things like boxing, maybe virtual method calls, maybe just the number of instructions that we see it generating with our code, and we can tweak our code and see if we can optimize the IL and ultimately hopefully optimize the reduced code at the end of the just-in-time compilation. Not going to need it for all things, just pointing out it's there and it can be a tool in your arsenal. And finally, don't overlook the importance of production metrics and monitoring. These are the thing that you probably want to get in place first, because you want to know, are the changes that you're testing locally and thinking are improving things, are they actually resulting in improvements in production? So what is your memory usage in production? How long does certain key parts of the application take to perform? Have those measurements first, and then you can show that you've actually optimized when you get to production. And most importantly, you can see if you've regressed anything. I work for Elastic. We have an APM product for .NET that you can go and use, plugs into .NET applications and can start profiling them and collecting metrics and monitoring information as they're running. So that's an option. There are many products out there as well. We're also going to be talking about benchmarking quite a bit in this session. And for that, we're going to use benchmark.net. So this is an open source library, primarily for micro benchmarking. And what they mean by micro benchmarking is small units of code. You might be benchmarking at the method level. Sometimes you may be benchmarking at individual lines of code. You generally won't be benchmarking huge blocks of your application that trundle through many methods. You can do, but more often you're tending to look at the really small, fine picture of individual pieces of code. It gives really high performance measurements. It does this by ensuring that it takes measurements after warming up your code, so it's pre-jitted and it's in its kind of final state. It does measurements of its own overhead, so it can remove those. And it does many thousands of iterations of most tests, so that it can benchmark each of your benchmarks in its own process and give you a really good statistical count of how long those methods are executing, down to sub-nanosecond measurements that are really important for individual lines of code. There's lots of ways you can configure it with things called diagnosers. We'll show one of those as we go through the session. And you can use it to compare performance. So if you're deploying your app to different architectures or in different environments where you maybe run different platforms or GC modes even, you can see how your application performs in the benchmarking under those different settings as well. So that's really useful. So you can go get that from benchmark.net.org. And it's used extensively by the .NET team themselves. So the .NET runtime team, the core CLR team, and the ASP.NET core teams all use this in their products to optimize them and give us the performance that we see from release to release. And they leave some of those benchmarks in place and they track them over time. They run them much like you would a unit test to see how performance trends over time. And if they see a regression after a pull request is merged, then they can make sure that that doesn't make it to release. So here's a really simple example. We have just a console application that we're looking at here, and we're looking at all of the code for the app. So the way you get started is you pull in benchmark.net from NuGet.org to your console application, and then we set up our main method inside the program class. And all we're doing here is calling the benchmark runner.run method and passing it a type that contains our benchmarks. Now, there are other ways you can have it detect benchmarks in this assembly. For now, we're just going to use the simplest form, but it's very configurable for different needs you may have. And then here is our class that contains our benchmarks. I've attributed it here with a memory diagnoser saying to benchmark.net, as well as measuring execution time, I want memory information. I have some setup code. This is all done outside of the benchmark itself. So I'm going to be benchmarking a method call on the name parser. I'm not interested in the overhead of creating the name parser or the string that I'm going to send to it, but I'm interested in the call to one of its methods. And that's what we're doing in this final block of code here. I have a simple method. It has a benchmark attribute so that benchmark.net knows this is a benchmark. And in there, I have the code I want to test. So here I call parser.getLastName and pass in the full name. And this will give me the results that I'm after. So you run benchmark.net. You need to run it in release mode. It will sort of basically stop and fail if you aren't. And then it will eventually give you this output. So it's going to take a while to run each benchmark, because as I say, it's going to do it many thousands of iterations in most cases. It will give you some output. Sort of here it's showing us this was run on .NET Core 3.0. It's an older test that I have. And more importantly, we get our results per benchmark. So here we can see that the execution time of that method was 163 nanoseconds. So we don't know really if that's good or bad, but it's our starting point for an optimization journey. If we feel it's necessary to optimize this, we know our starting point. Because we added the memory diagnoser attribute, we have a few columns now related to memory. These Gen 0, Gen 1, and Gen 2 columns show the estimated number of collections per 1,000 operations in each of the generations of the garbage collection process. So what we can infer from this is everything is falling into Gen 0. It's not living into Gen 1. So the assumption here is that all of our types that we're allocating are short-lived. And we can see, because of this very low number and the fact that this is per 1,000 operations, that it might take around 26,000 calls of this method before we'd introduce enough GC pressure for a collection. It's not a guaranteed number. There's a lot of heuristics that go into GC collections, but it's a good starting point. And then finally, we have the bytes allocated. So this is the thing that most people are looking at, how many bytes were allocated on the heap when this method executed. So one of the tools that we're going to look at about optimizing code today, and the one that we're most kind of keen on, is span of t. So normally when I do this event in person, in front of an actual human audience in a real room, I can ask them to put their hands up if they've heard of span of t. So imagine you're doing that now. I can't see you, but let's imagine. The last time I did this in a real event, I think there were around 1,000 people in the room, and most people put their hands up at that audience. So most people had heard of it. When I asked to keep their hands up if they were using it, pretty much everyone put their hands down. So that was a good sort of sign that many people were not using it. And that's correct. That's the response I'd expect from many of you. Span of t has been publicized really well by Microsoft because it's a key type that they've introduced that's given them the ability to make the .NET runtime and ASP.NET Core so much faster, and to get them at the top of the kind of tech and power benchmark results for things like requests per second in Kestrel. So it's an important type from that perspective, but they do tend to prefix all of that information with, you shouldn't need to do this yourselves. This isn't a type you'll probably be using in your code. And that's generally correct as well. I tend to not be quite as cautious as they are. I think it has its place for use in some code bases, not just library authors, but it is an advanced type. It's built into .NET Core 2.1. So any of those versions after that, you've got this type available to you, and you've got a runtime that's optimized for it. But it can be installed with the system.memory package. If you're using .NET Framework, it has a net standard compatible package that you can use as well. The core idea of span of t is that it's going to provide a read-write view over a contiguous block of memory. And the interesting thing about it is it's kind of agnostic to what memory you're looking at. It gives you the same API regardless of whether we're accessing heaps, allocated memory, something that's on the stack, or even unmanaged native memory. So contiguous regions, we're talking about things like arrays, strings, because those are single blocks of memory that we can kind of look at with this view. And you get access to an indexer. You can iterate through the items in this span of T, and you can modify them. It's mutable access to those memory regions. So if you've got an array of integers, you can affect the values of those integers through the span. It has almost no overhead compared to raw array access. There is a marginal thing, but it's very insignificant, and the overall gains of avoiding allocations generally outweigh any risks of the overhead at all. The key operation that you'll hear about when you talk about span of T is slicing, and this is where we adjust our view over that contiguous region of memory. So in this example, I have a new int array of a length of 9. So we create the array, and then to get a span view of that, we call as_span, and that returns to us a span of int. Span of int is, span itself is a specially designed type, and it will never be allocated on the heap. We'll come back to that. But the important thing is that by calling this method, we're not causing any allocations. We're just getting a span that has a view over existing memory. So the only allocation is the creation of the array in the first place, which generally has been passed to us from somewhere. On that, we can call slice. And slice takes a start and an optional length. In this case, we said we want to slice from position 2 to a length of 5. And that gives us this new view over this internal region of this array. We get back a new span that points to that adjusted region, and we can then work with that span to further manipulate and parse through the data that may be in there. The sort of analogy that I like to use for this is that of photography. So most people have taken a photograph with a camera phone. Some people may have DSLRs and telephoto lenses. If you're out in the countryside, you want to take a photograph of a really nice landscape, you go ahead, you set up and you take the photo. If something in that frame takes your interest and you want to see it more closely, you have kind of two options. You could walk to the object, which might be trekking across a number of fields. It might take some time. It might take some energy. It might get your boots muddy. It has an effort involved in it. The other option is that you pinch zoom, or you twist your telephoto lens and you just zoom in, and you get the closer view of the object that way. And that is a really quick operation. And slicing is like that because slicing is a constant time, constant cost operation. Regardless of how big the original array is, it's 9 elements here, it could be 9 million. The cost of slicing into it for any length is the same because it's just creating this very simple, lightweight, non-heap allocated type that references a pointer of that in that memory. So it's a very light overhead, regardless of your original array. So let's look at optimizing some code. The demo here is a little contrived. We'll look at more realistic scenarios and code in a moment, but I just want to bed in the idea of this span and also the idea of kind of the optimization cycle. So the requirement we're going to imagine, very real world, I promise, is that we need a method that takes some array from somewhere, and we want to return a quarter of its elements, but starting from the middle. I'm sure you deal with this day in and day out. But it's a good example for the point of understanding the core concept. So given this scenario, a lot of you are probably already coding this in your head and thinking, well, maybe we'd skip to halfway in, and then we'll take a quarter of the elements and we'll return that array, and then we've done the requirement. And this is reasonable. I mean, there's edge cases to this code, but it would work in principle. So imagine we've done this, we've deployed to production, and then a manager comes to us and says, actually, we've realized that this code and this application really needs to be fast. If we make it fast, we get more money. And so we go, great, okay, well, we're now going to go and optimize this code. So here we are, we're back in the first important phase of measure. We know what we're aiming to optimize. So we've already essentially profiled the app, but now we want to benchmark our code to understand if we're going to improve it. So this is a slightly more complex benchmark class than we looked at before. Let's step through the changes. The first thing is we have this size property, which has this params attribute with 3 values. This tells benchmark.net that for every benchmark it runs, we want it to run 3 different times with these 3 different sizes set in this property. And this gives us the possibility of testing outliers and differences between our code base. So while you want to test your common case, let's say that's 1,000 element array is common in our scenario, we want to test the outliers as well, because some changes you make might optimize code at one level, but then you could see a massive degradation on different sizes. So we'll test at 100 and 10,000 either side of our normal average to give us a bit of an impression as to whether our changes work across all scenarios we expect to encounter. We can also set up benchmarks. So this global setup will run once per benchmark. We mark it with the global setup attribute, and all we're doing in here is initializing an array of the appropriate size. This will be our source array that we pass into our method. So that's done. We can now write our benchmark, and this is the simplest form we can do. We're using an expression-bodied method here. We have the benchmark attribute applied. This time we've marked it as baseline. This is our first test, and this is the original code. So we'll say this is our baseline from which we will compare all other results. In this scenario, we've got our skip and our take and our to array, and we return an int array. So pretty straightforward. So we can run our benchmark. So the results here are probably not that surprising. A small array of 100 elements is 154 nanoseconds, 224 bytes. And then this increases as we go to 1,000 and 10,000. And you can see this scales quite considerably each time because we're multiplying by 10 the original input array. So the output array is growing as well. So the thing that we're actually creating as a result of this is getting larger and larger. And that's an obvious side effect of how this code is designed right now. Now, the first thing that we might think of, we might be thinking, we're smart here. We know that skip and take and link expressions have some overhead. So shall we avoid those and see what we can do instead? So we'll create a new array of the appropriate size. Then we'll use array.copy to copy from the old array to the new array in the appropriate places. And then we will just return the new array. And we've avoided link. So we run the benchmarks and we see the results. And we say, oh, OK, our mean has gone down quite considerably. We win. Allocate on the end there, 128 bytes, nearly half. That's pretty good. Now, the reason we've tested with different params is because we don't want to assume that that one result is always going to be totally accurate. Let's see the next one. OK, so we're still quicker, but the bytes allocated is nowhere near as drastically. It's not halved, that's for sure. What we've actually shaved off is about 96 bytes, and what we've really shaved off is the cost of the compilation of the link expressions under the hood. So we have removed some overhead, but not quite as much as we thought. We're still allocating a new array each time we call this method, and that's growing as our input data grows. But the final thing we can do is we can try span-based approach here. So the reason this test isn't entirely fair is that I've decided to return a span event here. So I've made an assumption about this scenario that the caller can actually accept back a span and continue parsing through that span view of the memory to achieve its goal. If they really need a new int array that they're returning, then we're a bit stuck. But in this scenario, we'll assume that returning a span is a valuable return type. And so we can call as span and then slice to get the data that we need. So in this result, the time taken is now under a nanosecond. I think we'll agree that that's a pretty good gain. And we've allocated no bytes at 100 elements. So that's also really good. If we look at 1,000, we're still sub 1 nanosecond. We're still no bytes allocated. 10,000, sub 1 nanosecond, no bytes allocated. Constant time, constant cost operation. Slicing, regardless of that input array size, does not change on how long it's going to take. On my machine, when I measured it, it's around the 9.9 nanoseconds. And we haven't allocated anything because all we've done is narrowed our view over existing memory and return that view back to the caller. So again, it only works if the caller in this example can do something with it. But in more real-world applications, the application of this across your code can be quite significant. Now, we can also use spans over strings. So we can call as span on a string literal, on a reference to a string. And what we get back is a read-only span of char. So char, because a string is ultimately just a sequence of char characters, and a read-only span because strings are immutable. And so the compiler enforces this rule that we can't return a read-write span view over that memory region because that memory region is still accessed by the string, and we'd be mutating a string under the hood. And that would really mess with a lot of your other code. So to maintain the fact that strings should be an immutable type in .NET, you can only get a read-only view over them. But this is still valuable for parsing through those strings. So in this case, imagine we wanted to get the sort of last name out of this string. So again, a trivial way of doing this would be to look for the last index of a space, assume that everything thereafter is the surname, and then we just slice from that position. And then we have the data that we need. So then we can do some further parsing on the string. There are some limitations to span, and these are just important to be aware of because these will come into effect. So it's a stack-only value type. It uses this keyword ref struct, which means it's a struct that starts off and only ever lives on the stack. it can't ever end up on the heap for any reason. And so that requires that we have C# 7.2, which gives us the refstruct keyword. And it also means that anything that is a span or uses a span can't be boxed. It can't be a field in a class or a non-refstruct, because those fields are part of the class on the heap or could end up on the heap if the struct gets boxed. It can't be used as an argument or a variable inside async methods. This is probably the big one a lot of people run into. We'll see how to combat that in a moment. The reason for this is that the state machine behind the scenes that gets built when your code compiles is going to be a struct, or it's going to be a class, depending on where you're running this code, and those could end up boxed onto the heap. So it would break the rules above. And similarly, if we capture it inside Lambda expressions, that creates a closure class that we don't want to have as well, because we break the rules again. So the way around this is we can use this type called memory of T. Fundamentally, it's very similar to span, but it can live on the heap. It's a read-only struct, not a ref struct. The reason you wouldn't do this just as default is it is slightly slower when you're slicing it. It's not as optimized as span. You can call span on it, or get the span property, though, to see a span over the same data, and we'll work out why that's useful in a moment in this example, actually. So here we have an async method, and we'd love to pass in a spanner byte that we do something with. The compiler is not letting this happen. We're breaking the rule of having a parameter here that's a span inside an async method. So we're going to swap to memory of byte instead, and we can now slice and work with that data if we want to. If we really want to optimize, then in realistic terms, in most async methods, they're async for a short period of time when you're maybe going over the network or to a file or waiting for some I/O to happen. But then the actual processing of the data that you're getting, you can kind of do synchronously. And so what you would typically do is create a non-async method that does accept your span, and then you would pass that in from your async method. Now, you can't do this, which is declare it as a local and then pass it in. But what you can do is just pass this in this way, and the compiler knows how to handle this. Or similarly, we just pass in the raw data .span and then work with it inside the main method. So this is how you get around that sort of async limitation. So let's put all of this into practice, and I'm going to kind of jump into some code now reasonably quickly. You can go and check out this code yourself if you want to, but the scenario, actually, let's show you the scenario before I show you the code. The scenario here is that we're going to read messages from a queue, SQS on AWS in this case. We're going to deserialize the JSON message, and then we need to store that message somewhere into an S3 blob store. To name that, we need an object key, and we're going to derive the key from properties of the message. So here's the original code. I'm just going to step through it very briefly. We have this source event context. This is just the property that contains the data that we have here that represents what we're getting in the message after we've deserialized it. We're going to say that we're going to use 4 or 5 elements for the key. It's optional. If the event date is there, we're going to use it. Otherwise, we'll just use the other properties we know are definitely present. And we're going to create a string array of the appropriate number of elements. We're going to call this getPart method, passing in each string for the parts that we want to use in our key. And getPart down here is this fairly straightforward method that says, if it's null or empty, we're going to use a constant unknown value. But if it has a value, remove its spaces using string.replace here to remove spaces with placing with the underscores. And then we're going to check it's valid with this is part valid method, which is just using a simple regex pattern. And then we're going to return the value. These get stored into each element of the string array, including the date if it's present by calling its toString method. And then ultimately, we are going to use string.join to join those pieces together. And we want them lowercase, so we call toLower to finish off. So this is the original starting point. Here's the new code, and we'll again briefly step through this. You can go and pull this down and have a play around with it. There's some optimizations here I'm not going to even worry about. It's a weird compiler optimization that avoids a mem copy. The key stuff we're going to look at is this is a little longer than the last code, probably 2 or 3 times the length. So more complex code. Fundamentally, it's quite similar to what we have before, though. But first, we're going to calculate the string length that we need. Once we've got that length, we're going to allocate some memory where we're going to use as our working buffer. So to be really optimal, we're going to say if we're under this value here, 256 characters, we're going to stack allocate a character array for this. So we're not going to heap allocate any arrays. And we can use stack alloc without the unsafe keyword here because we're returning it as a span of char. And this is, the compiler knows that this is kind of memory safe because the span can't outlive the stack allocated memory it's going to reference, because it is itself only going to ever live on the stack. It can provide these type safety and memory safety guarantees. The fallback, which is unlikely, is if we can't allocate on stack because it's too large, we'll create a character array. The reason for this code is really be careful with stack alloc. Just because we can doesn't mean we should. Allocating large amounts of memory there could cause a Stack Overflow exception in your code, and then you'll end up on stackoverflow.com trying to work out why. There is a finite amount of memory there, so make sure you use these bounds checks before you use it. Then we're going to build our string parts. So the way we do this is we pass in the source string that we're using, we pass in our span, which is our working buffer, and our current position by reference. And that ends up in this method down here, which ultimately what we're going to do is similar to before, but now in an optimized way. We're going to first check if it's essentially 0 length or all white space or empty. Then we use unknown. Otherwise, we're going to check if it's valid, but not by regex this time. This time we'll just use iterate through the characters and see, are they a letter, a digit, or a space? If so, we're good. Otherwise, we're invalid. And in the case where we're valid, we're going to use this new memory extensions .toLower invariant to copy the input value into our output span by slicing it at a current position. So we're going to keep slicing our way through the span as we write into it, so that we're always incrementing and appending to the end. And that's fundamentally it, really. For the remove spaces, we're now using the index of to see if there is a space. And only if there is, we're going to keep looping through until we've got rid of all the spaces. And at each character in the indexer, we just replace that with an underscore if we find a space. And we can do this because we're not working with a string yet. We're working with a char array on the stack that we can later convert to a string. And we do that at the top of the code here. So after we've done our building of our method, we add the date using this try format here, which again is an optimized version that takes a span as the place to write the formatted data. And ultimately, then we call this toString method. So we do allocate here where we call toString, but the rest of the code is optimized. So the thing you're probably really keen on is how much of a gain did we make? And here we are. So the original code took around 1,000 nanoseconds to run. The span-based approach is over 2 times quicker, pretty good. The allocations are also a little bit more significant, actually, almost or around 6 times less allocations, 192 bytes on over a kilobyte in the original code. Now, you might say that this isn't worthwhile. Less than a kilobyte of savings for this string allocation is probably not worth it, but this is processing from a queue. And this particular service does 18 million messages a day. So if we calculate that saving up, that's over 17 gig of daily allocations that we reduce just on that code path, just with those optimization techniques. So at scale, these things can have a gain. And this led to the fact that we can potentially run this service on smaller container instances in our cloud. The next thing I want to talk about is array pool. We'll do this reasonably quickly. It's pretty self-explanatory. In situations where you need an array repeatedly, you should always try and reuse the array. So if you're doing stuff in a loop and you can reuse the same array, great. But sometimes we're doing stuff that's going to be sort of concurrently accessed. So maybe in an ASP.NET Core application, we have an action method that gets called by all sorts of threads, so as different requests come in. In that scenario, we can't reuse the same instance because that's not going to be thread safe. But what we can do is use a pool of arrays to give us a fresh array each time we need it that we then return back, so that we're not allocating new arrays each time. We're just reusing arrays as we can from the pool. It's found in the system.buffers namespace. It's really easy to use. You get an array pool of T, whatever sort of type you need. You access the shared array pool generally, and you rent from it with a given length. In this case, you are likely to get back an array that's bigger than the length. And the reason for this is that array pool needs to buffer in different buckets those arrays. So it couldn't give you any size you ask for each time you ask for it, because you're unlikely to need the exact same size each time. So it's going to say, well, I'm going to put an array of 16 and then a bucket of 32 and 64, all the way up to about 1 million, doubling each time. And it will give you the closest, smallest array that is in the pool that's available. So you will likely get an array that's bigger than what you need, and you need to track your position within that as you're working with it. When you are done with it, you return to the shared pool, optionally clearing the array. So by default, the arrays are not cleared. Be aware of that. When you rent from the pool, you may have data in the array. So again, it's important to know how much you've written into your array if you're using it as a buffer, so that you only ever access that portion of the array when you then do some further work with it. To use it, fairly straightforward. So this method gets called really, really often, and it needs a temporary buffer, maybe to do something like read from a stream, perhaps in a real application. So in this situation, it's allocated a byte array of 1,000. But what we could do instead is rent. So by going to the array pool of byte.shared, we get the array pool. We rent from that an array that's at least 1,000 bytes long, and then we do something with it. To ensure that we are returning it, we make sure that regardless of whether we have an exception or not, we return this thing to the pool. So typically we use this with a try finally. Inside the finally, we do our return to the array pool of our temporary buffer. Next up, system IO pipelines, another one that I'm going to plow through so that we can see the actual code. So the reason this was originally created was the ASP.NET team were working to improve the request per second in Kestrel. Kestrel is the ASP.NET Core web server. It's doing a lot of network IO. That's all its job is, to listen to requests as they come in and pass them through into ASP.NET Core. The team, particularly David Fowler, realized that they could optimize Kestrel and avoid using streams for all of the transport layers, passing off through this thing called a pipeline instead, which basically optimizes the code. And for their scenario, they saw around a 2x improvement. You could achieve this with streams, but it's a lot of work to do it. Pipelines makes it a lot easier. And basically, it just removes boilerplate code. And the main difference is that unlike streams, what pipelines does is it manages the buffers for you from the array pool. So we're already getting the advantage of the fact that where with streams, we would create a new array and pass it in as the buffer for the stream to use when we're reading or writing. With the pipelines feature, we don't do that. It gives us blocks of memory that we work with. And there's two ends, a writer and a reader. Write, we have the pipe writer we call get memory, which returns us a memory of byte. Memory here because this is almost always going to be inside some kind of asynchronous method because we'll be reading off of a network file, a network socket or a file. So we get memory of byte because that's safe. We write into that however we want to. We could convert it to a span in a non-async method as well. But when we're done, we just advance by however much we've written and then flush it. And this says to the pipe, okay, I've written 1,000 bytes and they're ready for the reading end. The reader sits there with this read async call. So it's a non-blocking asynchronous wait until there's some data in the pipe. Once there is, the callback gets activated and we get back our read result. From the read result, we access the buffer, and the buffer is this read-only sequence. Why a read-only sequence, not the memory that we put in? The reason is because the pipe in advance doesn't know how much data you're going to give it. Some requests may be huge, some files that you read might be larger than others. So the pipe doesn't know in advance what buffer size to use. It just allocates a buffer, and once that's full, it will allocate another buffer. And it keeps track of all these in essentially a linked list. So we have these buffers spread across memory in their own little contiguous blocks, but not one contiguous block. But this gets represented to us as this read-only sequence, which is this linked list of these memory regions. So now we can access our way through the sequence that way. I can show this in action. So we have another scenario that I used to work on where we read an S3 file, which was tab-separated format. We decompressed the file and read 3 columns from each row and then indexed that data into Elasticsearch. And we wanted to optimize the reading of the file. So if I jump back to the code example here, the original code is actually really short. It fits pretty much on a whole, well, 2 screens because I'm on a massive font size. We read the file, we decompress it, we access the memory stream, and then this original code was calling toArray to get all of the bytes in the decompressed stream. In order to pass that in to get a string on UTF-8, so to get the encoded string. Now we have a full string. It was passed into this this library here. So this code is using a library called Tiny CSV Parser, which at least at the time needed strings, I think, to work. So once we have that string, it ends up in this parsing logic. And the key bit of this is that in parse, that library gives us this really nice way to say, okay, split each row on the new line character. That's a line of data. And then when you're mapping from each row, find the values at each tab. So the tab 0 is the date. And then tab 1 and tab 10 are the 2 other fields that we care about. Everything else we don't care about. So that's the original code. It's pretty self-explanatory, and you could read through and understand what it's doing. The new code is a lot longer, but it's fundamentally the same idea. So we get the decompressed stream. At this point, I use this connector to access that stream using a pipe. So at this point, usually streams are still going to exist in somewhere in your code, but you can convert them to a pipe reader at an appropriate point. So here we pipe reader create, and that gives us the reader. We then read async, so a non-blocking call here until there's data on the pipe. Then we get the result buffer, and we call our parse lines method here, which is highlighting the wrong thing, comes down here. And all this is saying is essentially, give me a sequence reader, so something that knows how to make parsing through those sequences easier. Try read to any on that sequence reader, takes the thing that we're reading to, which in this case is the byte that represents new line. So keep reading until you find a new line. If you don't have it, exit the loop and wait until more data becomes available. So we just avoid telling the pipe that we've read anything in that situation. We've read it, but we've not consumed it. We want it again so that later we hopefully have a complete line. And when we've got a line, we parse into parse line here, which is ultimately now using a span to look over that byte data as we have it. And we're just counting manually when we see tabs. So we're looking for the index of the tab character, or the first index. And we know that the first tab represents data that we're going to want. So we now do need a string at this stage because we're going to create an object that has the strings that we're going to send to Elasticsearch. But using this range here, we can say, give me everything until the first tab character, because that's the data we want. And then it's going to move on. So down here, we're just going to slice the line and say, right, move to the next section. And then we locate the next tab, and then we grab from there. And similarly to tab 10. After tab 10, we don't read the rest of the line. We know we've got the data we want. I know I've scanned over it quickly. We can go kind of, as I say, you can go and look at this code yourself as well to try and get a feel for what it's doing. But the concept is pipe readers and span usage there. So let's see the advantage this gained. So the original code was out 8.5 seconds. Not bad we're actually testing 75 files with 10,000 rows here. 8.5 seconds is not too bad. We got it down to under a second. Great, go us. The key thing, if you look at these allocations in that original code path, every file we read was read into a stream. It was then converted to a full byte array, just in order to convert it to a full string that represented the whole file. Then it was parsed. And there was obviously here 7.2 gig of allocations because of that. The new code, 242 meg. It still sounds high, but that's 30 times less than what we had before. And 203 of that are the string allocation costs of the actual strings that we do want, that we need to create the objects that we index to Elasticsearch. So this is a good gain in our scenario and something that's potentially worth doing. Some of the last stuff I want to look at then is looking at system text JSON. So these are new APIs that were introduced in .NET Core 3.0. You might question why Microsoft have introduced their own APIs. There was a long discussion about it. Ultimately, James, who originally wrote Newtonsoft JSON, wrote a blog post. He now works for Microsoft, to be fair. But he wrote a blog post explaining that this is a good thing. We need a JSON library ideally in the box so people can just use .NET and access JSON. And secondly, there's a lot of optimizations that can be now made if you redesign how JSON deserialization works, taking into account all of these new types and optimizations that we have. Going back and retrospectively doing that to Newtonsoft JSON without breaking the world would be quite painful. So this is in the box with .NET Core 3.0 and greater. There's a low-level set of APIs that we'll look at in a moment called UTF-8 JSON Reader and Writer. This is for raw writing of data at the very low level, which means you can avoid most allocations. And we'll see how that works in a second. For reading data, we can also use this middle level JSON document, which is a sort of document object model representation of the JSON that we have that we can then work with. This, for certain sizes of JSON data, under about 1 megabyte, I think, is essentially 0 allocations in the way it works. And then the normal high-level types, JSON serializer and deserializer, are typically what you'd work with. They sometimes still more performant than Newtonsoft JSON was, but they're not as good as the low-level stuff. And you can pitch your code as to where it's appropriate for what you're building. So the last scenario I'm going to show you is, imagine a situation, well, we had a situation in my old job where we were indexing data to Elasticsearch. We were using the bulk index APIs to do this, which means we can send about 100 documents a time, I think, or maybe 1,000 we were doing. But you can send a single HTTP request to index lots of documents. And what you get back as your response from that index request is JSON that tells you how long it took, were there any errors for any of the documents, were just a kind of yes, no, and then an array of all of the sort of metadata about each item that was sent in. And that basically gives you the error information if it's present. Now, when we were processing this, we realized that actually in 99% of cases, the request was succeeding, but we were fully deserializing the whole response in order to figure out if it succeeded, because we just wanted to know, true or false, was it a success? So we looked at optimizing this code. So I've got the original kind of code here. Again, it's a simplified form. This does actually fit on one screen, even at this huge font size. Basically, reading from a stream, we're going to use, in this case, it's Newtonsoft JSON, so we call it its deserialized method. We want an instance of bulk response from the data from the reader. And once we have this response, we can access this. This is the object representation of it. And you can see that we're going to have these two properties, how long it took and were there errors. And only if there are errors, or if this is true, would you need to inspect this collection. And as I say, we probably don't need to do that a great deal of the time. So in the happy path, the 99% case, we can just say, well, if there's no errors, that property is false. We're going to return true, success, and return back an empty string of IDs. There's no errors found. Otherwise, we figure out which IDs were actually the failures by inspecting all of those elements, and then we can return the errors. The new code is over here, is considerably longer. I'm just going to scroll for effect. I know that won't show up very well on YouTube. It's a lot longer. It's a lot more verbose. It's harder to maintain. So again, use with care. This one uses an array pool. So I rent an array. In this case, I know the maximum size because this is demo code, but I'm renting an array of the appropriate length of bytes. We're reading, in this case, from a stream. We could use pipelines here like we saw in the last demo. But in this scenario, I'm using my array pool buffer so that I'm not allocating the buffer each time. I'm using the pooled version. And once I've got that, I'm going to read some data. I then call into parse errors. And what this code is going to do, you can see it has this horrible signature where we take a read-only span of byte, the data that we've read from the stream, and all of these ref balls and things. These are basically my state that I could wrap up into a more formal object probably. Ultimately, though, what we're going to do is we're going to access the low-level UTF-8 JSON reader, which is re-entrant. So you can say, have I got the complete JSON data? So have we read the entire stream? If we haven't, we can actually just keep calling this method time and time again. And my own method here is also re-entrant by passing these state variables in. We can keep reading until we've consumed the stream, but we don't have to wait for the full stream to start processing. So that's one advantage. So we have the reader. We're calling read on there. And when it returns, when this eventually returns false, it means we've read to the end, which means we're on the final block. We've seen the final object bracket. So we've read to the end. So if we've read to the end and we've detected the errors property in here, or until we detect the errors property in here because it's a while loop, we're going to keep looping through. And what we're going to access is the JSON token. So each read pulls back the next token. And you can see at this level, we're having to inspect, are we at the start of an object? Are we at the start of an array? Have we found a property? And this is the interesting one. So if we find a property, if the value of that property is sequence equal, so we're going to do a span-based check here, to the errors property name, so the bytes that represent the word error or errors, then we know we found the errors property. This means, because I'm tracking my state, that the next time I come through this read loop, the next thing I'm going to read is going to be a Boolean value, either true or false. Have we got errors? And if it's false, then we know that has errors is false. Otherwise, we know has errors is true. So we're reading the data until we get to this property, and then we're going to break out of the loop, which returns us back up here. And then after we've done our parse, we now have this found errors property. So we know, have we found the errors property? Did it have errors? If no, we don't read any more JSON. So what we're actually looking for is in the first 20 bytes of JSON code is the actual answer. In the 99% case, that's going to be false, and we don't need to read the rest of the JSON array at all, the JSON data at all. In the unhappy path, yes, we still have to keep looping, and eventually we're going to find each item and find the ID out of it. And you can see how that code works if you want to. Again, it's not production code either, so use with some care. So what are the results of doing this? Well, let's assume the failure scenario first. So in the case where there were errors and we had to read through all of the JSON, then the original code was 428,000 nanoseconds. It's down to a third of that in time. Again, not huge numbers, depending on how often this is called, maybe useful, maybe not. But we have quite drastically reduced our allocations here. So 114K down to 16K. A good start. I mean, I know certainly that could be further optimized in the code that I've written, but it was a good sort of proof of concept. The scenario we're interested in, though, is the 99% case that we've indexed the documents and they all succeeded, which is generally true for our situation. And so in this scenario, where we do get a has errors false in that first few bytes of the file, you can see now we're down to only 485 nanoseconds. Because we read from the stream, we read those first 20 bytes, we parse them through our UTF-8 JSON reader, we find that it's false, and we just stop. There's no more work to do. When we've short-circuited a big chunk of code. In the previous example with JSON.NET, we've deserialized the whole JSON response, regardless, just to find out if that property is false, essentially. And I know there's ways we could have optimized that with Newtonsoft JSON as well, but in this case, System Text JSON gave me even further gains. Allocations practically zero. I think I figured out where that 80 bytes comes from, actually, when I was going through the code earlier. I do allocate a list at one point. I should reuse probably an empty list and an immutable list for the happy path, and then we'd probably get that down to zero. So a pretty damn good gain, I think. So I appreciate I've shown you a lot, and I've shown you a lot quite quickly. I do have a habit of trying to pack information into sessions. So do rewatch it if you missed some stuff. Do download the code and take a look at it and understand what it's doing. But one of the important things that I want to leave you with is, great, I now know I can do this. How do we actually start doing this in our business? How do we get people to allow us to do this cool stuff? The first thing is, obviously, think about whether you should be doing cool stuff. You might not need to for most of your applications. But if you have a scenario where you do know that there's a cost in terms of compute power for scaling something, or something is taking a long time and it has a potential cost impact to your business, if you could improve your business by getting results faster to whoever needs them, think about those types of scenario and think about the code that's behind those processes. Go in, identify a quick win in one of those. So grab the code, profile it, find out where the hot path is, find out where the most time is spent and the most allocations occur, depending on what you're trying to improve. Use a scientific approach for that. So, use a good profiling tool like, .trace, .memory. Use benchmark.net to measure the piece of code that you've then identified on the hot path that you have a suspicion could be improved. Get your benchmark, optimize it, and then once you've established what gains are possible, go to the business by putting those gains into monetary value. I think we all know that if we went to certainly a senior management position, a non-technical manager, and said, I can save, 200,000 nanoseconds on this code path, and it's probably going to save, 1,000 bytes of allocations, they're probably not really going to care or understand what you're trying to tell them. So figure out what the monetary value is and establish a cost to benefit ratio. So do this as a prototype. Do this as, time box an hour, a few hours to try these attempts. Once you've done that, your cost to benefit ratio could look something like this. So the process I used to work on was this one microservice. It was handling 18 million messages a day. The techniques I've shown you today, all of them are part of a set of prototypes I made based on some of the work that needed to do. Not all exactly the same, but the ideas are there. And then what I did was figure out, okay, based on these examples, my best guess is that I can probably get to about 50% of overall allocations. And I can pretty much assume I'm going to double my throughput based on, my early execution time improvements and then throughput measurements as I'm doing the work. So I had a sort of a rough idea of my potential gains. And then instead of going to them with that, I sort of said to the business, well, I've done some stuff. I think if we applied it, this microservice will actually need to be scaled less at high throughput loads. And that's one less VM that we need to scale onto. So by avoiding that one less VM across the year, the size we were using, around $1,700. Now, you might question, is all of this effort that I've just shown you worth $1,700? Probably not. Your developer time may be higher than the value you're saving. But obviously, year on year, this game will get you there. And if you're building something like microservices, as I was, a lot of the techniques I saw could be applied not on just one microservice, but maybe tens or hundreds. And so $1,700 can start pushing into the, or maybe 17,000, maybe more. Those are numbers that the business might be more interested in. And you can apply the same sort of techniques across, for example, key reading, very common problem, parsing the JSON from it, very common problem. Maybe some of your techniques would be good if they were applied there. Ultimately, what I'm saying is that scale matters here. So a single microservice could save you a little bit, but can that be scaled across your code base? Or is it a critical service that, shaving the execution time or increasing the throughput gives you a benefit? So lots and lots of stuff to digest. We will have a time, hopefully, for a few questions. But in summary, if you're doing performance optimizations, you should always be measuring and not making assumptions. Assumptions are really dangerous. Don't do it. Everything you should do should be backed up by profiling and benchmarking before, during, and after your changes. Be scientific about how you make those measurements. Benchmark.net is the perfect tool for scientific, accurate, repeatable results. And you can even keep those benchmarks as part of your CI process that run on each check-in to see if your code continues to maintain the performance you expect. If you're optimizing, focus on the hot paths. It's really easy to get sidetracked by something that looks like it's a big problem, maybe allocating a huge byte array. But if it's only done once at startup, optimizing it's not really worthwhile necessarily. When you can, and in your situation you're optimizing, one of the quick gains is not copying memory. So not copying between arrays, not keep copying off streams into different buffers. Spanity is a really good way to avoid that and just change the view over existing memory, parse your way through it till you find what you need, and then you can work with that reduced data set without having copied everything. Where you need to, and you're using arrays, array pools are a good example of way we can easily reduce allocations with very small code changes. Pipelines, great tool for I/O scenarios. If you're doing that kind of work regularly, go and look at it. It's probably more niche, I would say, than most of the things I've shown you today. And system text JSON, they do perform better in a lot of the tests I did. Measure it if you want to try it, apply them, but prove it with numbers as well. One thing I do recommend is this book, Pro.NET Memory Management by Comrade Kokosa. It's a good book. I've got it here because I just want to illustrate the sheer size, weight, beefiness. It's over 1,000 pages of high performance goodness. It explains how memory works in computer terms, in .NET terms, and then how to optimize for it. It's a great book to carry around. It's good exercise. It acts as a weapon if you're attacked at night, and it's full of good information. So I really do promote it. It's where a lot of my initial research that I've used in these prototypes came from. Ultimately, I'm going to kind of say thank you. We'll hand over to questions. Just a reminder, the bit.ly link there, highperf.net, will get you all of the stuff I've shown you. So if you've missed things, you can go back and get them, and feel free to reach out if you're watching the recording at DJ Gordon on Twitter. So with that, I guess we can probably go to questions.
Great. Yeah, we can. Thanks, Steve. That was great.
You're welcome.
Both interesting.
No, that was a fantastic session.
Partially mind-blowing too.
I want everyone to leave the day partially mind-blown.
And it's always good to give some self-defense tips as well. So thanks for that one. Right, we have some questions.
Yeah,
we have some questions we can just jump straight into. First one, the object key generator example you were showing there, and in fact, some of the examples you're showing there, they're quite extreme. There's quite a few changes going on compared to the original version. You also mentioned with the object key example that it could save gigabytes of data. So was that one actually a production example?
That did end up in production. Yeah, so the prototyping was the early phase, which is kind of what the code I've shown in here because it's a little bit more constrained. And then we kind of shored that up. So another key tip that I probably didn't mention is have unit tests around the code you're about to optimize. Make sure that after optimizing it, the code still does what you think it should do. It's very easy when you start getting into like spans and looking at sort of byte arrays of data that you miss something and you garble the whole output. So yeah, unit tests first is really important.
There were a couple of comments in the stream as well that maybe the regular expressions might help you as well there. So if you're dealing with regular expressions, unit tests are also going to be helpful with that too, I think.
Sure. Yeah. Yeah. It was a slightly slimmed down, contrived example of the whole thing, but yeah, definitely something that we put into practice, and we did actually reduce the scaling and the memory usage of our container instances that one went into.
Yeah, I got to say as well that that's actually I think that's a great way of getting across this sort of performance thing here. Is coming from like a techie background, like we probably do, the people watching this stream. It's very easy to want to improve performance just from a technical point of view. Better performance is obviously better. Or if you've got an interactive UI, like obviously we do with some of the IDEs, then again, performance is obviously better. If you've got a server scenario, sometimes you don't always see that. And so looking at it from a cost point of view as well is a great idea. It's a great idea for getting the buy-in to be able to, to have the permission to do the refactorings in the first place. But also to show that there's a real benefit to doing this, not just because we think it's cool.
Yeah. And the approach I took with this was very much, lunchtime hacking to say, okay, I've learned about this span. What do I think I could apply it to? Okay, here's an example, and sort of try a few things out. A lot of that's good fun, and I encourage people to do it. And as I stress, doesn't necessarily mean that everyone should be throwing this type of code out to production tomorrow, or anyone in the near future. Use it all with care. But there are certainly good situations that we found to apply it in certain microservices in particular.
I have a great performance tip: return null or just return. Yeah, I'm just kidding. I also have one more question, actually two, but in between, Matt. We have one question, which was, you mentioned not to use span of T in your own code base. Would you recommend using it if you're building libraries and frameworks for others, or is it best to not expose them?
So certainly Microsoft do advocate its use across library use cases. You want your libraries to be good, they're likely to be installed by lots of people, and more performance for free is a good thing. It's certainly one of the things I'm focused on now at Elastic in the .NET client as we move that forward. What can we do? Much like the runtime team have done at Microsoft, much like ASP.NET Core have done, we just want people to upgrade to the next version, and suddenly we're allocating less. And that's kind of, I think, a good practice for most code authors of libraries. Do you have to expose those APIs publicly? Sometimes yes, sometimes no. So a lot of this stuff you can keep internal, and you can make the gains in your own code where it's controlled. But some libraries, like JSON parsers, maybe you write a YAML parser or something, you might want people to be able to pass you a span of bytes or a span of characters as an input to your methods that you then process. And that avoids them having to allocate potentially an array just to pass it to you as an argument to your method. So what the runtime team have done, and what I certainly would look to do as a sort of library author these days, is as overloads that accept these things. So where you take a byte array now, it's good to accept a span of bytes, and then you have some common internal code that then uses whichever it's given, which is generally going to be very similar code, because you can call as span on the byte array that they parse you as well. And then you've basically got comparable code internally.
Yep.
Cool stuff. Sort of, I guess a follow-up question with some of the production code you're talking about there. Are you happy with what you've got at the end? I mean, obviously, saving some money is going to be a good thing, but that's not all you've left with. You're left with a different set of code base you've got now, and so on. So you're happy with, and you talked at the beginning about trade-offs between performance and readability. So are you happy with where you've ended up with this?
Some of it, yes. Some of it, no. I've moved on from the company now, so I don't know what fallout occurred after I left. But
ship it.
I do know, I did speak to one of the developers that I used to work with, and they did have to tackle a small change to one of the services I'd gone in and optimized. And they were not as happy as maybe I would like them to have been about this code that they had to try and work out. So it's definitely true that, by doing this, you are making a decision that should be assessed a relatively senior level within your team. Is this something we want to do? Is this a trade-off and a burden that we accept as a result of taking this high-performance code on? So certainly, I think probably I got a little overzealous with all the stuff that I was able to do. But certain services, I know they're still operating that way today. The benefits were worthwhile. Some of it they may well have adjusted so that it's more maintainable. So definitely assess up front where you can apply it. You need to do that sort of analysis of what can we save, and how often are we likely to have to manually figure out what this code is doing again, because it's very hard to maintain those much longer methods, those much more condensed pieces of code. It's much harder to kind of parse that in your brain when you're trying to pick it up again.
Yeah, there's a lot to be said for familiarity of knowing what you've already got with your existing code base, and then changing it up for these kinds of things. And yes, it's very easy to get a bit overzealous when you first start with these things. I remember making a bit of a mess with some RX back in the day, which I had to go back and fix at a later date. Before I left, they made me fix it because nobody else wanted it. Yeah, but yes.
I have one more question, which is, do you have any practical tips for performance measurement on networked services?
Not a huge amount. It's something I'm starting to think about at the moment, funnily enough, as we're writing a library that's doing pure HTTP. For the most part, most of that work is still going to sit on top of Microsoft libraries. So let them do the hard work, run on top. If there's a good library in the framework for doing HTTP or doing what you need to do, most of the time it's best to stick with that. If you're really down at the raw level, I've been using Wireshark recently to capture TCP and HTTP packets and understand a little bit more about some of the actual networking overhead of some of the stuff. There's some good stuff as well. I think Tess was showing it off. The .NET counters feature is a great way now with .NET 5. You get counters around how many DNS calls are being made, how many HTTP sockets are being used. So you can go and attach to a running .NET process with the counters and get an impression of networking use at that level. And then something like Wireshark's quite good for really low-level packet analysis after that. But as I say, try and stick to the built-in stuff. I know Microsoft are doing work around a low-level HTTP client that I'm watching extremely closely. Those sort of gains are the sorts of things I would look to do rather than rewriting my own HTTP library, for example.
Understand. Would something like telemetry also fit into that category of?
Yeah, I would say for all of this stuff, having telemetry in production for as much of it as possible is key. So, if you can track how many network sockets are open from your app when it's running in production, how much memory you're using on the heap, how many garbage collections are occurring. Certainly, those were metrics I tended to put into these high performance services so that we could track those over time. We could look for regressions. We were pushing almost daily to some of these during early development. We could see if we were improving or, as I say, degrading performance on those. Always have those. I think it's very easy as well. Some of these techniques, you might improve the stuff on your local machine. It works on my machine, great, ship it. Having the telemetry in production is also key to know that, yes, what was running great on, say, a Windows box, now when it's deployed as a Linux container in a constrained environment, still has the same advantages that you first saw.
Yeah.
Okay, I think another quick question. Is there a repository or blog where I can see before and after comparison with optimizations as you've just shown? So I know that your bit.ly link there, the highperf.net, Martin's just posted that into the comments. So if you want to find that, you can. I'm not quite sure what was on that link there. Do you have any kind of examples in that, or is that the slides?
So most of the slides kind of lead you up to the code samples. The actual code repository is there that shows you those before and after classes of the things the benchmark should run on your machine, and you can kind of tinker with it. As I say, it's demoware. And a lot of the stuff that I've shown is on my blog as well. So if you kind of search performance as a tag on the blog, you should find posts about most of what I've shown there, the usage of span, the usage of rape, all that kind of thing.
Great. Speaking of benchmarks as well, you mentioned running your benchmarks as part of CI. Does benchmark.net have the ability to kind of to break your CI if things are if the performance is degrading there at all?
Yeah,
is that built in, or do you have to add that yourself?
It's not necessarily built in. I know colleagues of mine actually at Elastic had been working on a package that could take the output from benchmark.net as part of the CI process. It's basically a set of XML files and things that you could interpret. I haven't tackled it yet, but it could certainly do so. I mean, my theory is maybe we could run them as GitHub actions. The challenge with CI for the benchmarking is you want your benchmarks to run on a consistent environment, and you don't want other things running on the machine you're benchmarking on. And so ideally you want to spin up an identical VM or something each time. And even then, you could have differences between runs, different, subversions of the VM that you're getting given by your hosts. And so that's the challenge I've yet to work out. So Microsoft, I know, do this, but they have a whole benchmarking environment that's sitting there running warm all the time, and they can run continuous integration on that, knowing that that environment is not, changing from run to run, and then they can get the consistent results. So my theory is GitHub Actions isn't going to solve it for me, and we might have to think about our dedicated VM under the hood for that. But it can be done. I just haven't done it yet. But you can check what Microsoft are doing in some of their repos and see if there's any examples in their kind of build area.
Sounds good. Thank you.
All right, cool. I think we are out of questions. We actually have a couple more on our list, but we should bring in our next guest. Steve, thank you from every one of us, from our team.
Thank you very much
for being here, and it was really interesting listening to you. And see you around, right?
Thank you. Thanks for having me.
Thank you.
Okay, and our next guest is going to be Olena. Hello.
Hi.
You're
Yeah. Yes, great. It's pretty hot, to be honest, in Berlin, so I'm like sitting and trying not to move too much. But yeah, I'm great. What about you? How it's like amazing conference. How is it going so far?
Very pleased with it so far. It's been brilliant. So great.
Good. I'm just glad we don't have the weather from yesterday, which you have today, I guess. Me being in the south, because today, hotter is, I don't know, not so pleasant. All right, but getting into things, you're going to talk about going real time using Azure CosmosDB and React. Is that right?
That's correct. That's my presentation.
All right, good. Since we're on time, I would again say we will take it away from here and leave the stage for you.
Okay, thanks.
I put your screen on.
Awesome.
And remove Matt and me, and have fun. And good luck to you.
Thanks a lot. All right. So first of all, once again, thanks a lot for attending my session and welcome. And my name Olena Borzenko. You can find me on Twitter. If you have any questions or comments, please feel free. Don't hesitate to text me. And a small introduction about me, what I'm doing, my company. I'm senior backend engineer in a company called Deuce Express. It's a beverages delivery service based in Germany. And currently we are in process of merging with another company, which used to be our main competitor on the market because they are doing the same business. So as a result of this merger, a decision was taken to build a new warehouse system. And basically the idea for this talk was born out of my daily work, as I'm part of this team, of the warehouse team. So as we implementation is going further in our new system and we are getting more and more requirements, we had a lot of discussions what kind of features we might introduce later on in our system. And I decided to take the already kind of the structure more or less we have and try to integrate other Azure features in it and see how it works. So that's what I want to share today. And before going into technical details, I want to say a couple of words about the warehouse system itself, so it will be pretty clear what I will show during the demo. So the warehouse, it's just a box, that's kind of a reality of the life. It's just a buffer between the supplier and our final customer. And there is, of course, the whole science behind it, how to build a nice warehouse system, and even how to build the physical building, how it could be structured, and so on. But there are some kind of fundamental things which exist kind of in any warehouse. So the first of all, it's movements, as they drive all the physical processes inside. You want to know where's your current products, what's the amount of products, how they are moving inside. And based on this information, if you're able to track all those events, you will be able to easily calculate at least two things. Of course, much more, but we will have an example. We will see the example of two things. The first of all, if you have the right amount of stock. So what it basically means that we want to know if we have a right amount of products, not only in like positive numbers, like physical items in there, but if we lost something, if some products were maybe broken, maybe missing during the transportation, maybe an accident happened or whatever. So we want to be able to see all those reports, like how many items we sold, how many items do we have, and what happened with the rest. And having all those events, basically the history of everything that is happening in warehouse, it will be really easy to aggregate and get this information. And another thing is if our stock is basically in the right place. And as I said before, the structure of the warehouse could be really complicated. And for example, you can have a 3-zone in a warehouse where your products, like fast-moving products, mid-moving products, and slow-moving products. And depends if your items are in the right place, it has a great impact on efficiency and how those items are delivered to a customer. So this is really important to know the state of your warehouse, what is happening on your physical locations. So while we were like discussing all those details, like how all this should work, how we can track all those movements and later on calculate all this information, we kind of after some time decided to try Azure CosmosDB. As we already saw from title, we will like work with this a bit more later on. And we decided to use CosmosDB, and we got this idea that it will be really easy to use it if we will also have Azure functions. So every time when there is a movement happening in the warehouse, like employee coming to the crate of products, scanning it and moving from one place to another, or maybe if it's automated warehouse, the robot will move those items, we will call our Azure function and we will save this information in CosmosDB. And all right, so we have a persistent data store. Now we have all our information, and what next, like how we can calculate it. Like usually with the traditional databases, I will just like write some queries, I will start pulling data out of it and do all those calculations. But CosmosDB has an amazing feature, which is called change feed. Maybe some of you already heard of it. The benefit out of it that using different Azure functions, for example, or other ways, you can pull the data out of it, or you can subscribe on a specific containers and listen to every change which is happening inside your CosmosDB. So we decided that we will introduce a couple of Azure functions which will listen to a specific container, which is in our case movements container. And every time when there is a change happening, we will update the state of our warehouse. So we will generate materialized views with information of what is happening on our physical locations. And also we will calculate a stock. So we will find out how many articles do we have and where are they located currently. And later on, we will save all this information back in CosmosDB, but in a different containers. So while we were designing this part, it was like initial step, basically. I realized that this is really, really flexible because as like Lego bricks, you can take all those Azure functions, you can combine it and like build different functionality for different part of the systems. And I'm really big fan of Lego, as some of you might see on my background, I have quite a lot of cars. And I really like when it's like when you have this flexibility and simplicity of building it, and also find out that I'm quite lazy of writing a lot of code. So every time when I can just take and use something, I'm really happy out of it. So the next step, logical for us, as we already have all this information, we want to have a stock monitoring. Or if any of you ever been to any warehouse or maybe worked in any product company, there's like it will be a usual thing to have many different dashboards like monitors where you can see how many orders are coming in, or how many products do you have, or how many cars are available or employees are available to do some work. So for warehouse systems, monitoring is a really important part. And I was thinking like how we basically can introduce this monitoring functionality easily, not creating, you know, some like bicycles or whatever. So as we saw in the previous structure, like we already had this step when we knew how to calculate our stock. and also like to know the state of warehouse. But taking like this small piece, like what else can we do, how we can then like show all this information in real time, or just like give those updates pretty often, so the information always will be current. So I decided that I will just do exactly the same thing as I did before. I will subscribe on a change feed for the different container, which is stock per location in this case. And because Azure functions have a lot of like different bindings and triggers, we'll get to it a bit later, I can easily connect to Azure Signaler service and send my messages there, and they will be broadcasted to any of my clients. So basically, the result was like playing around with change feed, Azure Functions, CosmosDB. What we achieved that we can create many different materialized views and show exactly the information our like employees or like maybe our clients want to see on a specific dashboards, not mixing all this and not overwhelming with the information like specific screen. So that was really great achievement for us. And I also found out that it's like super simple. Again, I can take already what I did before, just combine it in a different way and achieve completely different result what I want. And this is simple because every other developer which works in the same system will recognize the patterns. Okay, I have a change feed, and again, I have an Azure function. So this will be kind of a building blocks, and the only information which will be new for our developers is business logic itself, because the rest is the same across the whole system. So as I said already a couple of times, CosmosDB and change feed, I also might realize that not everyone used to work with this. So I will use a couple of minutes just to say a bit more about change feed itself. So the CosmosDB has containers, and we can compare it as like normal tables in, like, for example, Azure SQL. So those containers, they will have documents. They will save the documents with our information, and we can go in there and update document or create more documents. But the change feed will save all those events, every write or update operation, as a separate document. So we will have a complete log of everything that is happening in our system from the very beginning. And the great thing is that we can also consume all those events from any point of time or from very beginning. It's up to us. And there is a couple of ways how we can do this, basically. So we saw already that we can use Azure functions. What we can do also, we can implement, if we cannot, for example, if you don't like Azure functions, if you don't want to use it, we can also implement change feed processor using change feed processor library. We can do this on our own, subscribe to a specific container and listen to changes. And every time when there is a write operation or update operation happened, those changes, those events are going to be pushed to us, and we can handle them in the way we want. But of course, in this case, you have to do a bit more work because you have to deploy it and handle like all the other things. So another way is you can manually pull all those events from change feed. And this is like, I would not do this for the everyday work. If I would need to migrate all my data from CosmosDB to another data store, I will definitely go with pool model, because then I can extract all the events and process them in the event I want. But this is really complicated way, because in this way you have to handle everything: the state of the change feed, the exception handling, the way how you like deploy it. Everything is on you. But it's also really useful model how to consume those events. And of course, because CosmosDB is part of Azure, you can do a bit more with this. So as I already said, you can trigger an API on every update or insert. So you can use Azure functions to do something, or Event Hub to process those events. And also you can do real-time stream analytics. So as I started to work in the warehouse, it's not new that usually like a business might request some numbers, reports, or like tons of reports. So it means that you, at some point of time, you will need to do some heavy aggregations. And because CosmosDB is not exactly it's not exactly for those like heavy queries and those aggregations. So there are some built-in functions, but I would not do this to build a report, for example. I was looking into other potential solutions, and I found out that CosmosDB has a connector for Apache Spark, and you can do real-time heavy aggregations, which was a great thing for us. And as already mentioned, a zero downtime migration of your data in another data store, as for example, Data Lake or CosmosDB as well, or maybe Azure storage blob or table. So it's just like, I just wanted to give a general overview on CosmosDB and change feed, because this is kind of important to understand to understand it later, how it will generate some movements and how we'll see those real-time updates. And going back to our Azure functions, like because we will use them quite a lot, I want to also make it clear that Azure function itself, it's not an independent unit. The function up is the independent unit of development and deployment. And inside this app, you can have many different functions. So I would think of it as a different method or endpoints in your regular like application, and the function app itself can be represented as a microservice. So the function app can have different triggers and bindings. And today we will have a look on the combination of some of them, and we'll have a look how the HTTP trigger and CosmosDB trigger works. And also we will have a look how the CosmosDB input and output bindings and SignalR input and also output bindings works. And just to give a bit of also understanding, every Azure function can have only one trigger. It's no matter which one, like if it's like HTTP or Cosmos, but only one trigger. But in the end, you can have as many bindings as you want. If you have input binding, it means that data will be pulled in at the start of execution of your Azure function. And if you have output binding, your data will be pushed out in the end of the execution. So I want to give a couple of examples how we can combine those triggers and bindings. And we will have, during the demo, we will see in total 5 different Azure functions. So the first one will be, is to create a movement. I will just generate random movements so we can see how the real-time works and the creation of those materialized views. And for this, I'm using HTTP trigger and CosmosDB output binding. So what it basically means that I will, with the output binding, I will use the database named warehouse and a collection name or otherwise container, which called movements. And then I will build my some test data, and I will add it to async collector documents out. And when my Azure function will finish execution, it will push automatically this data to CosmosDB. When this data will be generated and pushed in Cosmos, we have another Azure function which will react on those changes. And this function will calculate our stock. So I will subscribe on this on the same container as before, on the movements container in warehouse database. And every time when there is update happening or change, I will this Azure function will be triggered, and I will do some execution in it. As I will transform my data, I will build the materialized views, and I will save it back to Cosmos. And because I want to be able also to receive this information from my client, I'm using HTTP trigger and CosmosDB input binding. So when I will trigger this function, I will receive everything what is in stock per location container. And we will see later on that there will be 2 more lines of code to log some information and basically return the whole collection back to the client. So writing those Azure functions, I realized that I'm writing much, much less code. So even in this last example, I will switch back. To achieve this, to pull the data from database and return it back, in a normal application, I would definitely need to have some repository level. I will access my database, I will pull all the data, maybe I will map it, because I have my entities, and then I will have data transfer object or whatever. I will map it, and then I will return it. And with Azure function, I basically use 2 attributes and 2 more lines of code to return all this data. And this, first of all, saved me a lot of time, and I don't need to write all this infrastructure. I just wrote it like my business logic, and I was able to start working with this right away. And let's do basically a demo, and let's have a look on how those Azure functions actually implemented. So as I said before, we have a create movement function, and I'm using the output binding for this. This one, like documents out. So I will generate some test data on here line. And as you can see here, there's nothing special is happening. I just have my test data, which is basically hard-coded. So I'm generating a model, I'm returning it back, and I'm adding this to my collector, async collector. So when my Azure function will finish execution on this line, those data will be pushed automatically to CosmosDB. And here I will just specify the amount of items I want to generate because it's kind of random. And to calculate our stock, as I said, I will use the trigger to react on any changes. And another thing I want to mention here, what I can do in this case, I can also specify another binding here for CosmosDB, like output binding, which will be exactly the same as here, but with different container name. So I can also insert this binding here, and when I will finish creating of materialized view, just save those documents, and I will be done. But I just wanted to show that there is another way. You don't have to do this always with binding. You can do this in a way as you like. It's just that you will need to write some code to actually connect to your CosmosDB. Like I need to specify the container name I want to use, get my database, and get the container I want to work with. And then I can do basically the same operations. So I'm checking if I already have materialized view or not. I'm doing some business logic, and I'm saving my data in CosmosDB manually. So it will happen in the middle of execution and not in the end of execution of Azure function. And get storage location, as I said before, just 2 more lines of code to log some of the information I have and return basically everything what we pulled from this container. You can do a bit more with that kind of bindings. You can also specify an ID of the document, and it will basically, if you know your ID and you know, for example, partition key, it will return you only one document because it will be point read. And beside this, of course, I'm always losing my mouse from time to time. Besides ID and partition key, you can also specify an SQL query if you have no idea like what exactly you want to get, but you want to get a collection of items filtered, maybe sorted. You can also do this in a query. I personally am not a big fan of writing queries, especially in attributes, because it does look like magic for me. But I just wanted to show that there is many different ways how to work with those bindings. And at this point, let's go back to a presentation and have a look on the another Azure functions we can have and what we can do with them. So as we calculated our stock and we were already able to write some movements, what we can do as well is to build an Azure function to return some information which needed for our client to connect to Azure SignalR service. So in this case, I'm using HTTP trigger and SignalR input binding. So it will pull a service URL and access token, and it will return it back to our client. So it will be able to establish a connection through a WebSocket and basically receive some messages. And another Azure function, which we'll also see later on, is with CosmosDB trigger and SignalR output binding. And in this case, I want to notify my client every time when there is a change happening in my stock. So I would use this function for this monitoring application where I will have a huge monitor in my warehouse. And every time when there is a stock change happening, I will send a message and I will display it in those monitors that we sold some items or we received some more items. So that's basically the idea why I want to have this function. And to see how our client could communicate with like Azure Function Signaler in general, just one more time, we will see this. This will be our React application. We will see it a bit later. So what I will basically do, I will send a request to my function app, to my I will have a URL of my function app, and I will send a request to API/negotiating point to receive information about Azure Signaler service. And once my client will get all this information and establish connection with Azure Signaler, I will be able to listen to some events when I will subscribe to them, of course. And every time when the change will happen, I will have another Azure function, as we saw before, which will be connected with the output binding to my Signaler service and will send the messages there. And once they are received, they will be broadcasted to my client from Azure Signaler service. So this is basically the structure how they can communicate between each other. And to have a closer look in the code, I will use a Signaler package for like JavaScript clients, and using Hub Connection Builder, providing the URL to my function app where I know that I have this negotiating point, and starting my connection, I will be able to establish like WebSocket connection between client and Azure Signaler. And after that, on the same connection I will be able to say, I want to listen to a specific event and process my event like with function or action, whatever I will have. So it basically looks super easy. You can just you establish a connection, you say on a specific event, do this thing. So in my React application, we are really close to the second part of the demo. I will use React, of course. And another thing, maybe not everyone is familiar with, it's a Mobic state tree library. This is an alternative for Redux. I use it because it helps to organize the application state in very, very structured manner. And I do like to use it because, first of all, it's super simple, especially for small applications or like internal tools. It speed up like development process significantly for me. And I will just name 3 reasons why I like to use it, and we will go to a demo part. So first of all, I do like it because it has centralized stores of my data. So I have an object which contains the description of how my data will look like and how it can be mutated through some actions. And then there is another section which called views, is basically if my component want to have my data transformed in a different way, I would not do this on the component itself. I would not mutate my data or change it or reorder or whatever. I will do this in the centralized place. I will maybe format my data, and I will allow my components to consume it. Another thing is that data is easy to use, but it's protected. So you can mutate your data. It's mutable, but it can be mutated only through specific actions, again, in this centralized store. So you will have a section with different methods, and your data will change and components will be re-rendered only if you will do this through those actions. So I like going from a .NET Word. I really like it because it's kind of like some encapsulation of some of the functionality. The simple assignment would not work, and I would expect this behavior because when I work on backend and I assigned my data, I don't expect it to change in database directly. So I would expect the same behavior on a front end, that if I just assign my data, nothing will happen. But if I will go and call like specific action, then my data will be changed. And this is what I really like about MST. And it has a built-in support for references, so we can easily normalize our data across the whole application. So we basically have stores, and we can inject them in the components or each other and reuse them. So demo part, the second part of the demo, I want to show again those 2 Azure functions which I haven't showed before. The one will be used by our client to receive information about Azure Signaler service. And here we will have Signaler input binding. And if you need more information except hub, because we will send messages to our client will establish connection with a specific hub, basically. Every time when we will send message, we will need to send it also in the same hub so our client can receive it. If you will send messages to a hub with a name like general, our client will not see it because it will be subscribed to a hub with the name warehouse. You can also provide here a bit of more information like ID token or user ID, climb type list. Like if you need a bit of more security, more functionality, you also can do this in here. And when your client calls this endpoint, it will receive all the configurations needed to establish the right connection. And stock change trigger, as I said before, we will react on changes in the stock. We will use this input documents we received, and we will send them using Signaler output binding. So we will generate the messages, and we will send them to Azure Signaler. I will use an event name called stock per location changed, and we will see that in my client, I will be subscribed exactly to the same event. And talking about client, let's then have a look how it's implemented on a client side. So as I already said, I will use a Signaler package with a SNET/Signaler. And using a hub connection builder, I'm providing a URL to my function app where I know that I have this negotiating point. And I'm establishing a connection. So I do have a bit of more functionality, like how much time do I need to retry? What if I, sorry, what if I lost, I need some water. What is going to happen if I lost my connection, and so on and so on. So this is one method which will establish the connection between my client and Signaler service. Another method I have here, which basically will create a subject for me. So it will be, I will be able to observe it like from multiple places, and it will return a stream, an observable stream, where I will be able to subscribe on a specific event. So this is not a subscription on the event itself, but just a stream, and then I can subscribe in a place where I want to do this. And as I mentioned that I'm using Mobix state tree, this is basically the syntax how you can specify it. So you have an object and you have the model. I don't have any model in my socket object, but I do have those actions. And every time when I want to do something, I will call the connect to socket or get stream action. So I have another store, which is called home store. Because I will have only one screen, this is basically the only place where I have any kind of logic. And I have an action here and method called after create. And this is an event which will be automatically triggered once my home store is basically created. And there is a couple of more you can use as on patch or on snapshot. If your data is changed, you can also do some actions afterwards. It's basically like a life cycle of our store. So when my store is getting created, I'm establishing a connection with Azure Signaler service, and I'm getting the stream for this event, and I will subscribe on it. So after a subscription, if I will receive some messages, I will process them in a specific action, which I have implemented higher in the same file, this one. So this basically, while I will receive a stock data, what I will do, I will just go through those items, and I will find out if it's a new item, or I just have to update what I already have on my UI. Beside this, I have two another functions. The one will call my Azure function and will generate some random movements. And another one to get all my storage location. So basically three functions what I will use on my client. And going to a component, just having a quick look. So this is my home component. Sorry, I have a home store I'm using here. So I'm injecting a home store in my component. And what I will do here, I will just pass my data, which I will receive from calling get storage locations endpoint. And I will pass it to my child component. So my child component will not call any service, will not do any logic. It will just render what is received, basically. And when my home component will be rendered, I will get this information. And I also have some functionality to start an interval. So I will be able to generate some random movements every like half a second, just to show how the real time basically works. And I'm pretty sure that it's already up and running. Yeah, that's true. And now we will go to a browser and actually have a look how all this thing is actually works. So now we have here a CosmosDB Cosmos database, and I have a couple of containers created here, but they are empty. Nothing in here yet. And this is my client. Yeah, so nothing is here. I will generate just a couple of movements just to show how those items will look like in my container. So if you saw, there is a gap in between, because when I clicked create movements, the movements were created, but it also takes some time for trigger to be executed and create materialized view and save them again to another container, to stock per location. So we have 5 movements which were generated, and as you can see, it's just a plain, basically, object which contains the article ID, the name of it, from which location and to which location my item was moved. And for stock per location, this is basically the same information we can see on UI. I have a location name, and I have a list of items which are on this location. I do have some negative numbers. This is happening because we have because my test data, I'm basically trying to move some water or cola from the place where they never existed. But for the warehouse system, it's also the case that you might have those negative numbers because you don't want to hide that something disappeared. You want to know about this problem and you want to react on this and find out why does it happen. So now, as we saw how the items can be generated, I want to go to my stock change trigger, which is basically the one which will react on our stock change and will send the messages to SignalR. I want to connect to it so we will be able to see how fast the messages appear in a portal and on our client. So it will be basically in the same time, like simultaneously. Yep, so we connected. And now when I will trigger this interval, we will start generating new movements and receive messages on the UI. Again, we have a bit of gap between when the movement is created in a database and it's actually and materialized view is generated. But as we can see that actual changes when they received by Azure SignalR, those messages broadcasted to my client, and they appear here even faster than they are in portal. So we can see that it's happening really, really fast. And basically, that's the way how it works. So now, as long as I will generate some random movements, and I know that my SignalR service is up and running, I will receive those updates, and maybe I will stop it now. I might receive a couple of more messages. So this is basically how my client can communicate with Azure SignalR through Azure Functions. And just to have a quick look, what I want to small comment before I will wrap it up. I have those functions in here, and if you want to debug it locally to play in the same way, so I have it published on Azure, but I do have my local client that I want to play around, you might have a problem that with CORS, and you have to go here and basically specify your local host, like your client address. And for your functions, another thing, don't forget to go to your SignalR, get the keys, which is connection Azure SignalR connection string, and put it in your configurations for your functions. It was I don't know why, but it was quite common. I saw in the last couple of days that someone was forgetting to put some connection strings, and that was the reason why debugging process was not happening, or testing process. So don't forget about configurations. Don't forget about CORS, and yeah, in any other case, it's super easy to play around. And just a quick summary from what basically I learned and from my experience from like putting this all together and working with CosmosDB and Azure Functions. They allow me to write much less code. And this is the great thing is, because besides having less code, I also can save some time, and I can concentrate on my business logic much more than putting around the whole infrastructure and thinking like how my data layer should look like, what kind of services I need, and so on and so on. And also, it's super simple to build the separate components. Not only that you have everything separated because in separate Azure functions or function apps, but also it allows your team and other developers to even listen into the same container and being subscribed on the same events, work independently, and build different materialized views and basically separate your logic. And at this point, thanks everyone for listening. And once again, you can contact me on like LinkedIn details and on Twitter. And I'm looking forward if there's any questions.
Great, thank you, Olena. Let me just bring Matt and myself back in here. And I should actually say Dyatlov. I think that's how you say it, right?
Yes.
It was hervorragend.
Yeah.
All right, cool. We do have a couple of questions. Let me just find them. So first of all, I made some notes. First of all, and I'm totally not into all that Azure, universe. But one thing that always surprises me is if I go to the Azure portal, I'm like stunned about how much services there are. And I just want to how do you keep track of that, and where do you actually start?
I will be completely honest. I started a couple of months ago. I hated Azure before. Like I was not working. I was like, no, I'm not going to look into Azure at all. We started to work because we were searching, as I said, like we started to build warehouse system, and the companies, both of the companies, they're quite big, and we had already like 20, 30 warehouses. So we needed something, first of all, scalable and maybe globally distributed. So we kind of get this idea to have a look in CosmosDB. And once I started to look into it, it's kind of, getting step by step. Okay, there's Azure functions, there's change feed, but what if you need to do some aggregations? Then you look in Apache Spark. And with time, you just kind of getting used to it. And every time there is like some new things, is like it's easier to keep track of like one or new service which was like released if you already learned everything before, So it just takes time, like a couple of months, to actually get into it. But I agree, it's pretty big.
Would you say it became is it in between love-hate relationship or even more love already?
I would say, it's kind of, I'm impressed from the size and variety of different like services, features, and so on. But I still in love in writing code. Like I feel sometimes lazy, but I really love writing code and all this like .NET things. So I love that they makes our life easier, but I don't really like Azure.
I have to say, and I bring this up the second time already today. I have to tell like everyone, it's the first time I was working with telemetry over the last past 2 weeks. That was really, really interesting and took also not so much effort. Yeah. Okay, but we do have a couple more actual questions to the talk, right?
I've got a very, very simple one to start with. Is the sample code, is the code you've got there, is that available on GitHub?
It is. I do have sorry, I keep forgetting to put it in my presentation in the end. I do have it on a public GitHub. Just if someone's interested, just write me a message in Twitter. I will send it.
Sure thing. If you give it to us afterwards, then we can perhaps put it on the in the comments of the stream
of course, I will do
that'd be useful, because it'd be very interesting, very useful to be able to sort of go through the code and
there is everything in one repository basically.
Mm-hmm. Great. So this is the code that you're showing today. Is that based on production code, or is it a sample which you've built just to sort of show how everything ties together?
It's definitely not a production code, but because I was investigating mainly all this like CosmosDB and Azure function and so on, the way how we build in production code quite similar to how I'm building my demos, because Well, I'm kind of also building the production code in the end.
Yeah, sure.
Yeah, I'm trying not to build it in the same way because, of course, production code is much more complicated. There's many edge cases and so on and so on. But the general idea of kind of the design, how you have those Azure functions, how they communicate, is pretty similar.
Yeah, because what interested me really, I guess, is because you're sort of creating something new here. I was wondering if you were creating a new feature or migrating existing code. So, what did you have before, and what have you got now, and what were the sort of problems you hit along the way there? Because this looks like a very I don't know what with the word. It seems to be a really good way of solving this particular problem. You know, the Lego, as you say, the Lego pieces, they fit together very nicely, and yet a solution which you build yourself, a previous solution might not have been quite so Lego-like and clipping together. So, what problems did you hit along the way?
First of all, this code is completely new, and we are not migrating anything. So we, of course, the way how the warehouse function inside, we kind of need to take the same requirements and in the end build more or less the system which will behave the same. But we don't reuse any parts of code and so on. I don't know why, but somehow it's always the case that if you have like warehouse system or like some retail system, it's always legacy. So we don't reuse it. It's legacy. That's the reason why we're rebuilding this, because it doesn't really scale well. And especially during the merger, now it feels really, really well. So all those pieces I knew, and they just based on the requirements and business logic, basically. So it's not even the same structure how those pieces are with what we have now in the old system. It's not the same.
Okay. One of the things I was wondering about with the Signal R connection was, does that mean now you can have some multiple connections as well there? So it's not just a Signal R connection to a single instance there, is it?
No. Yeah, of course. You can you can have multiple clients connected, and for me, for example, it was never a case that I want to connect to a specific user or something like this. But it's pretty flexible, this connection. Yeah. So if you saw there's like a hub name, so you first of all you can change it dynamically. You can for example, if I have a couple of warehouses and I want to have a different tabs and see my stock for all the warehouses, by just clicking between them, what my client will do will just reconnect with a different configuration, for example, and will receive messages. And the same will be for other clients. They can be connected to the same hub and listen to all those messages, and they will be broadcasted to all of them.
That's really nice. I like the sound of that. That makes it sound nice and straightforward. Just swap connections, and you're working with a different warehouse and everything.
Yeah, it's this is all like this sounds like really straightforward and so on. But sometimes when I'm realizing that we will like grow our warehouse system and so on, I'm kind of a bit of afraid because it's all kind of on triggers and events, and like it's all. I kind of a bit of afraid that it's in the end could be a mess. So it's also like you have to pay attention not to overwhelm your system with all those like triggers and events, and really kind of think through. Like we really spent a couple of months just thinking and constantly discussing about all this infrastructure, because once you know how to do this, it's easy. But if you start building and start thinking, of course your design is changed, but if you have no idea at all, it will just end up with tons of triggers and clients listening to everything, to everyone, and it will be just a mess in the end.
That leads on to another question, actually, which we've got, was how easy or difficult is it to debug Azure functions and all of this, and especially if you got all the triggers and that, and the question I think is dealing with React as well. So, I guess two parts, how easy is it to debug with all these different triggers and everything you've got there? And then how well can you do that with React itself?
So debugging, you know what? I just had the same question yesterday from my colleague, like, how do you debug these things? And to be honest, I don't really debug them much because building, like, first of all, write tests to cover the business logic. It's the first thing. And another thing, because they are kind of pluggable, there's many ways how you can test them. So you can test them directly from Portal. You can just trigger this function, see if it works. You can run them locally. you can also like run attached to basically a process, and then you can debug them. But I do know that sometimes people have problem. I was able basically without any problems to attach to the process when I run this Azure function and just go through it. But the most of the, like this demo, I was not debugging at all. I just wrote a code and it was working because the whole code was migrating from different demo, which I built previously. And it was before a console application. So it was already tested quite heavily. But it's not a problem, should not be a problem to attach to a process of the Azure function and debug it. With the React, this is a good question. I actually don't really know how you can like debug your front end at all. Console log and console information. No, but without jokes, first of all, if I have if my API works properly and I know that I'm receiving the data and my client can receive everything that is needed, is it like from Azure Signal service or whatever, the only thing you have to do is to ensure that your client has actually received it. And I'm using like Mobix State Tree. It's super easy to actually understand where it's going with your data because you basically can open it in browser and expect the whole tree. I don't really do this that often because it's not a debugging. It's just observing the state of your data. But yeah, if I need to debug it in browser, to be honest. I don't have any like special magic how to do this. But I do work a lot with React. So basically most of the things, if I debug something, it's I messed things with the configuration or something like this. So something is really bad and it doesn't work.
Yeah, okay.
We have another question from Frederick, which asks a pretty interesting question. Could have been me. Do you ever worry that an event trigger would end up triggering itself, causing infinity loop, causing, a lot of costs?
Yes. I also was thinking about it because that's exactly what I said before, that it's really, you should be careful with all those triggers because you can end up in a mess. I do worry about this, and before implementing any part of the functionality with all those triggers and so on, we really think through like all this, how it's going to be implemented. And also in the production code, we do implement like kind of how deep you can go. And well, basically in the production code, we do have some functionalities when we kind of go in the tree of the items. We do have some tree structures in there. And we also handle like how deep we go in the loop and if we're really not stuck in there. So of course I do worry about it. And we actually also had a lot of discussions about it recently.
But isn't there, I just wonder from side of Azure, would there be any way to have some heuristics or something like that? That would like.
Good question.
Or is it just that you set a budget and that's it?
No. Good question. I think I never checked Azure. It's actually a good thing. I will do this afterwards. But I'm pretty sure that they should have some functionality to actually stop this. If it's like stuck, it should be like, for example, if I use CosmosDB and I imagine that my trigger like stuck in the loop and it's like writes data and triggers itself and so on. What I will have for sure, I will start having a hot partition in CosmosDB because it hits the same server, for example. I will get a hot partition. So it will be one signal that something is going wrong with my Azure functions. But if there is something with Azure function itself and triggers, this is a good question. I don't really know. I will need to have a look in it. Good question.
I would expect there might be something.
Yeah, I would also expect it, if that's for sure.
Yeah. Eldad, I hope I pronounced that correctly, also has a question, and it is, when would you use the bindings and functions, and when would you use the SDKs of the different services instead? For example, for CosmosDB. Yeah.
What was the first part?
When would you use the bindings and functions, and when would you use the SDKs of the different services instead?
In the different services. The SDK for different services. Well, what kind of different services? It also depends on what service are we talking about.
I may ask that, and we might come back to that.
Yeah, it's actually it's the bindings in functions. I think that yeah, it all depends on the service itself. Like I would use a binding for sure if I need to have something really simple. Like in general, what I have to say, like working now with Azure functions, I would try to keep Azure functions super simple. Like I was showing before that you can specify ID and partition key and even SQL query with CosmosDB output binding. I would not do this, to be honest. The maximum what I would do, ID and partition key, okay, but if you have to write a SQL query, I would not do this in the binding. It does look like magic. It brings a complexity in the code, and it makes it hard to understand. Especially, I would imagine the new person coming in, having a look on a attribute, and there is a query in it. I can imagine the reaction, like, how does it even work? So I would definitely go with binding. If I need to pull some simple data, like everything that I have or one specific file, I would use binding. If I cannot do this with binding, I would definitely go and implement my own logic for CosmosDB, for example, as an example.
Mm-hmm. Also, I have to say those bindings look like perfect food for source generators or something. But I don't know. I guess it's useless there. I'm not sure.
If only we'd had if we'd have a session about source generators today. It's great. Speaking of the bindings and the parameters, though, I noticed one of the parameters was a collection of dynamic. We don't see much use of the dynamic type around. How come you're using dynamic there?
Yeah, actually, this is kind of by default, and to be honest, the same for me. I think that it was like first time in a long time that I saw dynamic type, and because first of all, Cosmos database is multimodal, so it's not only document; it can be graph, key value, whatever. So I think this is the reason why you have dynamic. But if you know that you're working with the documents, I think that you can also specify the document type itself, and it would be all right. But because of multimodal and all this, you cannot really predict which exactly type you will receive in the end.
Right, that makes perfect sense. Yeah.
Yeah, it's also not the case that you don't know which database you are connected to. So I'm pretty sure that you can specify it in there.
Yeah, true. We had another question as well, which I think is a perfect setup for us, to be perfectly honest. It says, how do you work with Azure functions? Do you use the CLI, or is there an extension in Rider for that? And funnily enough, there is an extension in Rider for that.
It is. And,
yeah, we can. Martin, who's been on the stream earlier, works heavily on that. He's involved in that, as are several others around here. Yes, you can do a whole bunch of things. You can add sort of run and debug markers into your code, so that you can sort of click on a code next to it and run and debug against the emulator. It's got the storage emulator built with it, and generally just makes working with Azure functions a bit nicer. So if anybody out there wants to try Rider with Azure functions, make sure you get the latest version of the plugin as well. So that was a nice plug. So sorry, that wasn't even a question for you. I apologize.
No, that's all right. That's all right. I to be honest, I started to work with Rider maybe 1 year ago. No, 6 months or 9 months ago, because I was working on Windows machine before, and of course like Visual Studio. But then I switched company, and my colleague he advised me to start working on Mac, because we do develop like .NET Core and so on, so you don't need to use Windows machines anymore. And he advised me to try Rider because it's much faster, and especially we had like microservice architecture. And if you wanted to test, for example, the flow or try some things, you have to have a couple of instances. And for like with Visual Studio, it was quite like heavy, and it was not really working as expected. With Rider, everything was flying, and I really liked it. So now I do work with Rider most of the time.
Well, we won't argue with that in the slightest.
That was a nice compliment.
Yeah, we'll take that.
Good. I'm happy that I can make a compliment. It's really, really great tool. I do like it.
Great. Matthias, do we have any more questions?
Please tell me if I just didn't get it, but we have one more on our list, which was a more general question actually. Do you have any recommendations on when an application should receive like real-time updates, or is there really only like specific use cases, like I don't know, we have stock markets here and such like that? Or when exactly do you really rely on this
On a
fast
real-
real-time update?
I will definitely, I had a couple of use cases before as well. I would definitely, if you have any functionality of collaboration, like it was from my previous experience of working where you had in a browser a mode of collaboration when two people can come in and change things. This is of course the real-time functionality for sure. For any kind of monitoring, so like in our product company before, I built also UI, which would really would be the real-time functionality would be a great fit when you saw in the real time the assignment when we had an order and the order is ready to be delivered, it would be assigned to a specific driver. So that kind of functionality we wanted to have in real time, and we had a dashboard for basically to see how it's like going, like which driver is picking which order. And I would say that any type of monitoring collaborations should be in real time. Otherwise, just ask yourself if it's not easier to just query it every 5 seconds or something like this. Yeah, because sometimes it could be a case. If you don't have to do this all the time, have it in real time, and like at some point of the day, couple of hours, you need to have it real time, and the rest of the day, no one is interested in this functionality. Maybe it's easier to play around and actually implement some like just pulling.
Mm-hmm. Gotcha. We have something actually that kind of leans into what we already discussed when we were talking about this. Really, when you said you're really careful about introducing new triggers and so that they don't trigger each other. The question is which functions. Let me just read it. With functions triggering on events in other systems, how easy or hard is it to keep track of the overall application architecture? Is there a way to get an insight into what function listens to what event and what functions emits events?
What functions emits events and listens events? Then every time when there is events, there is kind of like a bit of like magic, because you cannot really easily like track it. The first of all, like how we handle it and how we understand it. In any architecture, if you build a microservices, I would also like ask how you keep track of all those like microservices and all the functionality. Exactly in the same way, we do have also like microservices, but it's just like our function apps. And the separate teams take care of the like each service to trace the whole to have a trace of like every trigger and every event. We don't have it yet, and I don't know if there is anything default for this, but I'm pretty sure that any production system will need to implement some like advanced log to understand like from which service the event was sent and who consumed it basically. So I don't know default functionality for this. Definitely something which is needed in the production code.
Okay, cool. Someone also just mentioned application insights, telemetry, all the things.
Yeah, application insights is true. You can enable it, but I don't know. It was not pretty helpful for me, to be honest.
Okay, I don't have any more questions, except maybe one, but that's very off topic. I noticed you're pretty new in the speakers profession, let's say. It's like you're, I don't know, I think I saw your first talk very recently.
Yeah, I started like months ago, I think, or 1.5 months ago, I started speaking. So
Cool.
yeah, it's like, I think that this is like my first conference itself, because before we had like more meetup. Oh no, there was like Azure CosmosDB conference and Global Asia. But yeah, it's kind of all new for me, and always, exciting. It's a bit nervous, but I'm trying to, my goal is to share just like my pain, my experience, my things I'm doing on daily basis. So, and I'm always happy when people are also interested in this, especially for questions.
I think you definitely reached your goal today, and I hope we did a good job providing here a good way and experience for you.
Yeah, actually, a really great experience. I really enjoyed this.
Cool. Matt, do we have anything else, or should we?
No, I think we're done. I think it's time to say thank you very much That was a great session. It's surprising to hear that you're so recent in this. It was great. Thank you very much for joining us.
Thanks a lot for having me. It was really my pleasure.
All right, then
Great.
see you
Thank
around. Olena,
See you.
bye.
Bye-bye.
Bye-bye. And now I think it's time to bring on the next set of hosts. There's Rachel. And do we have Khalid as well?
Khalid is there too.
Yeah,
There
I'm
he
here.
is. Hey, now the party's getting started.
Oh, the party's getting started. I just want to say, Matt and Matthias and Martin, you've done a great job hosting today. So 4 hours, I think 5 hours has gone by, and any people who have stayed through those 5 hours are absolute legends. Although the speakers have made it really, really easy.
The speakers have been fantastic.
Yeah,
Really.
excellent stuff.
Mhm.
Okay,
Very much agree, and I hope you continue with that.
Yeah, I'm gonna try to. Me and Rachel are gonna try to hold down the floor, but you folks have set a really high standard, so thank you. So
I'm just saying, somebody's asking us when do we get a break. Somebody on the in the comments there is asking when do they get a break. And
right now's a good time.
Yeah, just hit pause. Just hit pause.
Yeah.
You can pop off, grab a coffee, and then come back and just press play, and it'll all be as though nothing had happened. It's great.
It's excellent.
At which point I think we'll leave you to it and enjoy the rest of the conference.
All right, thank you guys.
See you guys.
All right, Rachel. Well, hello.
Hey, they've left us here. Like we're the adults in the room or something.
Yeah, they've probably made a mistake giving us the keys to the castle, but we'll try to keep it professional here. But I'm really excited about our next speaker, and I'm really excited about the topic she's going to be talking about. I'm sure people have read the agenda and know that it's about gRPC. Just to not kind of pad this out any longer, I'm going to invite Irina here to the talk. So hopefully she's ready. And there she is. Welcome.
Hello.
I'm really, really excited about your talk. I think gRPC is a real winner in terms of technology. So I'm excited for you and for the JetBrains folks. And if you're ready, I'll give you the stage and we can kind of continue.
Ready as I can be. Thank you.
Yep. So stage is yours, and Rachel and I will duck out now.
Cool. Thank you. So let's see. Today we're going to talk about gRPC, and I'm going to try and make you love gRPC. I'm going to ask you at the end if I manage to do that. So who am I? First, my name is Irina Scurtu. I'm a software architect at a company called Endava. I'm from Romania. I teach .NET, and from time to time, I also blog. That's my blog, and this is where you'll find the resources for this talk, the slides, and the GitHub link. So, gRPC, why the fuss, and why do I chose this? So first of all, we need to know everything that is out there in order to make an informed decision whenever it is the case, right? So us developers, we're trying to work with the latest technologies out there, but the latest technologies out there are not often the most suitable things for our project, right? So in order to pick the right one, we need to know the technologies and to know what the applicability cases for that specific technology. So let's go ahead and have some history lesson. So the monolith. I always like to talk about the monoliths because when I started 12 years ago or something like that, the monoliths were the default projects. Everything was a monolith. We had huge projects. We worked with web forms, I think, at that moment. And we had big solutions and not so good computers. And I remember that every time we needed to build a solution, we might have as well move on and take a coffee because it was free time for us. The build took so long, but for us as developers, there was an easy life because whenever you needed something, that something was in the code. And in the code, meant that you could instantiate the class. You could go ahead and grab something, and it was there. But the deal with the monolith is that it's somehow hard to scale. It's not impossible. You can scale that. We have the tools and the means right now. But scaling a monolith means to scale the whole block. And maybe not the whole block is so used by our users. And when we scale something that is not needed, it means that somehow we're losing money, or the business is losing money. And we do not want that. But of course, as developers, we kind of do not care about that often, right? We have some other people in our team to care about budgets and all. But even so, the things evolved. So we moved away, and we had then MVC, because I came from a .NET background, and I love .NET. And then MVC appeared, and we had front end and we had back end, but these two things were very coupled. There was HTML render from the server side, but it was a way nicer approach than web forms, right? So the future tells us that these things also evolved. And now we have front end, and now we have back end APIs, and we have databases, and everything is decoupled, or we want to keep everything decoupled. And doing that, it means that we will have a lot of things to worry about. We will have many server-side apps that communicate with a single front end on several front ends. And now we need to, worry about orchestrating this. Now we do not have the whole block, and now we need to think, if I do this, I might break some other API and so on. Or you might think that, okay, how do I get data from other API, right? And the future, we like it or not, the future is distributed. And that distribution comes with something that is hard for us as developers. Now we might have architectures like this. Now we might have a single front end, several backends, and those several backends that communicate with several databases, and maybe with some other backends. Why not? Maybe we're calling other APIs from the server side, right? And well, things are getting complicated. Once that you are adding an extra layer, then things are not so easy anymore. And then you might add up and need things like this. You might code in .NET Core, in C#, but maybe you need a component that is written in Go or in Node.js. Or I don't know, you need to communicate with the server-side third-party API. And how do you manage this? You need a common ground for all these technologies. So you might say, okay, but we have a common ground. We have JSON. And I will say, okay, you have JSON, but how do you distribute HTTP clients? Let's say that we have the case where we have Nugget, right? We want to have HTTP clients to be able to distribute them with Nugget packages. We hard code them, we code them, we add logic, everything, just to add data from another API that is also written by us. Okay, and how do we do that? We create Nugget packages, we share them, and blah, blah, blah. Everything is fine. But the deal with Nugget packages, once you start growing them, is that they become spaghetti, a spaghetti of references. And microservices, as an architecture, they tend to have a goal, and they meant to keep everything decoupled. But once you introduce a Nugget package, you kind of have a reference, and you kind of have a coupling of some kind. And another deal with the Nugget packages that you create first to distribute HTTP clients is that they tend to grow, and they tend to become fat, and to get some additional logic that has nothing to do with the initial purpose. So they receive business logic in there, and I don't know what else, but they become big and brittle, and they defeat the purpose. Okay, and it's not so nice to share Nugget packages between your APIs, a lot of them, because I know you work with microservices, and this might be a way of getting data from one service to another, right? And why the need of any other technology if we have REST for everything? We have those HTTP clients that we're sharing through Nugget, and we're creating REST APIs. And okay, we have REST for everything, but REST as a concept, very cool if you know the deal and the underneath things from REST. But the communication is very simple. We have a client, we have a server, and in between, there is a request and response. But before we get the response, there is something that is called a content negotiation. And that content negotiation is a process that happens behind the scenes without us knowing, that takes care about a few things. And a few of these things are the format of the request. For example, what is the format that the client understands and expects as a response? What is the payload of the request or the response? How do you handle errors? Or how do you handle retries or authentication? And what do you do if the model changes? For example, property or several properties are removed from the backend. You, on the client side or in the consumer side, it doesn't need to be a front-end app. It also can be a server app, another API. If the model changes, what happens? Well, there are ways of preventing that, but still, if the model changes, first, the client might break, right? If you don't have tests to cover yourself. And how do you handle and how do you make the client be aware that, hey, on the server side, the model changed, either by adding or removing things? You might go ahead and say to your colleague, hey, you're working on the front end or in the receiving party, go ahead and remove that because it's not coming anymore from the server. But what if you cannot do that? How do you handle the model changes? For example, let's say you are coding an API that is consumed by many parties, but you do not know who are those parties. How do you force them to be aware and to change themselves when you're changing the model? So you need to find a way. Okay, then you might say, okay, what's wrong with REST? It works. We're sending data over HTTP. We're saying that we're having REST APIs. But to me, sometimes REST has a problem when it's not done properly. For example, it forces you to have a communication inside your team. If you're lucky enough to have the possibility to have that communication, it forces the team to have this conversation like, hey, you're going to use this info. Hey, add that field in the UI or in the consumer application. Hey, extract that, remove that. That is not needed. Please add two fields and so on. And this communication takes time. And more often than not, as developers inside our teams, we're very rushed to do things because we want to deliver fast and the business wants us to deliver fast. And we kind of do not have time to chit-chat about what fields need to be removed or added and so on in order not to crash. So here goes remote procedure calls. So remote procedure calls as a term is there for a long time, since 70s or something like that. So it's not new. It's just new inside our world in .NET. What it does is to make the system or several systems, a distributed system, behave like it's part of the same monolith, let's say. So makes the system seems in the same place. For example, let's have a look at some code. We have a variable named order that calls a method. Create order of a specific order request. Okay, nothing fancy. It's there. The code that we're calling looks very local, right? Let's have a look further. We have another variable, payment status, processes the payment for that specific order. And then we're checking if the payment status is successful. What do? We arrange the shipping for it. Neat, right? It's like in a monolith. It's there for us to use. But how about if I tell you that between these two, there is a small network call involved? So the code that we're using, it's very local, developer-oriented. It's methods, services, and so on, right? But if we have a closer look, there is network involved. So the call for process payment for, it's actually made over the network, does a hop over the network, and does things. So RPC as a concept makes the code look local and sometimes is prone to errors, just because the developers are forgetting that they're using this approach and this technology, and they might overabuse, right? You might make several network calls just by calling some methods because they look so code-alike. So the goal of RPC is to make network communication transparent. So in a way, it allows you to have a distributed system that kind of behaves like a monolith, right? Just this is the main purpose of RPC. Now you'll say, okay, RPC, but gRPC? What's gRPC and what's the use of it? So a short history, it appeared in 2001 as Google Staib project. In 2005, it was open source. Then in 2016, we had gRPC v1. And further along, in 2019, we had it with .NET Core as first-class citizen. So gRPC is contract-based. It's something like, it looks like an interface. You have a contract. We always say that an interface in C# is like a contract. Well, gRPC, it's pretty much the same. We will have no code references, so no more Nugget code packages sharing. It will use HTTP2 by default, which means that it will be way faster out of the box without us doing anything. It uses something that is called protobuf serialization, which ends up us having smaller payload. And of course, another very cool thing is that it's available in many languages. And this will allow us to interoperate. You might have a Go application that communicates with the .NET one, and it's very nice, without having the JSON payload that it could be common for both of them. Code generation, it will generate code for us. And it's pretty nice because everything is out there for us to use. Okay, so now if in REST or HTTP, standard way of communication, we would have a client and a server that communicate. Now we have something in between. That is the proto file. And that proto file is the interface, is the contract between the two. As long as the two parties understand themselves, well, the two parties can communicate. Okay, so what's the proto file? The proto file, it's a special syntax file that kind of looks like this. You'll have a cool syntax that is, as first line in the code, it's a file with the .proto extension. That's it. And inside it, you need to tell what's the syntax of the proto that you're using. Currently, it's proto 3. It's made by Google. Then you need to say, okay, this is the C# namespace that I'm going to use, namely my first gRPC, and then the generated package that is called Fibonacci in our case. And then you need to go ahead and say, what is the service definition? What you want to expose? And how do you do that? Is simply by adding a service keyword, giving it a name, and then inside it, you have something that is specific, like let's say it's like an interface, right? You need to say it. This is an RPC service because we're working with services. It has the name compute Fibonacci. It has as an input a type that is called requested numbers and returns this type. Okay, so this is the interface. You're saying what you're exposing to the outside world. And what you're exposing is this specific method, compute Fibonacci, with that specific input and that specific output. Further along, you need to define the types that you're using. You cannot make a proto file without it. And these types are implemented or defined as messages. You have the keyword message and you give it a name, and then inside it you will have properties. And one of the property is, in this case, is number, and in the second case is result. Okay? And of course, you can have types, and you should have types for it. This is an integer 32, and you'll have something here that is mainly strange, but it's not. This is not an assignment. This is actually the order of the field inside that specific type. For example, you would have another field here. You will have equal to, and so on, because it's binary and it needs to know how to be deserialized. Okay, so you will see in Rider you have a very cool extension that will have some sort of intelligence to give you the types that are available for Proto. I will show you that at the end. Okay, so you need to define everything, and this everything will go in a specific project. Okay, so before digging into some code, because I have a few demos, we need to talk about gRPC types. And these types are also called modes, methods. It depends on who you are talking with, but are types of working with gRPC. And the first method or mode is called unary, which is the classical request response that we know from HTTP or from our REST APIs. The second one is server streaming, where the server sends several responses to the specific client. Client streaming, where the client sends several, let's call them pieces of request to the server. And bidirectional streaming, or we have the both combined. So, the client is sending several things in, and the server is responding with several things out. Okay. So how these are looking, it's pretty much like this. Unary request response. The client initiates the request, the server gets the request, processes that, and sends back a response. And if you were to define such a type of method inside your proto file, you would have something like this. Okay, so it's an RPC. This is the name of the method. This is the input name, and returns one thing out. So one thing in and one thing out, pretty much. Okay, this is the most easy that you can find. The next one is called server streaming, and again, the communication with the server is initiated by the client. You cannot push things like you would do with SignalR, for example. So server streaming, one thing, what will happen is that the client sends one thing in, and the server will send several pieces of things out. Okay, and how do you represent this in the service is by adding a nice keyword called stream. You see, you have one thing in, and you have a stream of things out. So this is how you represent this when you write your proto file. Client streaming is similar somehow. Again, the client needs to be the one that initiates the communication, and it will send several things in, but the server will respond with only one thing. How do you do this? So it's simply by adding the stream keyword in here. So a stream of things in, so several things in, and it will return one thing out. Okay? Imagine this as being very useful for uploading files. You have a big file that you want to upload to the server, and during one connection, that thing will be split into pieces and uploaded, and it will be very, very fast. for uploading data from different sensors, sorry, also might be a good scenario, or to collect data from different clients. And the last one is bidirectional streaming, which is a combination of the previous two. Again, the client needs to be the one that initiates, sends several things in, and it will receive several things out. Okay? How do you represent this in code? It's simply by adding the stream keyword here and there. So several things in and several things out. Okay? Multiple in, multiple out. Okay. So let's have a look and see some code, right? Enough with the talk. I will use Visual Studio just because I tested this and my computer didn't crash. I'm using different things for streaming and I don't have such a good laptop. So I will go with Visual Studio, create new project, and then you'll have here an ASP core gRPC service. I'm gonna click next. And I'm going to talk with you for a bit because it will take a while. Okay, so in here you have to choose what's the version of it. It also doesn't matter right now because there aren't so many things changed from one version to another in gRPC, not to my knowledge at least. But I'm going to go with .NET 5. And it will create a project. And what you'll see, it's something that should be familiar because I either work with ASP MVC Core or Web API, and some things are there. Okay, so on the right-hand side, if things are loading, you'll see a project structure that is known. And I'm going to try to zoom it for a bit. So you're going to see the startup, CS, program CS, upsetting JSON, and this is familiar. Okay, but you'll see that you have no controllers because we won't work with controllers in a gRPC project, but you'll have a folder named protos where you should add your proto files, and it also comes with a default example that will help you understand what is this about, and also the services. So it's up to you how you handle things around services. But what's a gRPC project? It's nothing else, nothing more than a console that it adds a few things. Come on, open yourself. I need to take care of where I click in order not to break this. But in Startup CS, you'll see some familiar code. But in Configure Services, you'll see that there is a middleware here. Services add gRPC. And that's the middleware that allows you to work with gRPC. And also, in the use endpoints, there is a mapping that says, okay, I have an endpoint that maps a gRPC service, namely greater service that is in the project out there. And pretty much this is it. Nothing fancy about it. But if we have a look in the proto file and we'll see the grid.proto, it's the exact, I'm gonna make this bigger a bit. We're gonna see the same syntax that I showed you in the slides. So we have the syntax for the proto files, we have the C# namespace, which is the project name, and the package that we need to generate. And in here, you'll have the service that it will be exposed with the name. And also inside it, there is one method defined that, since you do not see the stream keyword anywhere, you can assume this is unary. So one thing in, one thing out, request response in the traditional way. And pretty much this is the interface definition. So this file can be taken out and shared through different ways. And in the services, you'll see something that is inheriting from greeter, which is the package that it was in there, called greeter base. Well, remember that I told you that we have code generation? Well, the code, here it is, the code generation. So the code generation, if I F12 this and it doesn't die, it's something that is strangely looking, but it does the job and it works. You see that is a public abstract partial class called greeter base that exposes a few things. And it has a service implementation, and pretty much this is it. I bet you haven't seen this kind of code for a long while. Okay, but this base allows us to say that, hey, this is a service that implements something that is in a proto file, namely this, okay? And inside it, it's a service that it's a classical one, nothing fancy about it. You can have constructors, you can inject things in it, you can add repositories or other services. It's up to you how you inject and if you inject things in here. But what you need to do is to actually give an implementation. And that implementation is for the methods that are exposed in the proto file. Just exactly like we have in interfaces in C#. An interface is a contract, is definition that says, hey, if there is a class that uses this, it might as well give an implementation. So the same happens with services that inherit from bases from the proto files. So what you have in here is a say hello method that has an input called hello request and does something. It returns a hello reply, okay? And what you'll see here as a second parameter that you cannot get rid of is server call context. It's something similar to an HTTP context that we are familiar with from Web API or MVC. So like it or not, you'll have the second parameter or the third parameter of this type with every method that you will actually implement, okay? So say hello, hello request, sends a hello reply. Let's have a look. An RPC, hello inputs, hello request, outputs, hello reply. But in your implementation, this will be tasks, okay? And pretty much this is it to get running. And I'm going to close this and I'm going to go and show you an actual demo for all these 4 methods. So what I have in here is a suite of projects. I have a server, which is the actual gRPC implementation. And I also have 1, 2, 3, 4 other console apps, okay? And for each of those, I will show through a dummy example with for loops, what's happening inside it. Okay, so let's see. In the server part, you're going to see that we have packages. And in the packages, we have gRPC core, which is it's an old version, but now we do not have the pre one. gRPC core allows you to work with proto files. And inside it, we have grid.proto that in my case has 4 methods. The say hello that sends a greeting that we currently saw. Then we have the server stream, client stream, and bidirectional one. And we will take each of these and look at it independently. Okay, let's see the proto file. This is here. And what I'll have to show you is if you right click and edit the project file, you'll see a thing, an item group that says, hey, this is an item group. It has a proto buff and includes this path to find the specific proto file. And it acts as a server for gRPC services. Okay, this path with include here allows you to have the proto files maybe not inside the same solution, maybe in a specific path, on a virtual path or somewhere, okay? So if you want not to keep the proto file inside the same project, you need to go ahead here and to specify the specific path, whatever suits your needs. Okay, so this is gRPC server, and this is how you say that this is a server for gRPC, just by adding gRPC and putting the server there. Okay. Okay, let's look at the Unary one because it's the easiest one. So what I have in here, it's a console app. Okay, that if you do not believe me, I'm going to show you. I told you about not sharing references and not sharing Nugget packages. And here it is. So what we have here as packages is Google Protobuf, gRPC, and gRPC tools. These three were needed when I started to demo this. So console app, nothing fancy. These three packages you need in order to work with gRPC. But in the program CS, you see some things. For example, you have the concept of a channel. In gRPC, there is the concept of a channel. If you work with the RabbitMQ, maybe, the concept of a channel might be familiar. So a channel is something that points up to a location, and this is the location of the server that you'll have running, and gRPC server, right? And as the second parameter for this channel, you can provide credential, and these credentials at the channel level. Okay, so it's not per request, it's for the channel. You have two ways of securing these. So in our case, because it's a demo, we do not need anything fancy. And we're going to say that this is insecure. It works, it's fine. Okay, the next step to work with gRPC or to call a gRPC server is create a client. And to create a client, you can go ahead and just call it. Well, and now you're going to say, so where does this came from? Because I do not have a reference to the initial server project. It's not there. And I'm going to show you how I did this. So greeter client and pass in the channel, it's done automatically by the code generation that I mentioned. So with the greeter client, it's implemented by default, generated for us. Okay? We pass the channel, and then we'll be able to use the client in order to call our methods. It's very similar to how we are working with HTTP clients, right? Create new client, blah, 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 pass in the location, and you just call the endpoints. Okay, so what we do here is create a hello request. I'm going to write this into console because we need to also track that. And here, we're waiting for the reply. And what to see? Our client has our methods in here. So the methods that we exposed, bidirectional, client stream, say hello, server stream, are there for us to use. So it's up to us what we want to use. So we pass in the request, and then we can also have call options. We're going to talk about these later. And we're going to wait for this. And you say, okay, I have a channel because I have some gRPC packages. I have the clients. But, okay, how does this know where to call? Okay, and I'm going to show you. I'm going to edit the project, edit project file. And we're going to look over the same kind of thing, an item group with the protobuf. And this time you'll see that we have an include that points out to a different path. And actually this path is somewhere pointing in the server project. Of course, you can also take that and sit outside of your specific projects. But this time, the type of the service, it's not server anymore, it's client. So this is how you tell that this project behaves like a client for a specific thing. Okay, cool. So pretty much this is it. And now we're going to look at some console. So in here, you'll have the server, and on the right-hand side, you'll have the client, okay? And you'll see this communicating with each other. So on the right-hand side, I'm going to run the server. You cannot get rid of this because this is how it works. We decouple things, but not that much in order for them not to be online at the same time. So, okay, what we see here is that now our application is listening. And on the right-hand side, we're going to make the client make some requests. So you see that the server is waiting for requests and the client sending things. And it's very good for the demo because it works so slow on my machine, because you see it sends JetBrains .NET days. And in here, there is a thing that happened. And this thing that happened is that we received some info about it, like a request finished is of type HTTP2. It's also type POST. So when we're working with gRPC, we forget about any other verbs except POST. Everything that happens, it's POST as requests, okay? You also see that it's a POST request made to this specific location. And you see that it's not some... It's a combination of a URL that we know of and then a method call. We have greeter / say hello. It's strange. And then you'll have a MIME type, which is application gRPC, and some information about the actual status code, HTTP related. It's a 200, okay? And also a thing about how long it took. And what we get back as a response is something like, hello, JetBrains.NET days, okay? And this is how it works. Every call that you make through gRPC, it looks like this. Okay, so let's see. This is the unary one. The, let's say, client streaming is the same, a console app. It's somehow similar. We have a channel that it's insecure. We have a client, and we're using that client to send things to the server. And what do we send to the server is this the value of the I from this specific loop. Okay, client stream, and what do we do in order to send them is to say, hey, await from the request stream and write async this type. So inside that loop, for that specific amount of time, because it will take them, I'm gonna delete a 0 from here. And what do we do is to wait that stream to be completed and wait for the response. And pretty much this is it. Let's see how it looks. Also in the server side, because we have an implementation that we're calling, right? So the say hello one is the same as in the previous example. And the client stream, gonna minimize this. It's somehow similar. It's an async stream reader of hello request. So many things in. The client is the one that sends things in. And inside it, we have a base message that behaves like a response and says, okay, I got, and here it will be the last I that it will be received on server side. What you do here is, while you have things in the request stream, so while you're receiving things, just take the current stream. This is exactly as we know in HTTP client, HTTP context dot current dot request dot something in a web API, and then we just concatenate this and return the reply. And as I mentioned, you cannot get rid of this parameter. It gives you the current context of the call. So this is all. So the server still waits, and the client streaming part we're gonna run, and hopefully will work. Fingers crossed. You see, the server gets things, and it got enough things. And what happened in here is that, okay, it got that amount of I, and the client that initiated the several requests got the last value of the I, so 99, so on. Okay, so where the request was made is in the service client stream with the same approach. It was a HTTP2 post request at that specific path. Okay, so several things in to the server and one thing out. So this is it. And the same. We edited the project file and we made it as being the client. Okay, client streaming. Let's see about the server streaming. Again, there is nothing too fancy about it. The channel, the client, and in here, instead of calling the client method, we're calling server stream. And also we're passing a few parameters. And these parameters can be something as being, you can also add deadlines, like, hey, if I do not get an answer in this specific amount of time, and in this case I added 1 millisecond, might consider this as being, okay, this is the deadline. If it's not accomplished, then throw an exception. And also you can have a cancellation token if you want, but these are the options for that you can send with your calls. So what we're doing here is, if the server is the one that receives, so we write things in the response stream. We read everything that we get in the response string and write them to the console. And let's see how this is working. Server is waiting, and the server will be sending things. And now, on the server side, you shouldn't see things happening because we get back the greetings timeout. Okay? Remember that I added in here the deadline as being 1 millisecond. And of course, 1 millisecond is very fast. And this is how we get the deadline. Because I also want to show you the exception part of the gRPC. For example, the deadline exceeded, okay, more than 1 millisecond passed, and it got to here, and we received an RPC exception with the specific status code, namely deadline exceeded. And if that happened, we write things in the console as being greeting timeout. And remember, the status codes that we're playing with right now in here are not related to HTTP as a concept. They're not the ones 404 and so on that we know of. These are related to a gRPC. They have the same name, but their signification is totally different. You'll see that we have aborted, already exists, canceled, data loss, failed precondition, invalid argument, out of range, permission denied, blah, blah, blah. There are a few of them, okay? But these are specifically to the gRPC, not HTTP related, okay? So this is how you can treat things. And if you were to have some authentication in place, you can also check this and throw an exception, like unauthenticated. Okay, I'm going to comment this out and uncomment the other part one because I want to show you how it's working. Let's see. You see that the server is sending things to the client. Is the other way around. On the left-hand side, it's nothing moving, but in the right-hand side, we're still getting an I because that's the example I'm using. Okay, so you see, we're receiving hello, 9,000 and so on. Okay, and also there is another thing that I want to show you. There is this message added here, namely found some trailer values gRPC header. In gRPC, because you're only doing post requests, you have pretty much no way of working with the classical headers from HTTP. And then they invented things that are called trailers. So you have here get trailers, and you get the current streaming call. And you have dictionaries where you can look after pairs of data. And this way you can mimic the headers that we have in HTTP the classical way. So a trailer is nothing else than a dictionary of key value pair that you add from your implementation. And this is what I added in here. So on the server streaming, on the implementation for the specific method, so client stream, server stream. Let me show you what I did. So it's one request in, and a server stream writer of out. So several things out, okay? And again, there is a loop that goes to this number that sends replies, several things out. And we simply just write things. And in order to mimic the headers, you have this option. You have to create a metadata entry with key and value. And to add, you have the ability to add that key value to the current context. Remember the server called context? Right. This is where you can add those. In response trailers, you can add the pair. And this way, bam, you have headers in gRPC, okay? So a way of mimicking it, at least. And the last one, you have the bidirectional one, which is, again, similar. You have this channel, you have the client, and in here, you somehow need to wait from one side and the other side. So you can call from the client the bidirectional method that you exposed, and then you need to wait while you have things in the response stream and to decode them. And you'll see the syntax that is response stream current is somehow very close to HTTP context current request or response that we knew of. And we write them, and then creating the requests, you have pretty much the same approach, but this time you're awaiting the request stream and you're writing there, okay? And wait the request stream to complete, and pretty much this is it. So you're listening and waiting on the both ends to see if you have things. And let's see how this is working. The server is running, and the bidirectional streaming will be built. Okay. Let's see. I hope it won't take long. I'm going to run again because I want a demo where these are not ordered. And sometimes are not ordered depending on how my machine behaves, and this time behaves. Okay, so the client sends these things to the server, and as a response, it receives this. But these are not necessarily ordered. It happened because my machine currently works. But if you run this several times, you might see that is not ordered, because that's not, you cannot expect this to be ordered, okay? It's async, and in async, anything can happen. Okay, so let's see another thing, and the last thing, the implementation on the greeter service for bidirectional one. So again, bidirectional, it has a stream of things in and a stream of things out, okay? And you see, as long as you have things to write, you get the current stream, and then you write those back. So this is all the fast about it. Okay, let's see if I wanted or not to show you anything else. Nope, but we need to go over a few slides. So what are the strengths? And I know a lot of people are comparing RPC or gRPC with WCF, and they are entitled to do that. But I'm comparing it to REST because it might be familiar to a lot of you. So REST is resource focused, embraces all the HTTP semantics, and it should embrace all HTTP semantics. It will give you a so-called loose coupling, and it's very text-based. You can understand what's coming there. And RPC, or gRPC namely, is action-based, is very programmatic oriented. It embraces the programming semantics. You call methods, not endpoints, and it's very familiar to us. And it gives you somehow a tighter coupling because you're coupling the code somehow. It's binary, and since it's binary, you cannot read it by yourself. You need additional tools. In performance, gRPC is way smaller because it has an efficient serialization. It's good for polyglot environments, lightweight, and it's perfect for point-to-point communication. your calling method, and you know specifically what method do you call. But you shouldn't forget that there is network involved. So the contract base, it's awesome. It has smaller payloads. It HTTP 2 and supports different streaming types that might suit a lot of business scenarios. And in downsides, we cannot talk about a technology without thinking about its downsides. And one of them might be the temporal coupling. Unlike messaging, for example, you need both systems to be up. Just like you need them in REST when you have REST APIs. You need both systems to be up in order for them to communicate. Same it's happening here. If the server is down, bad for you. You won't get data from the server. And also, as developer, you might forget that there is network involved, and you might abuse the network calls, because as I mentioned, it makes the distributed systems look and behave like monolith. And it's not human readable, and you also might need better testing because it's not human readable. And it will kind of force you to focus on CI/CD because, well, you'll need to find a way of distributing the proto file and to make them backward compatible or forward compatible or whatever. But you need to make sure that the systems that need the proto file have access to that proto file. And as a summary, it has 4 methods, decouples code. You won't have NuGet package sharing, no code references, and the only reference will be that proto file that you'll be sharing. It will be perfect for polyglot environments, great choice for microservice communication, a way better choice than HTTP clients. And I think the future of web APIs, or some of them, it will be that there will be no more hunting of documentation, no misinterpretation of status codes or data parse errors, because that's an important thing. And also, I believe that if we have a distributed system, these are all about trade-offs. We need to choose the right tool for the job. And as next steps, you might have a look at gRPC web, from browser to your API, HTTP2 as a spec, Proto 3 as a syntax, and what it has to offer. And if you love curl, there is a gRPC curl under development from the community that you might use. You have the ability to make calls from the console. And the book, I cannot leave here without mentioning a book, is gRPC for W developers. It has a lot of comparison with WCF, but also has a lot of info about gRPC as a concept and as a whole. Mark Randall did a very good job with this. And also, I wanted to show you a rider and a cool thing that I noticed. I just started using Rider, and I'm really enjoying it after so many years of using Visual Studio and then adapting to Visual Studio Code and so on. But in Rider, we have something very cool, very, very cool, that you cannot find anywhere else. It's an editor for proto files. So it's the same project that I'm going to open here. And it's a plugin installed. Let's see if I close this. Fingers crossed. So you have this proto file where you'll get some syntax. Come on. So, okay, stop now. For example, in here, you can see what types are available. My computer. Hope it won't die at the end. So in here, it works because my CPU is spiking. In here, you might have some IntelliSense. It will give you the types that are available in Proto and some other syntax hints, which is very awesome because when you first start with gRPC, you simply cannot know Proto syntax by heart, and you need to go ahead and search that. And this tool helps you a lot. Okay, so I'm gonna wait this, hoping that it will be finished and my computer will still be alive. But protobuf editor is called, okay? Plugin in Rider. Okay, I'm seeing some blue stuff. So now I'm seeing suggestions. Okay, so you have here things suggested that are very cool. For example, you can add, I don't know, age. And remember, it's not an assignment, it's the order of the fields, okay? So it helps you write proto syntax in Rider. It's the only part where I found this. Cool. So I think this is it. Thank you for listening. I will tweet the link for the resources for this, the slides and the GitHub. You will be able to run it by yourself. Thank you for listening and thank you for having me. Don't be afraid to ask questions.
Okay, thanks, Irina. That was excellent talk. Thanks for showing Rider there at the end. That proto buff editor plugin is awesome.
It's gold. I'm telling you, it's gold.
Yeah, it's really good. So chat has been kind of blowing up with a lot of questions. So we're just gonna kind of go through them, and hopefully you have the answers. If you don't, that's okay. Maybe we can get the answers to folks later. But first question, and I think maybe this, I don't know if it's a joke or not, but it's a good question. Is gRPC some kind of SOAP evolution? Would it be more suitable to service-oriented applications instead of microservices? And the person continues, where we usually have a service bus for async communication. So is it an evolution of SOAP?
Yeah, I can say that it's somehow an evolution of SOAP, but some people also say that GraphQL is also an evolution of SOAP. So I know Michael is up next. So no, it depends. If you have service bus and you also have messaging inside your system, then yeah, I think there is no point of using gRPC. But when you first start with the microservices, the go-to option for all developers, I promise you this, is making HTTP clients and distributing them. So this is another way of making another step into evolving their architecture. Okay, let's try gRPC if we still have point-to-point communication. It's very neat to use.
Okay, very cool. Thank you so much. I think Rachel, you have a question?
Yeah, so Joel asked if you can use gRPC in clean architecture and what is the best way to do that, considering some things like authentication, using identity or identity server.
Regarding authentication and securing things in gRPC, I advise them to have a look in the Mark Randall's book. It's a free book that they can find on Docs. That free book mentions a lot of things about authentication. You can have per call or per channel. You can have JVT tokens, pretty much everything that you have out there. If you have REST APIs, for example, you have things included in headers. And in here, you might include those things in the channel when you create the request and so on.
Yeah, I noticed in your samples you're using an ASP.NET Core NuGet package developed by the team at Microsoft. I also noticed it's actually gRPC is based on HTTP2. So yeah. It almost makes sense that it's built on top of the ASP.NET Core stack, which means you can just add any kind of middleware or identity server in this case, and like your gRPC calls will flow through all those registrations that you made. So is that correct? I
Yep.
think so.
Yep.
Okay,
it's
awesome.
on .NET Stack, so everything that's out there can be used as long as you know where to plug them in gRPC, and as long as you're getting familiar. Okay, you have only post requests, you can mimic headers, but you can have other infrastructure on top of it, like that channel that you're opening to for communication, and that can be secured.
Yeah, I mean it's nice from a technological standpoint because if the last person asked about SOAP, I know people are asking about WCF, but you don't have to worry about like envelopes and security,
no.
like those difficult features of those frameworks that maybe turn some people off. So gRPC
Indeed.
Yeah.
So,
very
as
cool.
I mentioned, the gRPC is compared with WCF as being an evolved WCF. It has a lot of things over WCF, but indeed, it depends on what world you're coming from.
Yeah. So one other question I think a lot of people were asking in different variations is you showed how you link those proto files from an existing solution, right? So it's on disk, but once you start to scale out your infrastructure, how do you share those proto files? And a follow-up question from Martin, our colleague from earlier. Once you start to scale up, how do you version those proto files so that you don't break clients?
Indeed, it's a tricky part, but how do you share those files? It's up to you. You need to have a mechanism. It depends on how you use Docker, you use what. So it's a simple file that needs to get to a specific location overall. In terms of versioning, you need to rely on the versioning that protobuf syntax offers. You can mark fields as deprecated and so on. So it's still a problem, and the versioning part is still a problem even in REST.
Yeah, I mean, versioning is very difficult to do, so it takes a lot of time. So, Rachel?
Yeah, so Tom's asking, is it possible and recommended to dump WCF altogether in favor of gRPC? Might there be features in WCF that are not available in gRPC, such as binary data transmission, named pipes? Does gRPC always use HTTP2?
That's a very good question. I don't know. By default, it uses HTTP2, but I cannot tell you if you can switch it with something else. By default, it's HTTP2 because it was made for performance. And I think it's a good idea if you can get rid of WCF because it's an old technology. And as far as I know, it's not kind of maintained. Always moving on to new technology it's good for the business, at least, and for the developers that work with at that business. It has all the modes that WCF has. They can find a lot of things inside that book. Full duplex is bi-directional communication, and the thing is that it happens inside one single TCP connection, which is cool.
Yeah, I mean, I think I read in the documentation you can go down to HTTP 1.1, but it's not really recommended. You kind of lose the benefits of gRPC at that point. So,
yep.
Yeah, I mean, a follow-up question I had was, have you heard anything about, as the .NET team starts to move towards HTTP 3 protocol and QUIC, how will that impact gRPC performance? Will it get better? Will it stay the same?
I think they're studying QUIC and HTTP 3, but I personally didn't heard anything about impacting gRPC at the moment, because there are a lot of things that people that are adopting gRPC, and I think they will allow gRPC to function as it is for a while without creating too much damage on these people.
Okay.
Because it's still new.
Yeah, it's still pretty new. So thank you. Rachel, do you have any other questions?
Yeah, there's still more questions coming in. So is it easy to set an NLB that serves several gRPC servers in a farm or cloud?
To set up a what?
An NLB.
I think it's a load balancer. I think that's what that stands for. Yeah.
I don't know if it's hard. I never did it. But it's still a server that exposes things and that can be called. So I assume from intuition that is as hard as it is for a web API, for example. It's still an endpoint there somehow.
Yeah, I would also assume that too, right? So it's on HTTP2. Any scaling that you do on a web server, you probably do on these endpoints as well. So,
Mm-hmm.
I guess another question. You know, that we saw a lot of code generation. I think source code generation is the topic of the day here today. But we saw you generate C# code. Is there any way to actually do code first gRPC that you know of?
Nope. But I might be ignorant in this. No, I don't know.
It looks like the proto files are a good way to kind of do design first. So I'm not sure code first gets you anything, but I know people coming maybe from Entity Framework might like a code first style. So, yeah.
Well, since we're on the subject of generation, Oleg was asking if gRPC supports JavaScript client Java generation.
We need to look at protobuf. Protobuf. Yeah, it has the JavaScript, Java, and other Python. I think it's on developers.google. I think they can find there all the languages that are supported. Not all of them are supported, but the important ones are there.
Did Oleg
C++,
mean
C#, Dart, Go?
Yeah. Did Oleg mean though from like JavaScript from a Node.js perspective, or JavaScript from like React or Vue?
Oleg, if you want to chip in here, he did not specify. Yeah. Also, Michael, who's up next, said he's listening. You said something 10 minutes ago, and I just see a what in the comments. So I'm very interested in this one.
It was about
the
soap part, I think. The soap part with.
Well, Martin suggested we bring Michael in early, and you folks can have a protocol death match. But
you should have a separate show for us.
Yeah. I guess we're still waiting for Oleg to kind of clarify from that perspective. But
well, in the meantime, there was a few people asking for if there's any samples that you happen to have, and specifically samples of gRPC with Blazor. Yeah, Blazor's the hot thing right now, as well. And
I don't
Martin
have
just
Blazor,
posted slides, nothing with Blazor.
But there are a few on. I noticed a few circling on Twitter, I think.
I was going to say, I seen a few from Googling and just kind of poking around to see what's going on with this. So they're out there, folks. Go ahead and just do a web search. I think they'll come up quickly.
Yeah, I'm still looking through the questions here. Let's see. You know, I guess gRPC was really built by Google. I think you mentioned it was like called Stubby when it first originally was created. What problems were they trying to solve? And as people adopt gRPC, where are some places that you've seen gRPC start to pop up in technology offerings?
To be honest, I don't know what what were the problems they were trying to solve. I think about serialization and let's say polyglot environments. I think at that moment in 2001, it wasn't that cool. And I'm seeing a lot of projects that have WCF moving and changing to gRPC. I mean, that's the go-to option, WCF gRPC. And now with gRPC Web, they will also be able to communicate with the gRPC server directly from the browser. And developers might have a look at that. It might be interesting in terms of development in future years.
Yeah, if there's like a use case out there or like a technology that has adopted gRPC, like what would the flagship product or tool or company, obviously Google, but other than Google, be using gRPC today? Like where would people look to I guess, learn more about gRPC from a company doing it?
Good question. That I do not know how to answer. I really don't know. I mean, protocol buffers were there as a concept for a while. Avro also was there and beating with gRPC. I don't know. I will have to look into it, and I will promise I will create a blog post. It's a very interesting question. Never popped into my head.
Yeah, I guess I've seen Microsoft starting to use gRPC and Dapper, which are their microservices framework. I know Rachel had Labrina on a while back.
Yeah, and I think we have a talk coming up today with those topics in it. Today or tomorrow, later. It's on our shift. So
yeah, so yeah, that's kind of where I've personally seen gRPC kind of pushed inside of microservices frameworks, and frameworks like Dapper and stuff like that. So do you have any other, did anybody else kind of bring in any questions, or I only really see one more, Rachel.
did we cover the bit of differences between SignalR and gRPC and the relationship there?
No, I mean, I guess that's a good question to ask.
There's a few questions on that, like how does it differ from SignalR?
Well, it's not the same. SignalR uses WebSockets, right? As far as I know, and it has different purposes. I mean, this should be somehow server-to-server communication, when SignalR is server to clients, like front ends and so on, push notifications and everything. But just just crossed my mind. gRPC IO, if people want to have a look. There are a lot of resources. Apparently, gRPC it's used by Netflix. Just to answer your question, I forgot about gRPC IO.
Yep, I shared that gRPC IO in the chat, so folks can kind of go look at that and kind of see who's using gRPC, what gRPC is about, and how to define your services and contracts. Yeah, I let me see here. I think there's one more. You know, from your recommendation, you kind of hinted at it in the last comment. You said, is gRPC really for building internal infrastructure? Can people use it for public APIs? What's your recommendation there?
Can you repeat that? I'm losing connection.
Oh, I'm sorry. So if someone's choosing gRPC, would they pick it for more internal service-to-service usage, or would you recommend gRPC for public APIs?
No, for internal usage for sure. I mean, service-to-servers, point-to-point communication. If you do not have messaging involved, for sure it's the right opportunity to use gRPC. But for public-facing APIs, well, REST as a concept, or JSON over HTTP, still it's the go-to option. I mean, it's understandable. It's easy. It's readable, first of all, and inside your code, you can do whatever you want in there. But when you come with your code to the public and you expose it, then something that is human readable might be nice.
Yeah, I know our next guest might recommend a different protocol for APIs, right? Yeah. So, you know, on that note, that's probably a good segue. And we just want to thank you. I think that was a great talk. And folks building infrastructure should definitely check out gRPC, the binary serialization that you showed from the different types of methods. Or the different types of calls. That was really, really cool. So thank you. JetBrains thanks you, and thank you for being a great speaker.
Awesome.
Thank you for having me
again.
Yeah. See you later. All right. So Rachel, you enjoyed that talk, right?
That was awesome.
Yeah, it was really cool. I think gRPC is definitely a winner, especially if you're building internal services and different teams. The ability to stream stuff is super cool.
Right.
Yeah. But, you know, if you're building a public API, I think that's kind of where our next talk is really going to be interesting. And if you're building client-side experiences, I think that's even cooler.
It's almost as if the person who scheduled this, Martin, almost knew these would fit together so perfectly.
I will say Martin wanted a death match, so whether it was
we all do.
So, I mean, on that note, we'll bring in our next speaker, Michael. I'm sure everyone's seen him online. He speaks all over the place. So I'm going to add him to the stream. Michael.
Hello.
Hi, everyone.
Yeah. So I'm sure everybody knows you from, your GraphQL talks and just pushing and evangelizing GraphQL for .NET developers. So I'm really excited about your talk. I've kind of waffled myself about GraphQL. I come from more of like REST background, HTTP over APIs, but I think I'm starting to warm up to GraphQL personally. Rachel, I don't know what your thoughts are.
I like it. Mm-hmm. The only thing was being from a .NET, very heavy .NET background. It's been a long time since I've ventured outside of, the Microsoft arena because they pay the bills, right? This tech stack. And so GraphQL was not made with .NET in mind. And so there's a bit of a disjoint, which I think, the hot chocolate product and some of that is supposed to help fix that a bit. So that disjoint was kind of a bit annoying, but now we have Miguel, who's out there helping us fix that and not have such a disjoint and be able to actually use it in .NET. So that's a good news.
Yeah, I think by now we are not anymore in catch-up mode. We are up to par with a lot of the leading platforms, especially in the server. We are one of the fastest GraphQL servers out there. And I think also feature-wise, we are now playing up with the great GraphQL frameworks on the Node arena. So, yes, but it's fun to evangelize the .NET community about that.
Yeah, I mean, again, you promised to blow my mind, I think, on Twitter. So I'm kind of excited just to watch and see what you can do, both with GraphQL and Blazor. So on that note, I think Rachel and I are going to dip out, and then we're going to give you the stage here. So thank you so much.
Thanks. Okay, that are quite some expectations that I have set there. So, and today we are talking not about the GraphQL and hot chocolates or the backend side. We are actually exploring GraphQL and Blazor, the GraphQL and the client side. And that is one area where .NET really was behind. And still in this area, we are playing catch up. Because there are great libraries like Relay for JavaScript, which is the library that Facebook actually maintains, or Apollo, which is, I think, the most widely used GraphQL client out there. But I'm not talking about Node or JavaScript today. We are exploring Blazor and GraphQL, and I think they are a perfect match. And if we think back, when was the last time we were able to build browser applications for .NET? I mean, real browser applications that run in the browser. And it's actually when we had Silverlight, but Silverlight was never that great. I didn't enjoy it that much because it had so many limitations in .NET. And that kind of is changing since last year when Microsoft actually introduced Blazor that runs on WebAssembly and removed this, I would say, this taint of having to have a plugin in your browser that runs .NET. But we will dive into this topic today. So, and just let me switch here to my pointer device. But we are actually trying to go a bit further with this and trying to push Blazor to the next level by removing the friction of data fetching that other technologies really have for front-end developers when you interact with your backend. And I could name that gRPC or REST, and I think we can do better, at least for the public-facing API. Just a hint, all the big companies, all the big internet companies like Facebook, like Twitter, like Airbnb and Netflix are using GraphQL for their front-facing APIs. But they're using gRPC or Thrift for their server-to-server communication. So gRPC and Thrift and GraphQL are not mutual exclusive. You actually can combine them very well. Okay, I know a lot of .NET developers still don't know what GraphQL is. And I don't want to do the whole introduction today. So we are doing a 3-minute introduction into GraphQL because I have so much code to show you. Okay, let's get started. This, we could say, is the hello world of GraphQL. In this request, this is a GraphQL request. We are asking our GraphQL server to give us the currently signed in user and the name of that user. And if we send that to our GraphQL server, then the GraphQL server will send us back a response that closely aligns with our request. And that is one of the key features of GraphQL. It puts us in control, the front-end developer, in control of the data. So we don't have, you could say, we don't have pre-set up requests like in REST, where it's all about endpoints and resources and stuff. In GraphQL, it's about the developer that builds a component for his or her front end and decides that he or she now needs a certain kind of data. And so with GraphQL, the front end developer is in the driver's seat, defines how the interface between the server and the front end really looks like. Okay. And as our components change, or we build new components or switch to new devices, so are our requests changing. And since we are in control of the requests, we just can decide to drill into more data or less data. In this case, we want more data. In this case, we want to also fetch the profile picture of our user. So we are drilling in and getting some details for our profile picture. At that point, we can already see that GraphQL is not about flat data structures or sparse fields. It's actually about trees of data. We can drill into our relational objects of our graph and fetch really what we need. And this becomes really powerful, not with things like an image or so, but when we think about connections in a graph. So for instance, we could fetch not only the user that is logged in, but also in the same request, the friends of that user. Think about Facebook as an application where we want to show the online status of the friends of the user. We could fetch the user information in the same request as the online status about his or her friends. And this really gets rid of the problem of cascading data fetching or data waterfalls that we have with gRPC or REST. And allows us really to focus on our UI components and on the data we really need. And when we look at our GraphQL request here, we kind of see some repetition, which is not nice. Like for the currently signed in user, we are fetching name and last seen. And for the friends, which is a list of user, we are fetching actually the same data. But GraphQL has us covered there, because in GraphQL we have a concept that is called a fragment, and a fragment is basically our primitive for composition. It allows us to build fragment hierarchies as we build component hierarchies in our UIs, and we will see that when we go into our examples, and class hierarchies in our backends. So even if you're doing server-to-server communication, fragments really can help you shape the interfaces that you have. Think of fragments as reusable data shapes. Okay, so let's sum that up, what GraphQL really gives us. With GraphQL, we only have one endpoint, because we only need one endpoint, since the user that is using our GraphQL endpoint defines what requests he or she wants to issue to that endpoint. And that also means that we can fetch all the data that we need at one specific point in time in one request. And that gets rid of the problems of the over or underfetching problem that we used to have with REST. And that is specifically that's very crucial in setups where you use maybe mobile applications, where you're fetching maybe data on an unreliable internet connection, and if you have thousands of consecutive requests, this will really slow down the user experience. With GraphQL, we can fetch all the data, as I said, in one request and be done with it. And GraphQL is built on a strong type system, and that is a very crucial thing that is also different from things like REST. Since GraphQL is not only a schema telling you, okay, the data looks like that, this is really enforced by execution engine in the backend. So you will never get a string for an int or a nullable or null for a non-nullable type. And that makes GraphQL predictable to use for the consumer. Okay, before we head into some proper code, let's also have a look at Blazor, because it's still very new and a lot of .NET developers still are unfamiliar or put it in a corner. It looks nice, but it's not usable. Microsoft will anyway cancel it or something like that. And I think Blazor is actually a really interesting approach, and I hope to see it grow further. So we are talking specifically about Blazor for WebAssembly. So what does that mean? I said we are going to put Blazor or put .NET in the browser without any plugin. And that works because Microsoft wrote a mono WebAssembly runtime. It's essentially a .NET runtime that runs on WebAssembly. And WebAssembly is an open web standard that is implemented by all major browsers, except for Internet Explorer, but who cares about Internet Explorer at that point anymore? So it runs anywhere, on any mobile device, anywhere. Okay, so that means actually with a .NET runtime in the browser, we can run .NET Core in the browser. And that really means that we can take all our existing code that we built up in the backend or even in front ends and reuse that in the browser. There are also other platforms that are building on this .NET Core in the browser, or this mono WebAssembly runtime, like the Uno platform. But we are talking today about Blazor. Just a hint, if you are more interested in an XAML-like approach, there is also the Uno platform. Okay, but with Blazor and the power to reuse all the existing code that we have and that we used over the years in our backends, we actually can use less JavaScript in our front ends now and do more .NET. I say less JavaScript, you actually couldn't get away with no JavaScript. But there are so great components in the React camp or the Angular camp that it's sometimes useful to just take this JavaScript component from one of those APIs, wrap it as a Blazor component, so a little bit of JavaScript, and then reuse it in your project. And the really great thing about running on WebAssembly is that your code will run at near native performance, much faster than simple JavaScript code. And all of this, as I said, is built on WebAssembly, which is an open standard and is not owned by Microsoft or any other company. It's really an open web standard. All of Blazor is open source. You can go to GitHub, commit code, file issues. So this is great. So let's have a look at how Blazor actually works. In order to create Blazor UI components or Razor components, we're using a combination of C# code and Razor syntax. You will see that in a minute. The syntax is compiled to a .NET, the components are compiled to a .NET assembly. These .NET assemblies run on the mono WebAssembly runtime that is downloaded together with your components or your Blazor applications to the browser. everything there, it sometimes looks funny when you see that you are actually downloading assemblies by just surfing onto a page. But it actually is super safe because we are running in the same security context as other browser applications, like applications written in JavaScript, because we are running in a WebAssembly VM. And there's one crucial part to this, because a WebAssembly application actually cannot directly interact with the browser DOM. So Blazor has a component tree that abstracts this. You could call it a shadow DOM. And actually, when you're doing, when you're writing your Blazor application and running it, it builds up an internal component tree and mutates this. And then there is a little piece of JavaScript, which is provided by the Blazor framework. You don't have to write it. That batches these changes to the internal shadow DOM to the actual browser DOM. And this works also the other way around. By when the user interacts with the DOM, changes are patched back to the shadow DOM, and you're getting a .NET event. That works great, and this concept is not only used in Blazor, it's used in React, where you also have the concept of a shadow DOM and other frameworks. So it's nothing very out of the ordinary. So let's also have a look at the state of Blazor, because I said Blazor is very new. But Blazor is also already battle tested. When I say Blazor is very new, I'm mostly talking about Blazor for WebAssembly. Because Blazor for the server shipped in .NET Core 3.0. And the Blazor framework actually describes how you can update components. Blazor for a server, for instance, updates the component state via SignalR. So they abstracted how the actual internal Blazor runtime that has its internal component tree batches the changes to the server. So Blazor for server does it with SignalR. And then Microsoft in last year, shipped Blazor for WebAssembly, which now sits in the browser and updates the component tree, as I showed, through a little JavaScript that patches the changes between the WebAssembly VM and the actual DOM. But Microsoft also started on experimenting with things like Blazor for progressive web apps and Blazor for Electron in .NET 5. And with .NET 6, we can now see fruition of these things, like Blazor for desktop is coming, and it will be much leaner than a Blazor that would run in an Electron application, because Microsoft is there starting to use the native web views of the operating systems. So Blazor is now coming full circle. We started at the server, then we went into the browser with .NET 5, and now we are going to the desktop and mobile applications. And this is really great, because if you think about that, all the knowledge that you started to gain in writing Blazor for server apps, you can now use to write real SPA applications that run native in the browser, and soon you can use that to build desktop applications. And this is a great code share. I think it's even better as the concept of React and React Native. And I'm not saying that Blazor is anywhere near React, but I think the difference between React Native and React is much larger than between Blazor for desktop and Blazor WebAssembly. Okay. Let's code. And this is where we get our hands dirty. And what I want to build today is a Blazor application that represents a conference app. And we do some simple tasks to fit that in our 1 hour slot here. So essentially what we want to do is list the conference talks. So a simple session list that we can page through. Then we want to be able to edit these conference sessions. And last but not least, we want to put some real-time magic in there so that we have some social messaging, and you can help me debug by sending me in messages that will run into my debug session on my very iMac here. So with this, let's start building something. So the data for this application I stole from the or actually not stole. I downloaded it from another example that Microsoft did. And they actually took the data from the NSC Sydney 2009. So all the sessions that you see there were actually conference data from the NSC 2019 in Sydney. Okay, so this is a Blazor application. And I just did some basic setup here. So I essentially put the Strawberry Shake packages in and the Strawberry Shake source generator. So Strawberry Shake is also a great application of source generator because we are using source generator to compile GraphQL into .NET. And that means we give you the full typed experience with IntelliSense and all that you can think of when you're thinking about building .NET applications. And we do that across all the IDEs. Today, we will have a look at Rider because we are here with JetBrains. And just let me hide that. Let me just walk you through here. So this is a basic Blazor application. And as we expect, a .NET application always starts with a program CS. And we have in Blazor a WebAssembly host builder, which is as convenient as you have in the backend if you build a ASP.NET Core application where you have a web host builder. So this is kind of familiar. The only difference is that we have here, instead of middlewares or something like this, we have root components. And these are actually our UI components. So this application, as far as it is at the moment an empty application. Let me just do a .NET watch run. And let's have a look at it. It's starting. Localhost 5000. Not yet there. So a simple conference application. We have a home page and, as I said, a page where we can then edit our sessions. So let's start with that. So in GraphQL, when you start thinking about components and what you have to build, you start also thinking about data. So in this instance, we want to build a session list. So the first thing is we want to build a GraphQL operation or GraphQL request that fetches sessions. So in Rider, we can now right-click here on our project and say, OK, we want a GraphQL file. And then we say get sessions. And yeah, don't ask me again, just add. Oh yeah, and in GraphQL, we have three kinds of root operations. In order to fetch data, side effect free, we say in GraphQL, you write the query. So we would start with query, and then we would give this operation a name. This is our name, get sessions. And you can think of this like a C# method, where you write now a method that represents your backend call. And next, we can just see what we have here in request. We have IntelliSense, so we can just pick sessions, and then we can drill in. From the sessions, we want this flattened list of nodes, which are the actual sessions. And from that, we might want the title and the ID, and it's great. We already have our first request. We could go with that, but I said we want paging. And we can have a look at these arguments here, because fields in GraphQL can have arguments, and I can see there's a where clause that I could define. I could define orders. I can take the first 10 items, so I can provide some additional paging context. I already prepared the request like it actually should be. To not bore you with my typing experience here. So in this case, we are creating our get sessions operation here, which gets in an after, a variable called after, which is a string, and by default, it's null. And this is actually a GraphQL cursor that lets me page through this data set. So essentially, when I get the first page, the first 10 items, I will get in this page info here an end cursor that I can then provide back to this function to get the next set, and so on. OK, so let's build a component for that. So first we compile its source generator, and that means it will generate some code for us. But we have a mixed approach here because Blazor is also a source generator, and it turns out that source generators cannot generate code on source generators. So since we are also generating Blazor components for you here, we are doing source generator for all the client, and we're doing traditional generation for the Blazor components. The next thing we need to do here is to build a new component, and this new component we call session list. That is our first Blazor component. So let's call it session list. And let's get rid of this HTML here and just start with the code. And I did forget one thing, because let's go to the imports here. And these imports are kind of little helpers so that we don't get ugly imports everywhere. And I don't want to write imports in my Blazor components for demo.components. So the components I write, I want implicitly be able to add to other components. Okay, with this we can actually start. The first thing we need in a component is some state. So there's a concept in SPA applications about dumb and smart components. A dumb component is, you could say, a reusable component that has no real state. So in this concept, state is passed in from the smart components down the component tree into the dumb components. And if a dumb component wants to interact with other components, it throws an event. So push data down and throw events to interact. So in order to be able to get some data pushed down, we are going to add here a list of sessions. And we already defined here fragment session info. And I told you in the beginning that fragments are kind of important to build components. So the first thing we do here is to add a session parameter, which is a list of sessions. So a list of session info. And as you can see, that is actually my fragment. So by writing fragments in my GraphQL requests, I can kind of define the interfaces for my components that I can then reuse. So this component gets a session list in here. And now we write some markup with it, and then we're done with it. So the first thing, if we have sessions, then we want to show something. So let's do a little if, and if the session is not null, we want to render here the session header and an unordered list. The next thing is we need kind of just a for each over our sessions. And then we just print out our session item. So let's do this. So that's pretty simple. So for each of the sessions, then print it out. And our list is actually done. Our component is done. Next, let's go to our page, our index page, and integrate that component there. So there is a concept in GraphQL clients in the JavaScript communities that is called composition, and we brought it to the .NET world. Composition means that we have for each operation that we create for you, we kind of generate a renderer. In this instance, we generated the getSessions renderer, which allows us to interact with the Strawberry Shake store. I will explain what a store is in a slide later. But just bear with me for now. So this getSessions renderer has three cases, you could say. So the loading case, which is showed why we don't have data in the store and we are getting the data for you. So we can kind of put some HTML here or some components here that represent your loading state. Then we have the error state where we could print error messages, something went wrong, and so on. But we don't have errors in demos. And the third thing is the content area, and that is actually what is rendered when we have the data. So in our case, we are introducing here our getSessions list that we just created. But our getSessions list needs some state. So we need to put in some code area here to put some state for our component. In this instance, we need an after cursor. So let me put the after state in here. And that is a string we want to pass into our request. Just remember here our get sessions request. So next, we put our component in here, which is the sessions list. Just let me fix that. Okay. And the component gets its data as a context from the get sessions renderer. And this is what composition means. So the outer component does all the complicated stuff with interacting with the reactive store and getting the data. And then it pushes it down to the component tree. And we just can pass it to our DOM component. So we are not done yet. We want a page. So we need some kind of a next button here. And this next button just takes from the data that's pushed down the component tree the end cursor and assigns it to our after cursor. So for each argument that we have in our GraphQL request, we have in our component here an argument. So we can just paste in the after, and we are done. Our component is finished. It will fetch data. Everything is fine. But we need to set up the client first. So a storable shake also just generates you all the dependency injection code. So you just have to say services, build up services at conference client, then define your protocol that you want to use. In this case, we are using configure HTTP client. So we are using the HTTP client factory from Microsoft beneath that. So you can use things like Poly and stuff. Next, we are assigning the base address and we are done. While I'm talking, this should already be refreshed, and we can go to our site, refresh that, loading, boom, our data is there, and it's pageable, and there was almost no code involved. It was just, I defined my data request, I created a DOM component, essentially a bit markup with some if clauses, what happens when no data is there, and I'm already able to just page through my data. And I only fetch the data I really need. So I also have a low bandwidth usage. Okay, so I talked about, first let's cheer, we did it. But I talked also about state management, or about stores, and this goes into the subject of state management. So what do I mean with state management? So when a response, a GraphQL response goes into our client, it actually is normalized into entities. So we analyze the GraphQL schema for entities, and you can give us hints what are entities and what's not. So we decompose these or normalize these to entities, and we are putting them in a store. And if they are already in a store, we will update the data that is in a store. And then we are creating from these normalized entities the actual result that you are using there, and put that also in a store. The operation store actually watches the entity store. So every time another request might update an entity that I'm also using in the current request, my renderer is updated and the component re-renders. We will see what that means in the next demo. So how does it work? So actually the generated client does not fetch the data. It actually just asks a store for data. So it essentially says, okay, I have this request. Can you give me the data for this request? And if the store doesn't have the data for this request, the store will delegate that to the actual middleware that fetches the data from the GraphQL server. And when the data comes back, it is normalized into entities. Then it notifies the operation store that now the entities are there for this operation request, and then the operation store will update the component. So let's see what that actually means in the next demo. Okay, let's go back here. We stay in the same application, and we just make it nicer. Okay, the first thing we can do is we go back to our page and we change something that is called a strategy. This defines a strategy. We are interacting with our store. So we could change this strategy to various things. By default, it's network only. And network only, let's just verify that. Network only means let me do this. You can see I'm coming on this page. It's fetching data. And as I go through, it's fetching data. When I go to another page of my application and come back to this component, it fetches data again, which is kind of stupid because I already had fetched this data and it's already in the store. And that is actually where the other strategies come in. And I could say cache first. That means I'm only fetching data once and then I'm keeping it in the store and update it while it changes. Let's go back to here and see if it's already refetched. Okay, I'm fetching data. I'm paging through my data here. Now I'm clearing here. I'm going to my edit session page and I'm coming back and no network traffic is here. Okay, that's good. That's one of the benefits of having a store, using it kind of as a cache and not fetching everywhere data. But let's explore that further. And let's do that by making the sessions editable. So in order to do that, let's create a new component that helps us rename the session. Because I don't know if you spotted that, but we have a little spelling error here. That's a keynote, but it should be a keynote. So let's go back to our components and create a new Blazor component that we call rename session. And this is not a typical DOM component. We call them data components. These are components that can interact with a GraphQL operation directly. And as we started earlier, in order to do something, we need to kind of think about what data we need. So let's create a new GraphQL request for our new component here to kind of have a data structure. So let's call this component rename session. And let's put it on the side here. That's a good place. And I already prepared that. But that's our rename session mutation. A mutation changes data, so causes side effects on our server. And we call, in this instance, we are calling our mutation operation here, rename session. And we are passing in an input, which is a rename session input. And if we drill into that, we can see the rename session input here actually gets a session ID and a title. Okay, let's go back here. In GraphQL, we only have top-level mutations. That's a common mistake when a new developer comes into GraphQL and thinks about structuring data. That is not possible here. Mutations are only top-level. Everything beneath a mutation is actually what you get returned from the mutation. So that's a changed state of the server. So we are changing or renaming the session here, and then we are getting back the changed session, and we are using the same data shape that we also used in the get session. So we get the data in the same shape back from the server as we get it back from the get sessions operation. Okay, that's great. So I set data components, and data components in Blazor just means that we are importing here, inheriting here from the strawberry shake data component class. So let me just import that, and it's showing it as red because I didn't compile the source generator, didn't produce this this mutation as of yet, but at this point it is produced. So with this in place, I actually have now a property operation here that I can use to execute mutations directly from my component here. So in order to bind things to it or interact with it, we need again a component state. In this instance, our rename session state consists of a title. That's the actual title that we are editing, and the session. The session is actually what we get passed in from our upper component, and the title is actually what we bind to our input field, and what you could say the actual working copy of the title. Next, we need a parameter to pass in, and that is the session and also an event to tell the component that we changed something or that we have completed our editing. So you can see a session is passed in. We are setting the session state, and we are also setting the title. And then we have an event here that kind of tells the upper component that we are done. Last but not least, we need to execute the operation here. So that's the last piece of proper C# code. So essentially saving the title. So let's put that in. A little async method that uses the operation to execute and pass in the rename session input that we saw here in our GraphQL type. And when that is through, we don't care actually about the returned result in this component. We just invoke that we are completed, and then this component is essentially disposed. Okay, but we also need some markup here. Oh, miswritten. We also need some markup here that will allow us to add this component. Again, if the session is not set, we are not showing anything. If the session is set, we are showing a little edit area where we have this input that I told you before binds to the title field. Then when we push the save button, we essentially get, we are saving the operation, saving the data, and producing a change. Okay, so let's create this edit page with this component. So for this, we go to our edit page here. And the first thing we actually can do is just copy the list here over. So we are starting out with the same list. And then we need some extra state here. So we are putting in a selected session that we can assign. So whenever we click, for instance, on one of those sessions we have in our list, we want to assign this new component state here, which we use to also bind to our rename session component. Second, we put in our new component that we just wrote, and that is the rename session component. And this, let me just get rid of these guys. This actually binds to the state that I set up here, and also puts in here a delegate into the event that sets the selected session to null when we are finished. So essentially clears out the area, and then we'll also hide the edit components. Okay. With this, we are almost set up, but if we remember our list, we actually remember that we don't have any way to have an edit button there. It's just a simple list of a string. So we need to kind of update our session list to also allow for scenarios where we want to edit in our session list. And for that, we actually need two new parameters. One maybe that is a flag that allows us to edit or to select sessions, and the other like an event that is triggered whenever we went first. This guy here. And when we essentially click on a session, we want to have an event payload, which is a session info. Again, the fragment that we define once, we are passing around our components. In a proper application, you would have more fragments for the various use cases of your components. Okay. The second, we need we need an allow parameter that allows us to select. Essentially, it switches between these modes. And then we kind of just write a little bit of if clause here. When allow is select is enabled, then we want to insert an edit link here that is not only a text, maybe with a nice button. Okay, I don't have the HTML capabilities to do that, so you get an ugly button in here with an ugly pencil. It will look hilarious, but okay, that's the best I can do for HTML. Okay, with this, whenever we allow select, we will render this edit link. And when you click on this button here, we invoke the onSelected session and pass along the session of this row, essentially. Okay. With this, we are good to go. I just think we need to put in here that we want to allow this stuff. So essentially, we need to use our new delegate here. So when on session selected is triggered, we kind of want to set the session that is passed along on the selected session. Still feels some kind of weird to have C# expressions in these HTML syntaxes, but okay. And after that, let's pass in the true. So this is a selectable session. It allows us to select things. And it should already have been recompiled. No, it's still working on it. And there we are. Let's refresh. So now watch this. First, let's talk about this store. I'm paging through our index list here, fetching data, going to the other component, but the data is already fetched. So I can browse through this, but all the pages, they are fetched. Going back here, no network connection. It's all done on local data. And now I want to edit this invalid title here. Let's fix that. The edit area is showing up the moment I click on it. No server turnaround. So I'm doing Keynote here and get that bigger. And these are two different components that have nothing to do with each other. They really have no connection. But I'm saving this, and this component just re-renders. And that's because it's local state. When they update in one component, the same local state, it affects all the components. So essentially, without even thinking about reactive components, you automatically get reactive components to interact with your data. And this makes a completely new use cases possible here without writing a ton of complex code and dealing with state management and things like Fluxor or things like that. Okay. So also it's changing this title and it's done. And I'm going here, no network request. I can just page through. The only network request we had is to do that mutation. And this mutation got some data back. And that actually updated the store. Okay, that is GraphQL query. We have a GraphQL mutations. Changing state on the server. There's a third pillar of GraphQL, which is called GraphQL subscription. And this is all about real-time events or real-time data. Let's dive into that topic. What we're going to do for our Blazor page here is we are going for the start page to allow attendees of the conference to write in social messages like great conference, great, was in a great session and stuff like that. How do we going to start about that? So again, we are thinking about data that we need for our component to make this happen. So we are starting with a GraphQL file. So adding a GraphQL file here, which we are calling on message received, shall be our GraphQL file. And I already prepared the request on message received. And it's very simple. We start with subscription, like with a query. It's almost written like a query or exactly written like a query. Just the keyword changed here. And then we can pick essentially from our events here. So we have a couple of events on session schedule. So when a session is scheduled, that could be some case when sessions are made public and we want to then show them off in real time in the application or something like that. So there are more real-time events here. And in this instance, we are using this social messaging, so on message received, and we are getting back a message. And from that message, we only want the body. Okay, so essentially the text. So we compile that, and then we start creating our component again. It's the same workflow like doing a simple mutation component or data component. Again, like a mutation component, we are creating a data component because we want to handle the subscribing to the data. We don't want to let the renderer do it. We actually want to get our hands dirty. So let's call that social message messages and get rid of the HTML here. And then we put in our inherit, again from data component. And in this case, we are using the onMessageReceived subscription. The next thing is that we, again, need component state. And we don't want to have all the messages there. We just want to have the most 5 recent messages there. So let's have a state, a list as a state here. Yeah, a list of strings. And next we need some code. So essentially when we initialize our component, we want to subscribe to our backend, to our subscription. And then every time a message comes in, we want to add that to our list. So let me walk you through that. So on initialize, so when the component is initialized, we're taking our operation, but instead of executing like with the mutation, we are now watching this component. And watch returns an observable. And then we can use System Reactive from Microsoft to essentially sift through our things here. We only are interested in successful results, for instance. And then we might want to only have the string of the body. So we are not actually interested in all the other structure of the GraphQL response. We just want from the successful result here, the body. And then we have the subscribe method, which is called for every new message that is coming in. There's one guarantee that we are not calling the subscribe message multiple times in the same thread. So it's synchronized, so you get one message after the other, so you don't have to implement any locking here. So that's why we can just insert our messages here. And then if we have a count higher than 5, we just remove the last one and tell Blazor that something has changed, state has changed, and re-render the component. Okay, last but not least, we need some markup here again. Sorry. Could also write that, but it takes longer than the templates. So what we want to render here is if our messages, if we have more than one message, we want to show this what's new header, and then just render the messages as an unordered list, and then we're happy. Okay. So this, we go back to our component here. We only want to show these messages if also the session list is rendered. So we are just packing in here the social messages component. And then we could just run it. But subscriptions are real-time events, and we are just using an HTTP connection. GraphQL is actually transport agnostic, meaning it can use a gRPC as a transport. It could use WebSockets as a transport, SignalR, or what have you. In this case, let's go with the standard that you use for subscription, and that would be a WebSocket. And you just can chain in here the transport protocol. And I'm just doing this. So essentially, we built kind of an API like for the HTTP client factory, where you can pass in the client. You get in the client delegate that is a socket client, and you can assign the URI, put something like poly in that handles socket interruptions and stuff like that. And with that, our client is actually ready. It should be recompiled. It should be there. Let's make sure. Okay, it's there. And you can now help me debug that. So let's go here. Grab this URL if you can. I can put that in the chat. And I'm going back to my client here. Let's see if that works. And also if some of you are still awake, I hope. And you can see it's real time. So it's coming in. Let's see if some of you picked that up, because there's a little time difference. And hey, you can see it now. Because there's a little gap between streaming it and me saying it, and you pick it up 2 minutes later. yeah, you can see that this data is coming in real time, and it was quite easy if you think about how easy it was to put these components together and get this all set up. It was not a lot code. It was quite fast to do that, and gives you all these capabilities about these components that update reactively. Yeah, I quite like the outcome of Strawberry Shake. So the next thing we have one more thing to discuss. I think it is not enough time for code, but it's regarding Xamarin. Like this not only works in Blazor, it also works in Xamarin, and you can use it to build nice Xamarin mobile applications. And there, this store concept brings you even further, because think about offline applications. And since we have a store there, it's very easy. It even starts out passwords. Awesome. If you think about the store concept, state management, you kind of can just hook up some persistence, and it really is done quickly. So let's go back to my slides and talk quickly about persistence. So we have these two stores, entity store and operation store. And these stores actually work with immutable data structures. So every time I change something in the store, we are creating a snapshot of the store. A snapshot just holds the difference, right? But you kind of can subscribe to these stores and then just persist what these stores produce. And this allows you to create applications that when they start up, just take the persisted state and load that into the store, and then just work from there. Fetch data after they already display the data. Think about applications that come up, immediately have data, and then just fetch the changes from your backend. And that enables really cool use cases on mobile applications. And that's actually where GraphQL was born, because Facebook developed GraphQL because they had problems with the data fetching between their mobile applications and their backends. So this is really the home turf for GraphQL, solving mobile application issues. And just let me show you how easy that is to hook that up. I'm not coding that. There's still new messages in. No, there is no drop table possible. But let me stop that. And let's just go into the persistence demo. Okay, so how difficult is it to set up a persistence project? It's pretty simple, because the only thing that we have to change to our setup that we had in the other application is one package. And this is the persistence SQLite package. And you can write a different persistence, use something different than SQLite, but we implemented it for SQLite. And we are also working for support for IndexedDB for the browser for Blazor. So you could also use that storage and others. So with this, if I go to my setup code here, I'm just saying add conference clients, like I did in my Blazor application, then configure the HTTP connection here, and then just do add SQLite persistence, and everything is set up. Just provide the connection string and we will handle the rest. There's one more thing to do. It's essentially getting the persistence and telling it to initialize, and that will pre-fill the data with the local data, and then then you can just use it. And every time you change something, it will update the persistence automatically. So that's a very cool feature which is especially targeted at things like Xamarin or Blazor for desktop or Blazor for mobile applications. Okay. Let's go back to my slides. You survived. You've seen our Blazor approach with GraphQL here. It's pretty new, like a Blazor. so the conclusion here is, with GraphQL and Blazor combined, we can iterate much faster as with REST or gRPC in the browser. Why is that? Because the front-end developer is in control over what he or she fetches. You don't have to go to your backend engineer just because you need a new request. Still, the backend engineers are needed. They need to develop the graph further, put more data into it. But you're the one who picks things from there. And the requests are not like, you have to take this data. You decide what data you want and how you combine that. And with Blazor especially, you can reuse a lot of knowledge and code. All the code that you learned, all the knowledge that you acquired in the backend, you can reuse it and put it to use in the browser. And it feels kind of funky when you start working with Blazor, because you click something and immediately reacts. You have a .NET event, but it's in the browser. And that's kind of what I like about. And the second most thing I like about it is we are doing it with C#, and that's the great stuff. I know React is far ahead, but if you're in the .NET arena, this is, and you want to do .NET in the browser, this is really the way to go. And with GraphQL, we fetch data more efficiently, meaning you only fetch what you need. You build components data-driven. When you start building a component, you start thinking about, how do I structure my data? And that's very different from how we did it before. With REST, it's like, here's the request. Figure out how to build the components with that. And as you have seen, Strawberry Shake is not only a GraphQL client, it's a state management solution that lets you interact with reactive components, makes your UI really live. Like, all the components, all the data is constantly updating and refreshing, which doesn't trigger, like when I use browser applications, often I have a F5 trigger where you constantly refresh the website, and you don't have this feeling when you are working with Blazor and Strawberry Shake anymore. And I know there are a lot of you who think that is cool, but would like to have link. And that's why we are bringing also link support, Strawberry Shake link support, to the next version coming out in end of June. And that will allow you the same features, but for simpler queries, you can use link. Link cannot do all what GraphQL syntax can do. So it's more for people that are getting started with GraphQL and want to get into GraphQL. You can just use the link expressions. Then we compile actually with source generators from that GraphQL and make all the GraphQL magic possible. But for you as a developer, you're using link. Okay. If you like our project, you can head over to our website, chillicream.com, or subscribe to my Twitter feed. I'm Michael Staib. Very easy to find me there. If you like the project, if you like open source, give us a star. That's essentially the main currency in open source. Projects that you like, star them, not only us. And this helps us maintainers to grow the projects. With this, I'm done and are ready for questions.
Okay, that was really, really awesome. My mind was blown. I think a lot of the questions coming in are actually a mix of both about hot chocolate and Strawberry Shake. I know a lot of people are asking more about back-end stuff. So one of the very first questions that came in was, how do you perform optimized database requests? And how does that work with hot chocolate?
Yeah, hot chocolate, that's one of the strengths of hot chocolate, because you can give us almost any database. And with our hot chocolate data package, we actually can rewrite GraphQL requests or part of your graph into native database queries. fetch the data optimized, and integrate that in your response. And you actually have to do almost nothing. It's either with the Fluent API, you say use filtering or use sorting or something like this, and we do all this stuff for you. There is even more coming out with the June release, which will be a huge jump for the entity framework capabilities, where we start to introducing query execution plans. One of the first GraphQL server who does that. And then we'll even look at overlapping data, like where we can see, like you're writing your resolvers and they are written for the optimal path, but then we see that we have some overlapping data in the database, and we can reduce the system load to all the databases by rewriting your actual resolver structure into fetching the data from just one source instead of two sources. So there's a lot of improvement coming, but for the end user, it's just plug and play with Hot Chocolate.
That's really cool. Rachel, do you have a question?
Yeah, there are several questions about caching, and they're a little bit all over the place. So how about we'll just say, what kind of caching can you do with Hot Chocolate and with Blazor, and just hit some of the main points about caching and what you can do with that.
So caching is differently in GraphQL, and if you're thinking about, so let's start with the client. So in the client, we have the store. That is kind of a cache. We are caching the data of the requests we are doing. And we can dynamically update them. I didn't show all the strategies. So there could be a cache first, where we fetch initially the data from the backend, store that into the cache, and don't touch it. It is essentially updated by doing other requests that have overlapping data, and will update these entities, and we are notifying the components that data has changed. Then there are things like the cache and network policy, where we first look in the cache, take that data, and then in the background fetch from the network and update the data silently, so that your components immediately are there with data and then are getting updated, which is a very good user experience, because you don't have to wait for loading backends. So that's for the client side. There's more if you go into topics like optimistic mutations. This is more in the mobile application part, Xamarin or Blazor for desktop. So in the server, it looks a bit different. Like a GraphQL server is doing queries essentially. In order to cache GraphQL requests on CDNs, it's useful to use, for instance, the GET request. So GraphQL requests can be performed in multiple ways. You can use the GraphQL GET request, which includes the query that you are doing, and then use a standard CDN. This is only true for GraphQL queries. Mutations is having side effects, so they are uncacheable, and real-time data requests are also not cacheable because by nature. If you want to do caching really with GraphQL, there are a couple of concepts around that, like persisted queries, where essentially you compile the GraphQL requests, you export them, you import them into the server during the build process, and then you only send hashes. And these hashes represent requests on the server, and then it's even easier to cache them. There are also integrated caching solutions where you cache parts of your graph and other parts are dynamic. So it's up to your use cases, but there are concepts, and we allow for them in Hot Chocolate.
Yeah, it sounds like there's a ton of options there when it comes to caching. Like
a lot going on. You figure there's several technologies going on here. You have GraphQL, then you have to work also with Blazor, and you might also have a specific database and other requirements and a lot of different layers. So a lot of moving parts.
The fun part about gRPC, also these protocols, is that actually GraphQL is transport agnostic. For instance, gRPC is often used between servers. And we have something called schema stitching or schema federation with Hot Chocolate, where you can essentially split your graphs. And then the public-facing graph is actually a merge of multiple microservice graphs, you could say. And in this respect, we will, with the August release, start using gRPC to do GraphQL requests. So essentially between your multiple graphs in your company, we will do gRPC requests to fetch GraphQL queries. So it's not mutually exclusive. You can either use gRPC natively to talk to your microservice, to aggregate the data for your graph, or even with things like schema stitching.
Yeah, it's interesting you mentioned schema stitching, because when you started showing local storage persistence in Blazor, I had this thought. I don't know if it's a good or bad idea, but it would be cool if you could stitch together a local storage engine with the server side, so that you could basically just talk to one endpoint,
yes.
Right?
And that is coming.
Okay.
It is not called schema stitching. It's called local resolvers. It's one of the features that you can do with Relay. And we are bringing that to Strawberry Shake with the August release. So what that allows you to is just to interact against your GraphQL APIs. So you will essentially define GraphQL queries. And these GraphQL queries are merged from the remote state and also from local state, or even REST. You might have a REST endpoint somewhere. You just want to do GraphQL, then we just plug it into Strawberry Shake, and it makes it GraphQL.
Yeah, that sounds really cool. It actually reminds me of the tool that we use for our guides, our JetBrains guides. We use Gatsby, and I could see people using Blazor to build a similar maybe desktop Blazor experience where they have local resolvers for the file system, or maybe for Bluetooth, but then also be able to call a different API. So there's a lot of cool technology that I think people could kind of integrate. And I'm glad you're doing this stuff, and I think that gives people the opportunity. So again, thank you so much for doing this project. It's awesome. Very cool.
Yeah, it's my pleasure. I really love open source, and that's kind of my night times. That's why I'm constantly chatting, or I'm often chatting to Matthias. Mm-hmm. And the funny thing about OS maintainers, they become very active at night. So when he at the beginning of the streaming said he doesn't know in which time zone he is today, it's actually the OSS timeout, because we are more active at night.
You're like bats, right?
Yeah.
Nocturnal. I mean, I have a silly question, but where can people get that Chili Cream T-shirt? Do you guys have a swag store?
Yes, we do.
For you? Okay.
Oh, awesome!
If you go to the Chili Cream website, you can buy swag. Please do. We finance our website with it.
Yeah, I'm definitely going to buy a shirt. I think it's pretty cool. So, Rachel, do you have any other questions or?
No, but since Michael mentioned the schema stitching, I know he has a talk on this because I've seen it. I think we were at the same conference together, and I went and was able to watch his session on it. And I'm pretty sure they're online. So if folks wanted to check that out, he's got some other great talks out there on this.
Yeah. And the next hot topic, I hope in autumn, will be serverless GraphQL, which we invested a lot. And this will tie into things like GraphQL over SignalR and the new PubSub, web PubSub of Microsoft that we also tie in. Also, people for graph databases, we are integrating with Neo4j, and this is coming in June.
A lot of goodies coming up.
This is almost too perfect of a segue to our next talk. So, Michael, I just want to thank you for your time, your contributions to open source. Awesome. This was a really awesome talk. I'm definitely becoming a convert to GraphQL, but I always have a soft spot for REST. I don't know. That's always going to be there. But
I have to work
GraphQL
more on you.
So again, thank you so much. Thank you for giving this talk. I know people enjoyed it. I enjoyed it. Thank you again.
Great. Thanks.
Thanks. We'll see you later. All right, guys, folks, that was awesome, right?
Yes.
Very cool, Rachel. He did blow my mind. I think when you
it's a great product and a great talk with, like I said, a lot of moving parts, and he takes that complexity and boils it down into something that's very consumable in an hour. So it's quite an excellent talk. And while we're here, folks, don't forget we do have JetBrains TV and the JetBrains channel. Don't forget to subscribe. We're supposed to tell you that, right? Because you love this content. And give a big thumbs up in the comments if you are enjoying .NET Days so far, because I think we all are. And we have Matthew Groves up next, right?
Yeah. Yep, he's sitting in the green room and he's getting ready. I think we can pull him in and just have a quick conversation with him right before the talk. So,
sure.
Matt?
Hi there. I'm trying to find a thumbs up emoji on my phone.
Look, see, literal green room.
So do you have a Mac? Because I've learned the shortcut is Control-Command Spacebar will open up the emoji.
Right. Well, on Windows, it's a Windows period, but I'm using it on my phone because that's where I'm watching the YouTube stream on my phone. So I had to hunt through all the emojis for that. But I got it. It's up there. There's my thumb.
Yeah. So this is really a good segue, I think, from GraphQL into NoSQL databases because, I'm not sure how much folks know about GraphQL, but you write these things called resolvers. And these resolvers can really talk to any kind of data source, whether it's SQL, whether it's a NoSQL data store, or even anything like a file system or S3 bucket in Amazon. So this is kind of a cool topic. I love NoSQL. So
yeah, we're working our way from the front end to the back end, I guess, to end the day.
Yeah, that's a perfect way to put it. I mean, before we get started, how did you get into NoSQL?
Oh gosh, how far back do we want to go? I think my first experience with NoSQL was a long time ago when Xamarin wasn't even called Xamarin and was still in beta, Monodroid, and I was writing some Android apps, and I looked at an embedded object database or object-oriented database for a mobile app. And that's when I first got interested in them and what they can do. And I've always been kind of interested in since then. And I've worked over my career at different places. And, I've dabbled in every once in a while, but it's just always something that was kind of like out there on the periphery. And it's like, I went to school and learned SQL and relational. I've done relational since my very first programming job. And I'm just kind of used to SQL as a language. And so I didn't really fully get into it until I discovered Couchbase, which is what I'll be talking about today. And it kind of combines the best of both worlds, I think. So,
yeah, I mean, I've played around with it a little this week, and it was so easy to get into because of the query syntax. It was very SQL-like, if not almost a one-to-one. So I'm excited for folks to see how easy it is to get into NoSQL. And I guess on that note, it's probably a good time to kind of give you the stage. Rachel and I can kind of step out, and good luck.
Yeah, you guys can take a much needed break. You've been working hard today. Appreciate that.
Yep, thanks so much.
All right. Hello, everybody. And just to wrap up the first day of JetBrains .NET Day, we're going to talk about migrating from SQL to NoSQL with .NET and Dapper. So this is a video that was making the rounds a while back on Twitter, and it's just the guy on the right is putting all the blocks into the same hole, no matter what shape they are, which clearly caused this person on the left distress. So sometimes I feel like relational SQL databases are the hole that we put every block into, but I want to try and take that in the other direction. Can we try to use a NoSQL database as if it were a relational database? And so that's my hypothesis, and I think the answer is mostly yes at this point. And that's what I'm going to be doing with a utility that I wrote called SQL Server to Couchbase. And it's a set of tools that for now, can help you copy the structure and data of a SQL Server database into a non-relational NoSQL document database, specifically Couchbase. And I'm looking at Couchbase because obviously I work there and I know the product very well, but I also think it's the most relational friendly NoSQL database out there, if that makes any sense. So hopefully you'll see what I mean as we go forward there. Just a reminder, I know you all are watching me live, but in case you're watching this recording somewhere else, thank you very much, JetBrains, for having me to .NET Days 2021. If you're watching this elsewhere, definitely check out the next JetBrains event, next JetBrains .NET Days. And also just check out the wonderful JetBrains tools. My favorites are ReSharper and DataGrip. I'm going to show you some DataGrip today, actually. I think it's a fantastic tool that since it came out, I've been using it pretty much almost every day. So I'm very happy with that DataGrip, and we'll see some of that happening today. My name is Matt Groves. My title is now involved the word marketing. So I used to be titles like software developer and developer advocate. Now I'm a product marketing manager. So that means I get to work on a lot of that marketing baloney that developers get annoyed by. But I'm trying my best to make it less annoying and more valuable and more technical focused as much as I can. And this cartoon is what I looked like pre-2020, when I used to go outside and I put on a tie every once in a while. And towards the end of the presentation, you're going to see a cartoon that better represents the state that I'm in now. So look forward to that. You can reach me on Twitter, on LinkedIn, of all those other things, MVP and Pluralsight and blah, blah, blah. Okay, let's get to it. We're going to migrate from SQL to NoSQL. So the tool that I'm working on is kind of like a automatic language translation tool. So if you're familiar with Babelfish or Google Translate, it's kind of in that vein. These are really useful tools to help understand someone, to help learn a language, but it doesn't replace actually learning the language, at least not yet. So things like idioms aren't translated well. On the left here, you see a literal translation. I'm not even sure what the original language is, but the English version doesn't make any sense at all. I'm sure there's some idioms going on here or some sort of context that's absent. And if you're familiar with Star Trek: The Next Generation, there's a great episode called Darmok, and that represents the same sort of concept here. Like, you can do a literal translation of something and completely miss out on all the cultural context around it. So if you've not seen this episode, that is just proving my point even more. So definitely check it out, Darmok and Gelada Tanagra. I'm sure you've heard of that before. But what I'm going to do is try my best to make the Google Translate for databases from SQL to NoSQL. And since I've been using SQL Server a lot of my career and Couchbase a lot of my career, I feel like I'm in a pretty good position to understand some of the context around both and make an attempt at as much as possible an automatic translation. So let's start with my really basic SQL to Couchbase dictionary. So think of this as kind of like a phrase book or like a Spanish to English dictionary sort of thing. We've got the SQL relational concepts in the first column and the Couchbase concepts that match in the second column. And then kind of some notes on what you're gaining or losing in the translation there. Since it's not a perfect translation, because they're not both the same kind of database. So this is SQL Server specific, but I could certainly see MySQL, Oracle, Postgres having a very similar mapping. So the first row there, by moving from a SQL Server server to a Couchbase cluster, the main thing we're gaining there is all the benefits of NoSQL that you've probably seen or heard before. Scalability, able to add more machines to a cluster instead of just traditionally a single machine. You can add machines to a cluster, which also gives you replication and high availability options. And the other thing that Couchbase has specifically is a built-in caching. So it's kind of like, you normally have to pair SQL Server with a tool like Memcache or something. With Couchbase, it's built right in. So just from that, we're gaining all those things. And that's kind of one of the main reasons that people go to NoSQL in the first place. The next row down, in SQL Server, they have things called catalogs. Usually people refer to these as databases, though. And in Couchbase, a similar concept called a bucket. And I know that's an overloaded term because Amazon also has something called a bucket, but this is a different bucket, Couchbase bucket. And then the next level down, we have a schema inside SQL Server. Now, when you're using SQL Server, you might not even be aware of schemas because you may be using DBO as the default all the time. Or maybe you are using schemas for things like microservices or multi-tenancy. If you want to set part of the data to be organized in a certain group that's only accessed by certain applications or certain people, that's what a schema is for. But sometimes you see DBO, and that just represents the default schema. The next thing we do is go down the table at SQL Server level, and that roughly translates to a collection in Couchbase. The difference there is that for create a table, you have to define, okay, here's the columns, the column names, the data types, all those things. You have to define those up front. With a NoSQL Couchbase collection, it's really just you give it a name, and this is a place you can put documents. You don't have to define anything about them. You know, the data types, the schemas, anything like that. You just have a collection, and it contains documents. Now, typically, they're going to follow a very similar model, very similar set of values, but they don't have to. So that's kind of something you're losing there, depending on how you look at it. The next one is a row. So each table has one or more rows. Well, 0 or more rows, technically. And in Couchbase, this similar concept is documents. So a collection has 0 or more documents. A table has 0 or more rows. The difference is with a NoSQL document database, the data format is JSON. So it's a flexible format. You can put whatever JSON you want in there. As long as it's valid JSON, it can go in there, and that's fine. So it can vary from document to document. You know, hopefully not a lot of variance, just when you need it. But that gives it more flexibility there. So that's something you're gaining. So you can see kind of a trade-off here between big upfront design and limitations and constraints versus flexibility, and you know, you have to have a little more discipline about your data. Next thing down in SQL Server, the language you use to interact with it is called Transact SQL or T-SQL. In Couchbase, there is a SQL implementation. This is kind of what we were talking about before slides, is that Couchbase has a full SQL implementation. And you'll see a little bit of that today, but when I say full implementation, I mean everything you'd expect from SQL is there. So joins, insert, update, delete, merge, common table expressions, subqueries, aggregations, all that kind of stuff. It's all there. So this really sets it apart from other NoSQL databases in that you have all these capabilities. So it's a lot more comfortable as a relational developer to make the transition. And as we were saying before, just drop that into DataGrip and run the query, and it might run as is. Maybe some small tweaks. We'll see that later. In SQL Server tables, you can define a primary key. In Couchbase documents and other NoSQL databases, each document has a unique key, and that's per collection. So some difference in translation here. It's roughly the same thing for the most part, but with a NoSQL database, you can't really have a true compound key, right? It's just one key per document. Now you could work around that and use a delimiter in your key. Some of our customers and users do that, so you have basically one key that you break into 2 parts if you want to. The other thing is in SQL Server, you actually don't have to define a primary key on a table. And I think there are very few situations where you'd want to do this, but it's an option as well. And you can't really do that in Couchbase. Again, the workaround would be just put some GUID in there, something meaningless that you're not going to use. And the last thing is index. So depending on your experience with SQL Server, you may not write indexes, you may barely write indexes, or you may write indexes all the time. And the same is true for Couchbase. In order to support SQL queries, you need indexes on the data. So that's kind of the translation card there. And that's the premise I'm going to start with my idea of a conversion app. So let's dig into some more detail. But first, I want to talk about the word migration here. I don't want you to be put off by this word. It kind of implies that we're dropping relational, we're dropping SQL completely and abandoning it for NoSQL. And I'm sure that everyone in my marketing team wants that to happen, but the reality is always messier, right? So instead of saying abandon SQL and migrate to NoSQL, I consider this effort more of a bridge between the two, between relational and NoSQL, a bridge that you can either use them together, or you can make an easier transition from one to the other, or vice versa. So there are many use cases where you'd want SQL to hang around and NoSQL database to work with it. So I'm going to go through each step of the application that I wrote, the tool that I wrote, and show you, what's going on and the code for it, how I'm using Dapper in the process. And I'm going to also point out what can't or maybe shouldn't be automated along the way. We're going to automate as much as possible. But if you do try to automate too much, you're going to end up with Marvin here, the paranoid android, very depressed if you're trying to automate things that really need a human to look at them first. All right, so step 0, first thing we do is we've got to connect to our databases. We'll mostly be reading from SQL Server. We're going to be looking at it. We're going to be reflecting on it. What tables are there? What indexes are there? What users are there? Turn this light on here a little bit. I'll mainly be writing to Couchbase, so creating those things, the buckets and scopes and collections and keys, indexes, documents, users, all that stuff. Now, throughout this demonstration here, I'm going to be using a data set called AdventureWorks. It's a SQL Server, a Microsoft official sample data set. I think it's a really good example for demonstrating SQL Server capabilities as well as a realistic translation effort to a NoSQL database. Okay, so first snippet of code here. We're going to start with a SQL connection, and that's going to be used by Dapper. So I'm not going to go into the basics of Dapper here. There's lots of other presentations and material on Intro to Dapper, but it's basically a tool that you're going to use to interact with relational databases, in my case, SQL Server. But it's just a set of extension methods. So as long as I have an object that implements IDB connection, I can run Dapper extensions on that. So SQL connection here is an object that implements IDB connection. So that'll be my entry point for using Dapper. Second thing is I'm going to connect to a Couchbase and get a cluster object. So now my .NET client will have all the information it needs to communicate to every machine in the Couchbase cluster, just for this cluster object. So as a developer, you don't have to worry about, there's 10 machines out there or 5 machines or 100 machines. It doesn't matter because you're going to interact with it through this cluster object and let the client and Couchbase handle all the rest of that routing business. I've also, throughout this presentation, there's a whole bunch of logger code and some other things that I've removed just to make it easier to fit on a slide and easier to read. But for this type of utility, you've got to make sure to put plenty of logging in there in case things go wrong, so you know where they've gone wrong in the process and how you can deal with them. So the third thing I've got here is this serializer setting. So I'm not using the default serializer. I'm actually adding some custom SQL Server types, and we'll talk about those in a bit. But that's an important thing to deal with if you want to handle as much of the data as possible. Okay, step 1 then, once we've connected the databases, we're going to create a Couchbase bucket with the same name as the SQL Server catalog. So on the left here, I've got the AdventureWorks catalog here. And on the right here, I've got the AdventureWorks 2016 catalog. Now, actually, they're different names here, right? Because this is a situation where do I really want to create my buckets automatically? Because there's lots of things that need to go into the process of creating a bucket and thinking about it. So in Couchbase, how much RAM do I want to give it, for instance? How much replication do I want this bucket to have? And things like that. So these are things that can be configured. So if I'm going to configure those anyway, I may as well just make the name configurable as well. So in this case, I've got 2 different names, but normally they would match. That'd be fine. This is all easy to set up in Couchbase, but it needs some human thought behind them. So the actual flipping switches is just a web form and some drop downs and things like that. But you need to think about how much RAM do I actually need to give this cluster? Is it a development cluster? Then maybe just the minimum. But if it's production, then I need to think about how much RAM do I have per box, things like that. We're not going to get into that too much today. The code for this is, again, none of this is using Dapper yet. We'll get there. But the first thing I'm doing is these are the settings I need to configure a bucket. So as I mentioned, the RAM quota, the name of the bucket, what type of bucket it is, things like that. I'm just pulling that right from config. Got a question in the chat here. What would be the benefits of moving from relational database to a non-relational one? So yeah, I kind of touched on that early on. The idea of being able to more easily scale, handle high availability use cases, and also in the case of Couchbase, maybe some performance gains. We'll talk about that a little bit later as well, because there's a built-in cache there as well, and also flexibility. So if you're in a use case where data flexibility is important and you don't, your data doesn't fit neatly into a relational table all the time, those are all situations where you might want to look into a document database like Couchbase. Okay, the second thing is I'm going to actually create the bucket in Couchbase. It's only going to create it if necessary. So I've already created it manually. This is just going to be a no-op essentially. And the third thing is I want to wait until the bucket is ready and the services on it that I want to use are ready. And there's lots of services you can use in Couchbase. The ones I care about are key value and query. So key value is just looking up documents by their key, and query is SQL queries. So we want to have those both available. I'm going to use both for this translation app. Last thing is we're going to get what's called a collection manager, and this will allow us to create scopes and collections in Couchbase as the rest of the program goes on. All this code is on GitHub, by the way. It's got more logging statements in it, but it's all on GitHub, so you can go. I'll give you the link later on. You can go check it out and try it out yourself. Next thing to do is create scopes and collections, and this is where it actually starts getting a little interesting. So on the left here, we've got a AdventureWorks database, a little screenshot from SQL Server Management Studio. And on the right is a screenshot from the Couchbase admin console. So if SQL Server makes use of these non-DBO schemas, as AdventureWorks does, then we're going to create corresponding scopes in Couchbase. So we've got human resources, person, sales, production, etc. We'll create those scopes over in Couchbase. And then for each table in those schemas, we'll create a collection inside the Couchbase scope. So over here, we've got person, schema, address, table. That's how it looks in SQL Server. It's schema.table. And over here on Couchbase, we've got the person scope and the address collection. So we're just kind of translating those literally over there. Now, there's some manual considerations here, things like access levels. Do I want to translate all these schemas into their own scopes? Maybe for certain applications, only access the person schema or the person scope, for instance, like microservices. Or maybe you're using schemas for multi-tenancy. So you have tenant1.address, tenant2.address, and so on. So you think about that. If you don't really need a separate schema, if it's just there for organizational reasons or whatever, then we can collapse them all into one single collection name. So it's an option that's out there. One other thing, which is pretty cool, I'm going to show a screenshot here from JetBrains Data Grip, is, and actually just kind of discovered this today, is that if you connect to a SQL Server database, it's actually going to organize the schemas and tables in a hierarchical fashion. So unlike SQL Server here, where it kind of mashes them together, Data Grip shows them as a hierarchy, as I would expect them to be shown. So I can expand person and just look at the person tables and so on. So that's a very cool feature I like of Data Grip. One other thing to point out here in manual considerations, did you know that SQL Server allows really, really long table names and schema names, and Couchbase has shorter limits than that? Guess how I know? Guess how I found out? So we have to think about that as well. And if you're using some more of the advanced or obscure features of SQL Server, like temporal tables or calculated values, a direct translation here becomes more challenging. So that's some programmability we have to that's not inherent to JSON data. So we have to figure out another way around that. So again, to manual considerations. It's not impossible, but it's just going to require some extra non-automated work to do that. Yep, so there's person and an address, and then person address on the right. All right, so here's the code. We're finally going to get into Dapper here. And this is why I chose Dapper, because it's really so easy to just drop in a SQL query and start getting results from it. So right here, I've got a SQL query that's going to query SQL Server for all the table names and schema names. And I'm querying from information schema.tables. So if you've not heard of that before, that's basically how you get metadata about stuff that's in SQL Server, about objects in SQL Server. So I'm just give me a list of all the schemas and all the tables that go in them. Then I'm going to construct the collection name and scope name as strings. So this is going to go off the decisions we made about multi-tenancy and microservices. Either combine them into one name, and if they're really long names, like I mentioned earlier, It's actually going to substitute a shorter name if necessary, and it'll do this consistently. That's why I've put these in their own methods. Then we'll create the scope if we need to. We should only have to do that one time, and create the collection if we need to. And the reason I put these if statements on here is because this is a program that's meant to be able to run multiple times. It's meant to be interruptible. So if something fails or something's stuck, we can quit, or it'll end, and then we can run it again and not have to do the same kind of work all the way from the beginning. So I've tried to code that in here as much as I can. All right, the next step is once we've got the scopes and collections in place, we're going to actually start copying data. So if I have a row of data here in the address table, I need to create a JSON document shown here in the address collection. So this looks kind of messy. This is kind of a crammed together JSON view here. So let's zoom in on that document a bit, get a prettier view of it. So this is the translation. I read the data from a SQL query in Dapper. I serialize it to JSON in Couchbase. This is the document key. So this is kind of like the primary key in SQL Server. It's not exactly the same thing, but it's kind of the equivalent there. Notice that the key is also inside the document as address ID. Now, this duplication is not necessary and may be harmful if you think about it in the long run, but it does make translating the SQL very much easier later. So some trade-offs there again. This might be something I introduce as an option in the program, like, do you want to put it in the document or do you want to omit it from the document and just leave it as the key? The other thing is SQL Server has these proprietary data types. So one of them is called geography. You have a geography type that contains a location on the map. And so if you look at that in SQL Server, it's just a bunch of binary, not human readable. So I've imported the Microsoft SQL Server types library, and that will allow me to serialize them to JSON. So you can see here it's got the lat and long, z, all the values you'd expect from geography. This is an area that might need some improvement in the future. There's a lot of data types in SQL Server, proprietary ones, things like the hierarchy data type that might be tricky. Other lesser used types, custom data types could be an issue. So you need to think about that, and copying the data actually could take some time as well. But there's something I've learned about Dapper that I think speed things up for a bulk copy like this. So we'll look at that in a second here. So here's the code to copy the data over. This is the first step. We're going to again use Dapper here to get a list of all the tables. And I want to exclude the temporal tables, the history tables, because typically those are massive and there's no primary key. So we have to put some human thought into those. If you're not using temporal table types, then don't worry about it. There are some very interesting use cases for temporal types, but I'm not going to make an attempt to automatically convert those over. So once we have those table names, we're going to go ahead and start copying the data. Now notice here I have this sample data parameter here. That's in case I want to show this program in action, but I don't want to actually copy 1 million records over, let's say. So I'll be using this later on in the live demo. And also notice pipelines here. I've taken a lot of the pipeline stuff out of this code because I'm not going to cover it today, but the library that I've written allows for some advanced filtering and transformation. So if I wanted to, for instance, just copy data over that's less than a year old, or copy data over but obfuscate the PII, for instance. Those are some things you'd use pipelines for. So now I'm going to drill into this next copy data method here. Show the details of this. I've omitted again a lot of logging here and filtering, transforming stuff. So I want to point out this line here. I'm actually opening a second connection to SQL Server with Dapper, and I'm setting, if you notice there, buffered to false. It's true by default. So from the Dapper docs, I'll just read this to you here. A non-buffered query is equivalent as streaming. You only load objects on demand. That can be useful for a very large query to reduce memory usage, which is exactly what I want to do here. I'm doing a select star on every table, basically. So, copying those all into memory or buffering those into memory could really increase the memory footprint of this program and really slow things down or possibly even cause overflows and crashes and things. So that's why I have buffered false here, and actually ends up, I think, speeding up the process as well. But I can't use the same connection for that. I'll get an error about connection already being in use. So that's why I've opened a second connection here. Now, each row then returns a C# dynamic, an object of type C# dynamic. So I'm using dynamic because otherwise I'd have to create a class for each table. And at that point, it kind of defeats the purpose of automating this. I'll have to create potentially 100, 200 classes or whatever. I guess you could use some code generation to do that if you really wanted to. And the next thing is I'm going to use Dapper to interrogate the table and figure out which columns make up the primary key. So remember, in SQL Server, you can have multiple fields making up the primary key in a table. So I need to figure that out so I can join them all together into one document key for Couchbase. And the last thing, the only line of code here that's really related to modifying data in Couchbase is this line right here. This will put that row of data as a dynamic object, and it's going to serialize it to JSON in the process. I'm using upsert here, which will either do an update or insert, depending on if the object exists or not. Because again, I want to be able to run this multiple times. So I don't want this to fail if the item is already there. Okay. What about migrating to Azure CosmosDB is the question coming in there. Yeah, I would be open to someone contributing a PR for this project to do that. Right now, I'm still, this is kind of an experimental, like pre-alpha effort to convert things over. We'll get to some things in a second here that might make you think twice about taking this approach with Cosmos, though, because there are some things that Cosmos is lacking in terms of fitting a relational model. Okay, next thing is we're going to copy indexes. So all these steps, by the way, are optional. You could choose to skip the indexing step if you want to. But what we need to do here is for each SQL Server index, we're going to create a corresponding Couchbase index. So with SQL Server, indexes can be created with the create index syntax. So I'll just pick one here, the index on the address table for the state province ID field. And the create index syntax looks like that on the bottom right. And that's how you create an index in SQL Server. So since I know that, I can then create a similar index for Couchbase. So this one on the top left here, that's how you create an index in Couchbase. Or no, sorry. The bottom right here, that's how you create an index in Couchbase. So you can see the syntax is very, very similar there. Create index, index name on bucket, scope, collection, and then the fields you want to index. And so I go through and I create those indexes. I calculate them automatically based on the metadata I can pull from SQL Server. Some manual considerations here. So, depending on your experience with SQL Server, my experience has been that SQL Server databases are criminally under-indexed. There's not enough indexes there. There's not the appropriate amount of indexes. So when you move over to a NoSQL database, you may need to add more indexes than you thought you needed because your existing data was not indexed properly. Or the opposite side of the fence, with AdventureWorks, there's a ton of indexes in there. There's hundreds of indexes. And we don't necessarily need all of those when we move over to non-relational data. So fortunately, Couchbase has some tools to tell you, hey, these are the indexes that are being used. These are the ones that are not being used. And also, it has some tools to recommend indexes that might speed up your query as well. So those are things you kind of have to do manually, though. Also, with NoSQL databases, typically there aren't unique indexes available. So again, there's some workarounds for that in maybe with key construction or with eventing services, things like that, that you could replace those. So these are really indexes that are purely there for performance reasons and not necessarily for business logic or data constraint reasons. Okay, this is probably the biggest method in the whole shebang is the create indexes method. I've removed a lot of this here to fit it on one slide because this is a huge query right here that gets all the indexes, their names, and the fields that they index. And I've cut out about 90% of it, but you can check it out on GitHub, especially if you have ideas to improve it, to make this more readable or more accurate. I would love that sort of commentary. But that's a big old query there. Again, running in Dapper to get I just want the index name and the column names and the schema name and table name. That's the stuff that I need. Second thing is I'm going to do some string manipulation to get those fields, to use the correct escape characters. So in SQL Server, the escape characters are square brackets. In Couchbase, they are backtick. I think that's very similar to what Oracle does as well. So I have to, especially if you have field names that have spaces in them or dashes in them, you have to use the correct escape characters. And the last step here is to go ahead and execute a create index statement on Couchbase. There's actually a lot of room for improvement here in terms of deferring indexes and running them all together to make them more efficient. So there's some work to be done there. So right now, indexes are kind of a slow spot in this utility, in creating them for the first time, that is. Okay, and the last thing is we're going to I think the last automated thing I want to talk about today is copying users over. So for each SQL Server user, I want to create a Couchbase user. And for each SQL Server permission that user has, give an equivalent Couchbase permission. Now, AdventureWorks doesn't come with any interesting users, sadly. So I invented one. This user has permission to only 3 tables. So we've got very fine-grained permission here. 3 tables. It has select, insert, and update permission, except for 1 table, which has delete permission as well. So very, very fine-grained permission. I don't know if this is a common scenario of doing this fine-grained permission or not, but I wanted to demonstrate that it's possible in SQL Server and in Couchbase. It's kind of hard to read. I'm happy to show this when we get to the demo. In Couchbase, I do my best to map over the permissions, but the thing with Couchbase is it actually has multiple APIs to work with data. So it's not just SQL on Couchbase. You can also use the key value API. I'm not going to show the code for this because it's a bunch of switch case statements, but this is a reason why creating users, you should really only do this for convenience purposes. If you have a ton of users that have a lot of fine-grained permissions, this will give you a pretty good head start. Otherwise, I would stick to a manual approach here because you don't want permissions to leak through that you don't want the users to have, right? So, and not all users make sense to copy over, right? Do I really need a DBO user on my NoSQL cluster? And then things like LDAP Active Directory, that's integration step that's separate from this utility. Okay, step 6 is we need to convert the application over from using SQL Server to using Couchbase. Now, I haven't actually written anything that can do this, sadly. It's not impossible, but I'm reminded of this XKCD comic. I do have some good news on this, but I just want to reference again that when we're migrating data, we may not actually be abandoning SQL Server. So if we're not abandoning SQL Server, we're not necessarily abandoning the app that uses SQL Server either. We may want that to stick around for a short period of time or maybe indefinitely, depending on what we're doing. But I just wanted to make that clear that this migrate doesn't necessarily mean abandon. We're building a bridge to make a migration forward there and back possible. Okay, so we talked about this early on. We can look at a SQL query in SQL Server, a T-SQL query, and switch that to use Couchbase. So I pulled this query from Microsoft documentation. This is a AdventureWorks sample query, and it returns the first and last names of all employees and the cities in which they live. This is the data that it returns. So we've got Saeed and Kim and Hazim. The first 3 there for Bothell, Carnation, Kenmore. Actually looks like Camation because of the kerning there, but that's Carnation and Kenmore. All right, so that's the data that's being returned. Here's the same query converted for use with Couchbase. Couchbase using the Nickel query language instead of Transact SQL. So I'd be curious if anyone can spot the difference here. So if you can spot the difference, go ahead and throw it in the chat. I don't know. I can give you some bonus points, I guess. I don't know. You can use them on anything, but be curious to see if you can spot the difference between those 2 queries. So some manual considerations here while you're typing in your guesses. That these queries are close, right? But they can't really be migrated automatically. Again, we're back to the XKCD comic of translating one language to another. But the syntax is very, very close. And so if you're used to running queries like this or complex queries like this, you can take that same approach with the data in Couchbase. And hey, Cyber Undead got the answer. Yes, that's correct. It is the concatenate operator. That is the only difference. And oh, Roberto got it as well. Good job. Bonus points to both of you. So Couchbase uses the Oracle style concatenate operator and SQL Server uses a plus. Otherwise, these are identical queries, which is really cool. And this goes back to the Cosmos question as well, is that notice there's a couple inner joins here. As of today, there is nothing like an inner join in CosmosDB. So what, you can't really do this same kind of relational style query with Cosmos. There is SQL, but there's no inner join. There's lots of stuff that's missing from the Cosmos SQL implementation. So what you typically do with Cosmos is then go ahead and consolidate your data, which we'll talk about in a second here. So you can work around not having joins. But with my approach, it's like we're just going to do a lift and shift of the data. We're taking our relational data, putting it on a NoSQL database, and then starting there. And maybe we can optimize it later. Now, some queries will run. Oh, by the way, here's the results. Same exact data. So Saeed, Kim, and Hazim, Bothell, Carnation, Kenmore. Much better kerning this font. Same exact data. So some queries may run almost as is, just like this, but that's not always going to be the case if we're realistic. The syntax is very close, and if you're used to writing SQL, you're going to be very comfortable here. This is one of the things I really loved about Couchbase, is that I can take all the SQL knowledge of one of the most popular languages in the world is SQL, and apply that to a NoSQL database and get all the same benefits from NoSQL with the benefits of relational. Now, indexes. I mentioned this before. Indexes here for this query, they can be reviewed. So is this query going to run? We can check that. Is this running the most efficiently? We can run it. Or is there going to be some better indexing we can use for this? I've also noticed that like address ID is being used for a join here. We might want to change that to join on the actual document keys in the long run. But again, if we're just talking about doing like a proof of concept, lift and shift, let's just try to see if it works, then this is a perfectly valid approach to doing this. Okay, and one thing I wanted to mention, if you're actually using Dapper in production in your application, you can, the basic Couchbase SDK is very, very similar to the way Dapper works. It's, this first example here, this is a Dapper, a piece of code that uses Dapper. So we're just querying, putting in the SQL, putting in some parameters. The second example is the same thing with Couchbase SDK. It's not exactly the same syntax, right? There's a $ instead of an @ and there's this options object instead of just an anonymous object for parameters. But you can see that it's very similar and very comfortable. I actually thought about making a Dapper extension somehow for Couchbase. I think that would be a fun thing to tackle someday. I'm not exactly sure how I'd make it work. I'd have to do some sort of Couchbase implementation of IDB connection, maybe. I don't know. Let's think about that. But that might be a fun thing to do. All right. How are we doing on time? We doing okay on time? Do a quick demo here. Is that all right? All right. Where are we going to start here? Let's see. Let's bring up my, this is Visual Studio here. And I want to show you, this is all available on GitHub, by the way. I'm going to show you just a sample console app that I created that uses this library I've created. And this is the configuration, the basic configuration you need. So here's the connection string for SQL. Here's the connection information for Couchbase. Some other settings, those extra long table names I was talking about, various flags you want to set for this utility. And I've got over here on data grip, here is my local SQL Server database, AdventureWorks. You can see all the schemas there, human resources, person, production, purchasing, sales. And I can expand those and see all the tables in them, which, again, I just love how cool this is. I can just quickly focus on one schema at a time. I love it. I love data grip. I also love data grip because it connects to Couchbase too, which is very cool. Okay, so I've got that SQL Server there. Now over here in Couchbase, I've got a Couchbase server running locally here, just a cluster of size 1, which is fine for development. In production, you typically have a whole list of servers here that make up your cluster. But either way, for a developer, it's basically the same experience. I've got a bucket here called AdventureWorks JetBrains. There is nothing in it. The only scope and collection is default and default. This is kind of like the DBO in Couchbase speak. So it's just nothing there to begin with. So let's go ahead and run this program. Fingers crossed that this works. A lot of logging stuff being written to screen here, but we're copying over all the structure and data from SQL Server AdventureWorks into Couchbase. So that's the collections and the users and the scopes. Now it's copying over the indexes. As I said, this is a place where it definitely use some improvement. But it's going to just take a sample of indexes. There are 100 and some indexes in AdventureWorks. We're only going to copy over 5 for the sake of a demo, and then it'll start copying over the data. So let's just go over here and look while it's doing that. We can see we've now got all 5 of those schemas converted into scopes along with default. And we've got inside of person, we've got all these different collections in there as well. And it's going to start copying data over. It's probably doing that right now, right? Yep, copying data over right now. So it's going to take a minute or 2 to do that. But what I've also done is, just by that conversion, we're just converting the data itself over. We still have to think about how we're going to access that data. So what I've done is I've created in the same GitHub repository, I've got 2 sample projects over here that are both using Web API. One uses SQL Server and one uses Couchbase. So I'm going to go look over here at SQL Server and Person Controller. And so Person Controller, this is just a handful of endpoints to show off, basic ways we'd interact with SQL Server. So I'm using Entity Framework for most of this, but Dapper would be fine too. It's just the same general principle here. So this endpoint gets a list of all the persons, but it gets it in paged. So I want, say, page 0, page 1, page 2, etc. So it's going to use the Entity Framework here on this person's entity to order them by last name and do a skip take to do a page. I just want the ID, first and last name, and then put that to a list. All right. Easy enough. And I also want to show over here the Couchbase version of that. This is just kind of a handy way to, again, kind of a translation, like a phrase book, to see how would I do that same thing in Couchbase. So here's the get persons page async. Now, Couchbase doesn't have Entity Framework provider, at least not yet. So I'm just going to use some raw SQL here. There is a library called Link to Couchbase. So if you want to use Link, you can use that here instead, but it's not Entity Framework provider. It's just a link provider for now. But here's the SQL. It's very similar to what you'd see generated by Entity Framework. Just a select and a from, and we've got a limit offset for paging, order by last name. It's all happening there. And again, to the list async. Okay, so I think we're probably done at this point. So the data is over. So we'll go ahead and let's just run the SQL Server example real quick here. Start new instance, open this in the browser. Hopefully, okay. And I've just got Swagger built in here so we can navigate the endpoints. So here's the endpoint I talked about. So let's start with page 0. Why not execute that? And what's happening here? Value cannot be null. What? What are we doing? Did I break something already? I just tried this before. I swear I did. Default connection. That's right, isn't it? Default connection. AdventureWorks. What did I do? Oh gosh. Let me see. Try this again. I don't know what's going on here. Debug, start new instance. I do have SQL Server running, right? I'm pretty sure I do. Oh, I know it. No, this should work. SQL Server, startup, yeah. Page number 0. And I'm getting it. Value cannot be no connection string. Why isn't it giving me a connection string here? There's a question about store procedures. I see your question. I will definitely get to that here. I'm going to spend just a few more seconds trying to figure out why this isn't working. AdventureWorks context, default connection. App JSON, database AdventureWorks. It's localhost, right? Yeah, there it is. I saw it here in DataGrip too. That's frustrating. Okay. Always with the demos, I swear. right. Sorry to debugging live here, everybody. But this is the kind of thing that, like I said, reality is always messier than marketing makes it out to be. Why isn't this connecting to SQL Server? If anyone sees the issue, shout it out. Start up. I swear I did this. This configuration being loaded, LOL IIS reset. Oh, that might be a good idea. Except I'm not using IIS. I'm using just .NET there. I'm pretty sure. Configuration, I don't see why it wouldn't be loaded. Startup. Why wouldn't it be loaded? This is probably the sort of thing where I was messing with it and I accidentally copied and pasted something. I don't know. Just set a breakpoint here and see what happens. Okay, so configuration, get connection string, default connection. What does that do? Media window. I can't type. There we go. It's not getting the app settings JSON file. Why isn't it getting that? So it's not loading. App settings on development. No, I don't think so. And like I said, this was working earlier when I was practicing and trying this out. Oh, is this some weird JSON something? Here, let me just do a quick check of see if I made a typo somewhere. You see any problems with this JSON? That might cause it to not load. Copy paste connection string just for this demo. All right. That's good thinking. Ah. Okay, and use SQL Server and another one. Okay. All right, we'll try it again. This is work. We're going to move on. It's just remove the UTF BOM. I don't know what BOM is. It's another one of those acronyms. Okay, we'll try it here. Come on, fingers crossed. Page 0 and... Okay, well, it's working. I don't know what the heck happened there, but I must have screwed something up when I was practicing. But there you go. There's the results. There's one page of persons. So again, Saeed and Catherine and Kim, all there. I don't know why Kim's in there twice. That's curious. But anyway, that's the results we're looking for. I could go ahead and then take one of these IDs and drill into a specific person, another endpoint, and try it out, and I'll get Saeed there. Right order mark. Okay, I'll look into that. Thank you very much for those. But I think we'll power on through the demo here. And so then I've got the Couchbase version of it, which I'll go ahead and run that. Now this won't return exactly the same data necessarily because I only copied a sample of the data over. I made a cleanup before. It's very possible I did that. So it's not going to return exactly the same data, but it'll be similar, like sample of the data, because I don't want you to sit here for 30 minutes watching data get copied over. So here's the Couchbase version, entering the same page number 0, and I even made a note to myself about this, and I didn't do it. So there are some indexes again because I didn't want to copy all the indexes over. I made a copy of these indexes that I should have. So I'll just go ahead and do this real quick here. AdventureWorks 2016, it's AdventureWorks JetBrains. This is really exciting, I'm sure, watching indexes getting created. Okay, there we go. Now we'll try it. This is the ASP.NET version using Couchbase. Debug, start new instance. So this would work just fine if I let it sit and run all the indexes. Like I said earlier, it's only running 5 of them because we only have so much time today. So I'm just creating one manually. All right, there we go. Same sort of results. Oh gosh. So here, remember that pipelines I was talking about? It's actually working here. So I'm mangling the data as I copied it over. I forgot to take that part out apparently too. I wonder if I accidentally just jumped to a fork or something. And that's why all these problems are happening, right? So if we go back to my program here, yeah. So I've got this example pipeline that scrambles sensitive data, and it happens to be the first name and last name of person. So that's why it's all scrambled looking over here. Normally this would say, you know, Saeed or whatever it was, the correct names. So this demo didn't go so great, but get the general idea there. All right. So that's what I wanted to show, and you can dive into all this code's out there in the GitHub repo. So let's hop back over to the slides, and a few more things I want to cover. And then you can send your questions in. So what can't be automated, at least not yet? So there's a question about Sprox in there. Also, you know, it's kind of implied, what about views? What about triggers? What about functions? So there are some equivalents to these things in NoSQL databases like Couchbase. Typically, Couchbase or other NoSQL databases have something called views or MapReduce views or something along those lines. That's the closest analog to a SQL Server view, like a materialized view. Those things are a little less flexible because they're typically written using JavaScript and not a language like SQL that it can do joins and things like that. So, but it's the closest analog. Those are kind of on their way out, MapReduce views, because of, you know, some of the performance implications of it, scaling implications, and just the limitations in what you can actually do with the MapReduce functions. Couchbase has something called UDFs, user-defined functions. So that's a direct analog to a SQL Server user-defined function. And you can also use that if you have a stored procedure that's like a read-only select stored procedure. That would be a good substitute for that. Functions as well, user-defined functions, I mentioned that. There is a service called Couchbase Eventing, which is a close analog to triggers, not exactly the same thing, but that allows you to write some business logic into your database if you want to keep it close to the data. Those can respond to mutation events like create, update, delete, and so those can be used in lieu of Sprox or triggers in some situations. I will say that among developers who interact with SQL Server, it's been my experience, this is back to the Darmok and Jalad, that stored procedures and Sprox and triggers can be very controversial. There's a spectrum out there of never ever use them, and there's people out there who are like, you got to use Sprox for every single time you interact with the database, right? So depending on who you're talking to, the lack of Sprox here, this may be a good thing for you. I don't know. Depends on where you fall in that spectrum. The other thing I'd mention on the migrating queries over, there is again there's no foreign key or unique constraints. You can have something like a foreign key to represent joins and relationships, but there's no constraint for it. There are some workarounds and alternatives, and one of the things that NoSQL has been adding recently that you may not be aware of is ACID transactions. So you can actually have a transaction that modifies multiple documents. And the other thing I want to mention here is that with SQL Server, the only way to interact with SQL Server is through SQL. Whereas with a NoSQL database like Couchbase, you can actually do a key value lookup, which I just kind of skipped this over in the demo because we're having some problems there. But if we're just selecting, say, one piece of data at a time, one row of data at a time, or one entity at a time, we might want to switch that to use the key value API instead of involving a SQL Server parser, indexer, and engine. So that is something else you should consider. That might give you better performance in the long run, is to use that. Should I automate? should I go through this process? And if you're interested in going to NoSQL because of some of the benefits, this is kind of the decision you have to make. And this is why a tool like this is going to be helpful for you to get a head start when you're doing proof of concept or evaluation. Is the traditional approach has been just rewrite everything. Just throw out the database that you had before and rewrite your application, and throw out the application with it and rewrite your application to use a new database. And that is going to be a really high effort project, a really high risk project, and probably expensive, but it will give you the most benefits out of the new database, is rewriting it from the ground up. But I think, and this is something that Couchbase has been leaning towards, is, that's all well and good. We're happy to do those and help you with those. But there's also a class out there of developers and applications and use cases where let's just start with low effort and low risk. And we'll just do, like I said, a lift and shift of the data from a relational database into Couchbase. Just host it with as few as changes as we can get away with, and see if that's going to give us the performance benefits, the flexibility benefits, scaling benefits that we want. And then we can start to optimize that. And we can start to combine those different tables into one entity. So in my example, I have in AdventureWorks, you have a person table and you have an email addresses table. And they're separate, right? Because I can have more than one email address. I may want to consolidate those and just have email addresses be an array inside of my person document. And that's going to save us some joins. It's going to save us ACID transactions and that kind of thing. So we can optimize that as we need to and refactor as we need to hit our performance goals. And we can keep going up that chain. So these are all valid approaches. It really just depends on what your goals are, how much time do you have, how much effort do you want to put into this, how much risk do you want to take, that sort of thing. I will say that those sample applications that I was just struggling with, I actually decided to do some load testing on them, because I wanted to see, after I converted from SQL Server to Couchbase, I wanted to do a sanity test. So this is like a back of the envelope sanity checking load test. It's not a rigorous benchmark. Don't take this as gospel. This is the performance difference. So I ran some load testing on both of them. It looks like it's about 250 clients over a minute, roughly speaking. And this is the SQL Server load test, so ASP.NET plus SQL Server. And I'm just testing the endpoint that uses paging. So just getting one page from the person table in this case. And there we go. So average response, 76 milliseconds. That's pretty good. That's pretty good. I ran the same test on Couchbase. Again, same endpoint. And this is the level 5 conversion. So I didn't do anything with the data modeling changes. I just copied the data over directly, as I showed you in the slides here. And going up to level 4 takes some more human thought and work. But just for the sake of evaluating this and sanity checking this, let's put it through a load test. So same load test here, 250 clients over 1 minute. Average response time about the same, 70 milliseconds. Slightly better, but about the same. So this is a test that's being run on my local machine. It may not reflect reality that well, but it is at least a sanity check. So this is kind of the at worst. We have the same performance, the same latency, but we've gained all those other things, scalability and high availability and flexibility. I would expect this load test, as we have more clients for Couchbase, a production level Couchbase cluster, to do better than SQL Server. I would expect that to happen. So we've gained those things when we're actually going up to scale and going into production. All right, so let's wrap up here and make sure to throw those questions in there, and I will answer them as I see them. Just to wrap up, though, I think NoSQL is becoming a better fit for more and more use cases. We can stop throwing all those shapes into the same square box of relational and start looking at NoSQL to answer some of those use cases, while retaining those core benefits I keep harping about: scalability, high availability, and performance. My approach to conversion is not a novel one, as I have come to learn. There's another project out there called Couchgress, which aims to do almost the identical thing, going from Postgres to Couchbase. So scopes and collections mapping to Postgres tables and schemas. And there's another effort actually by someone else at Couchbase, unbeknownst to me, was doing the same approach with MySQL. He was creating his scripts in Python there. So if you're interested in those efforts, check out those there. There's some links there for you. One other effort I want to mention, and this is from a company called Molo17. I believe they're based in Italy. They make a tool called GlueSync, and this is a production-grade commercial tool that can actually do a live synchronization between Couchbase and SQL Server and vice versa, and also Oracle for that matter. So this is like a production, unlike my sort of experiment. This is a production-level commercial solution that can help you do this. And they've got a bunch of customers that are doing this very thing to kind of take advantage of legacy SQL Server and some of the cool stuff they can do with Couchbase, and without ditching one or the other. If you want to try out this tool, if you have ideas for it, if you have criticisms, or hey, have you tried this, or any sort of questions or feedback, I love that stuff. Go ahead and submit an issue, even if it's just suggestion or feedback, and you're just dropping it off and leaving, and don't ever plan to come back in a while. I really like real world feedback and ideas to improve this project, this experiment. And of course, pull requests are welcome too, if you're interested in doing that sort of thing. If you have anything else you want to talk about with Couchbase, any questions or problems or comments, you can email me. There's matthew.groves@Couchbase, twitter.com/mgroves. You can find me on LinkedIn as well. This is the cartoon that more represents what I'm looking like post 2020, kind of grizzled and sort of like a world weary, I guess. not smiling as big, but that's it. That's the application. If you have any other questions, throw them in the chat there. I'm happy to discuss it further with you. I do want to say thank you to all the JetBrains staff for having me here at .NET Days. I really appreciate it.
Yeah, we were really happy to have you. I mean, that was a really cool talk. I know when folks start to go from a relational database to NoSQL, the thing that catches people up the most is probably document modeling. Do you have any tips for people out there? You talked about going from level 5 to level 4 migrations. Yeah. What tips do you have for folks starting out? Yeah, I mean, I've actually just finished a presentation on this recently, because you're absolutely right. JSON data modeling is something that's very crucial. And so going from level 5 to level 4 is where you start to think about your entities. So as I mentioned, the person and email address, those are two different tables in relational. Does it make sense to combine those into one entity? Because with JSON, you can now have more complex nested structures, sub-documents, arrays of documents, etc. So you basically you think of an entity diagram, like entity framework type of diagram, and start looking at that and drawing boxes and say, well, what if I draw a box around these 3 tables? If you're familiar with domain-driven design, the Blue Book, the idea of aggregate root might be a place you can go and start thinking about what are my aggregate roots, and maybe those should be the document models. And in fact, I think a long time ago, Martin Fowler, when he was first talking about NoSQL, he liked the name aggregate-oriented database better than document database, and I agree with him, but it hasn't really caught on as a name. Yeah, it's a bit of a tongue twister, so I can see why people went to document database or NoSQL database. Aggregate object database might be difficult, especially in meetings with your team members. So, Rachel, do you have any questions? Matthew's been pretty good about answering questions.
Yeah, I didn't see any that he didn't really get to answer. But I got to say, .NET folks, I'm glad he's out doing this talk, because especially the part in the beginning with that little quick table of, if you had this in an RDBMS, here's the rough equivalent in your document database, because it's more about shifting your mindset to think about working with data in a different way, and that way is not relational. And as we know, sometimes you can get set in a mindset, and then you are trying to fit that square peg in the round hole, and then you're crying like that girl in the video, right? This happens every time, and I see it time and time again. going from one paradigm of programming to another, right? Like OOP to functional even, or, RDBMS to document and all of these things. So it's really good that we have these tools and folks out there creating content to help with those shifts in your thinking.
So actually a good question just came in. Is it okay to duplicate your data? Because I know that's from Rachel talking about paradigm shifts. Duplicated data in SQL is normally a no-no. But what is it like in a NoSQL database?
Yeah, so it's actually kind of interesting. A year or two back, I went and read E.F. Codd's original white paper on the invention of relational databases. I highly, that's a humble brag, I guess. But anyway, he invented relational databases as we know them today. And one of his comments in there was, I'm going to paraphrase here. Basically, I'm optimizing for disk space because it's so expensive right now in the 1970s. But he saw a future where, if disk space wasn't so expensive and performance is more important, duplicating data would be totally fine. So even way back then, he foresaw that could be the case. Now, I will say, there are some NoSQL databases where duplicating data is necessary. If you're doing a wide column type of database, Cassandra type of database, you kind of have to do that because there's no indexing, there's no joining. A document database like this that has a join feature and has ACID transactions, that's less of a problem unless, again, it's going to help you meet your performance requirements, right? So you can still have your data be somewhat normalized in a database like Couchbase if that's what you want. But if performance is a premium, then you might want to start thinking about, all right, how do we copy this data over and keep it in sync so that we can improve performance and keep our data, data integrity.
Yeah, I mean, I think you pointed out in your talk, definitely with Couchbase, just having SQL-like syntax for queries makes that leap just so much easier. And while you should make a mental paradigm shift, the syntax really lends itself to kind of ease into that shift rather than jumping out of a plane with no parachute, right? So it's pretty cool stuff. The other thing I wanted to ask, you didn't really hint at it, but what features does Couchbase have that maybe SQL Server doesn't have or maybe doesn't do as well?
Yeah. So some of the things about Couchbase that I didn't really cover, because this session was all about how do I put my relational data in NoSQL, right? But Couchbase has some features in it that kind of lend themselves to other types of applications. So, for instance, we have a full mobile stack. So the last speaker was talking about a case where you might want to cache your data locally in local storage or whatever. Couchbase, there's a Couchbase Lite, which is a database you can deploy to your Android, your iOS, even your Java desktop apps that can give you an offline database experience. So you can read and write to that data. If you don't have any connection, let's say you're out at the curb, just out of the range of your restaurant's Wi-Fi, and you're fulfilling a pickup order or something, you can still read and write to your database locally on your portable device. And when you get back into the building, it's going to sync up automatically to your data. So that's a great one that Couchbase has, and that's actually what a lot of people using GlueSync are doing. They're using that to sync data from mobile devices to Couchbase to SQL Server, and to integrate with the rest of their ecosystem. Couchbase has a full text search engine built in, so that's really nice to for things like catalog searching and even geospatial searching. If I want to identify a polygon and find all the restaurants within that polygon on a map, I can go and do that with Couchbase. Analytics is built into Couchbase as well. So if you're concerned about reporting in NoSQL, I have a whole other session on that. If you're concerned, well, this NoSQL stuff's great, but what about all my reports and my BI? Well, there's a feature there for that too. Yeah, I can talk about it all day, but those are some of the big ones, I guess, that Couchbase offers.
Yeah. Well, I don't really necessarily see any more questions. Matthew, thank you so much for this talk. I think it was an awesome talk. Don't worry, the demo gods always get somebody. I didn't think it was that big a deal. It was a great talk regardless. So thank you again for your time. Thank you, Couchbase, for lending us Matthew for the day. So thank you, and we'll see you later.
Thanks, everyone.
Thanks.
Yep. So Rachel, that was the end
That's
of
it.
day one. Yeah, that's it.
We're at the 50% mark. Just have to do this tomorrow.
I'm curious to see if anybody in chat actually stayed all 8 hours and 51 minutes. I wonder if there is someone
Hardcore. Anybody out there stayed the whole time?
Oh man, but yeah, it was a great day. Whether you stayed for one talk or all talks, every single one's great. They will be, they are recorded. Every single talk will be on our JetBrains channel, so make sure to like and subscribe, and you'll see those videos as they're processed and pushed out.
Yeah, look at this. Several people here. We have some awesome, knowledge-hungry people here. So
yeah, woo.
It's awesome. Man. Yes, if you couldn't, it's no problem because again, they're recorded, so we're good.
So again, subscribe, like our channel, and hopefully we'll see you tomorrow. Yep. So have a good night. Good day.
Night.
Bye, everybody.